being able to FaceTime your residents and your family and friends at home on Earth, whenever you like, with a snap of a finger. Number 2, being able to track your health data. And number 3, using IoT, Internet of Things, to have GPS systems located in all the main parts of our settlement, whether that's the restaurant, the theater, etc. So whenever you enter one of these parts, it actually tracks that you've entered that part and asks you for feedback. Using that feedback, we can understand how we're going to reconfigure the settlement. So that's connection, safety, and being able to have constant improvements. Next slide.
Next, as part of our safety features, we're having rapid evacuation plans in case of emergencies. So our GPS system, or more locating abilities built into the watches for each resident, will be able to point out safety breaches as shown in that watch diagram there, which will have, the safety breach, so the flashing of the colored and corresponding alarm sound. So it's our blue and our red, our purple and red, and the information and announcements. And within our pathways in our courtyard area, there will be LED lights, which will guide 2 routes in case of evacuation. During evacuation, 2 routes, there are manhole covers in the pathways, which when opened up will have something akin to fireman poles, which will lead down into our where the shuttles are located, so that those can be able to exit opposite the direction of the blimp flying to avoid crashes.
And when it comes to reconfiguration, we've taken this very, very seriously. As you saw from the devices I presented just a couple slides earlier, we're taking the data and the feedback tracked from those devices to understand how we need to reconfigure the settlement. We have this animation over here to show how using an electromagnetic railway system with a magnet subcontracted from the company Magnetic Propulsion Company, we're able to actually use those magnets and build a railway system of it. And by changing the charge of these magnets to flow the houses as we wish, we're able to actually accomplish a settlement that can reconfigure based on the citizens' desires. Now you might be wondering, I'm sure a lot of people have different desires in the settlement. So how are we going to figure out which desires to go through? We're using a special algorithm in machine learning, specifically reinforcement learning, called PPO. This stands for proximal proximity algorithm. And how it works is it essentially takes in all this information and puts this agent inside a scene just like this one. Then we have a reward function. This reward function is essentially telling the model what is the most ideal situation for how the settlement is going to be organized. And once we have that and taken the data from all these different people, we use machine learning to create these patterns and figure out what next experiment to run. As a settlement that cares about the mental toll of people and how people can often get bored staying in the same place over and over again, we want to make sure that we're changing based on people's desires as a combined settlement. And also, we've done a lot of research and a lot of details into spacesuits that we're going to have in the settlement as well, which you're able to read on your devices on your own. And these are all the materials that we're going to be using for this.
All right, moving back into critical infrastructure. So we have 2 ways we're providing food primarily: aquaponics and hydroponics. What are aquaponics? It's basically a cycle in which the waste of fish is used to provide nutrients for the food. So it's renewable and it's sustainable. In our settlement, we have used 5 aquaponic chambers, as you can see, each with 8 openings in which we will be producing many veggies, many plants. Another benefit of this is we're using it for a recreational activity, which will not only provide interest for our visitors, but also it will increase our revenue. What we're doing is we're allowing them to fish in this settlement. Next slide, please. All right, this is another way we're producing fertilizers, essentially. So the BSF is a black soldier fly. We're going to take its larvae and we are going to mill them. What this does is it provides us a powder. Now this powder can be used as a fertilizer and it can be used as a nutrient powder, you could say, to be consumed by humans. Then this powder is known as frass, and this frass can be used with the Venus regolith to produce hard leafy greens and other things along with it. Next slide, please. All right, this is just the general food estimation diagram. So for our entire food production, we will be needing 1,800 meter squares of base area. And we've calculated the initial occupancy to be around 1/5. And that's why we've put those figures up there. Secondly, we will also be producing non-dairy milk and artificial meat. The artificial meat is 3D printed, and the non-dairy milk is produced from oats, soybeans, and almonds. Next, please. All right, so after this, I will be talking about the waste and water pipelines. This is just an overall layout of where they will be placed. This is the community layout as you saw by the human factors department. Next slide, please. All right, so liquid waste management. This is waste that comes from homes. This is waste that can also come from factories. How are we going to get rid of this? This is a very commonly used system. We're going to sediment it, then we'll filtrate it, then reverse osmosis, ultraviolet sterilization. What this does, it removes germs and it makes sure the water is pure. For solid waste, there's two things we need to take care about. First, organic waste. Secondly, inorganic waste. Inorganic waste can simply be ejected onto the Venusian surface, and organic waste will go through a lengthy process to eventually produce syngas, heat, and slag. Syngas can be used in other chemical reactions that might be going on in the industries, while the heat and slag, heat specifically, can be used for thermal conductivity. Next, please. All right, moving on to our power systems. Our primary power systems are two nuclear reactors. Yes, you may be thinking it's unsafe, but what really are the chances of a nuclear reactor going wrong? To be precise, 1 in a billion. Considering our settlement is on Venus, we can't really do much. Solar would be unfeasible because, well, the clouds, they don't really allow much. And wind would be unfeasible because it's a floating settlement. So we have then used molten salt fission reactors, which have high efficiency. Yes, they do produce a lot of heat, but we have taken care of that. Next slide, please. All right, so for our secondary power source, we're basically using our backup and storage sources. Lithium-ion batteries will be our primary storage system, and solid oxide regenerative fuel cells will be our secondary storage system. Lithium-ion batteries are easily transportable, they're feasible, and they have extremely high efficiency rates, even as high as 80%. Next, please. All right, so this is thermal control. Because so much heat will be being produced, we need a way to reject it, we need a way to eject it. How will we do that? We have capillaries. Capillaries, what they will essentially do is they are filled with propylene glycol. Propylene glycol, it has a very high specific heat capacity. It can transport heat with it. These pipes will be laid out in the industrial floor, beneath the industrial floor, and will eject heat as it passes through it. Next, please. All right, this is the waste heat rejection system for the nuclear reactor specifically. So we have radiators here. We've tried to maximize our surface area with this. We've used copper alloys for its high melting and boiling points, and once again, propylene glycol because it has a high specific heat capacity. These radiators will help eject heat. This is a front view of our settlement. From here, the heat will go out, it will pass through the radiators and go back in. Next slide, please. All right, thermal control residential. This is fairly straightforward. We're using almost traditional ACs, air conditioners. The only twist is that by altitude, at a lower altitude, your temperature is extremely high. And at a higher altitude, your temperature is extremely low. So we've implemented systems from which you can switch around the AC. So it can heat and it can cool. Next, please. All right, so because our settlement is focused around efficiency, reliability, and all sorts of things, we've provided a table which ensures all those things. It ensures that in case of any failure, we have backup plans. So the aquaponics chamber, which would be an extremely severe issue, we have a plan to get around that. Next slide, please. Similarly, because we have so many different infrastructure systems, so many systems, we have to take care of them regularly. Over here, we have the frequency of how much they need to be taken care of and what will happen when we do so. Next slide, please. All right, communication. So, of course, since we're in a settlement, we do have to have a way to communicate. We have three types. Internal communication, which is happening within the settlement for the humans. inter-settlement communication and surface settlement communication. For the primary internal communication, we're using the wireless mesh network, which will make use of multiple nodes at a time, so that even if one is damaged, the entire system is still working and it's easily repairable. The secondary is Li-Fi. For the inter-settlement primary, we're using the deep space network as it's already fairly established. And for the secondary system, we're using satellites subcontracted from OrbitLink. Over here, you can see 4 satellites in orbit of Earth, 4 satellites in orbit of Venus, and we will use them to communicate. For the surface settlement, we're using ultra-high frequency or S-band frequency waves, because any other frequency would then not be able to penetrate the Venus atmosphere fully. Next slide, please. All right, these are just recovery pathways. As mentioned previously, we do have plans in case anything goes wrong. We do have a way to get around that. If there is an issue with the electricity, even in the case that the nuclear reactor does get heated up, we have various ways to take care of that, similar with any thermal issues and atmosphere issues, as you can see. All right, next slide.
So you might be wondering, how are we going to get these raw materials from the surface of Venus to the settlement? So we're going to be using our subcontractor magnetic propulsion again, and using a circular magnetic accelerator and launch pipe to propel these pods straight up to our settlement. And then we will also have a magnetic decelerator on our settlement to therefore slow it down. Next slide, please. So upon processing and refining these materials, what are we going to do with it? So we plan on using this balloon-assisted rocket launch. So BAL. This essentially uses a weather balloon to launch our exported raw materials up into LVO and therefore ready to export to other settlements.
So we have here the monthly cost and revenue of production. On the left side, we have all the materials that we are going to produce. You can see that nickel and titanium are the biggest ones, because these are the materials that has the most value. The total revenue could be almost $2 billion. And on the right side, we have all the operation costs. And then in the right corner, the total profits that goes with $716 million. Next slide, please. Then finally, we have the main and general cost table, which is divided into 5 phases. The first 2 ones refers to construction. We also use several subcontractors. The third one refers to transportation and launches, and the 2 final ones to assembly. Then in the right corner, we also have another graph that shows the Venus settlement export growth over 4 years, because we plan, once we have the settlement built, to export and growth over only 4 years. This first 2 points, it's once the settlement is already built, and then over the years we will be scaling and growing. And this entire graph shows the dynamic production after fog is research, and more or less the profits of the entire settlement after 51 years is almost $80 billion.
And now we've got the lovely compliance matrix, everyone's favorite part. Look at all that green on there. So the green basically represents areas where our functional requirements have met our operational concepts. I mean, wow, look at that. And then here the slide numbers also indicate where our functional requirements have been met. But just to sum up our settlement a little bit, we've told you about our novel technologies, our design process, our structure, our inspiration. But that's not what makes Vulcan truly special, right? What makes our settlement special is its convenience. And we managed to do this by leveraging 3 things. Firstly, our location. We told you about our location. This makes it really, really easy for us to export things, even if it does come at the cost of like a slightly slower IOC to FOC. Secondly, our novel technologies. They are simply revolutionary. I don't know how many novel technologies were in here, because honestly, by the end of it, we lost count. We couldn't just pick 2 because there were so many. And then lastly, I think it's our ability to have 150 extra subcontractor workers working on the settlement at the same time. This was sort of slightly brushed over earlier, but we have 450, Foundation Society workers. But we also have space for up to 150 subcontractor workers, which means that at any time, if this Foundation Society wants, they can expand their settlement. Vulcan will be the most convenient, reliable, and useful method of transporting natural commodities to the inner solar system, right? The only question is, out of adversity comes convenience. Foundation Society, do you want to be a part of this?
All right, we'd like to invite the rest of the team up. Dugaldine, please come up for questions with the judges. Kelsey, as soon as they get set, 10-minute timer, please. Yeah. I don't, because I couldn't see. All right, please just come all the way up, guys. Come all the way up. You can kind of get behind each other. We're going to go ahead and start the timer. I unfortunately could not see the page numbers. You guys had them. They were beautiful. They were large. They were right behind my speakers for me. So I am looking for the radiator slide. I'm going to go ahead and go with my question. Wow, who has the clicker? Very good. Jack is looking for the slide for me. It was a picture of, no, that one's fine. Let's go to 34. I don't think that was it, but there was actually a picture that was it. Let's go to 35. I have a question about the radiator here. So you are generating heat from your reactors, and the heat is going into the radiator, which is radiating this heat to the outside. Is that correct?
Yeah, that's correct. It's transferring it to the atmosphere of Venus via conduction and convection with the atmosphere.
Can you tell me what the temperature is on the outside of the radiator where this is conducting to?
The ambient temperature of the air at the highest altitude we cruise at 65 kilometers is negative 23 Celsius. We estimate like a radiator equilibrium temperature of 300 Celsius.
Beautiful. Thank you so much.
Let's go to page 14. I think it's 14. Okay, so I have a note here. Okay, on the bottom left, you've got carbon monoxide outputs. We all know that's a toxic molecule. How do you guys contain that and prevent it from escaping into your atmosphere? How do you treat that as a hazard? How do you control that hazard?
Yeah, this was a huge problem when we were realizing that we were wanting to use a plasma reactor, basically. Our main way of containing is making sure we have our super sealed containers. Basically, just normal scientific jars that you would attach to a normal cold trap would be enlarged and stopping the reaction over time to like replace when it is full. So it'd be a huge safety concern, of course. But with staff that are going to be the ones replacing it, that are highly specialized, we are hoping there's going to be no leaks. Our main reason why we also want to keep this carbon monoxide is for later production. For example, we can combine it with hydrogen to create CH4, which is methane, which we can use for liquid gas.
Okay, yeah, using the carbon monoxide is fine as long as you control it. Perhaps you could address that in a little bit more detail if and when you might win the proposal. We're going to go next. Hold on, no, we're done with that question.
If we can look at slide 30. Go one back. Slide 30. Yeah, there we go. So just a quick question is, how are you getting your sewer to, what is that location? I guess to the bottom left-hand corner. Is that where the plant is, or what is that?
So basically over there in the bottom left corner, we have our waste treatment facility. And so that's why we've placed these pumps. What the pumps do is that for the sewer pipes, they pump it towards the facility so that any backlog, any backflow, sort of like veins in our bodies that open and close valves to push the blood forward. In the same way, these pumps will pump the waste towards the treatment facility while also pumping and distributing water throughout the residential and commercial areas.
Okay, so the plant is located up high?
No, it's on the surface along with the rest of the buildings.
Okay, so it's all parallel.
Yeah.
Dulan, thank you so much for your presentation. Sticking on slide 30, you mentioned in a previous slide that you had a really cool system of being able to reconfigure the entire internal structure on this electromagnetic rail system using machine learning to optimize for the most compromising layout based on everyone's wants and needs. Really cool idea. But you've got these water lines that are fixed, from my understanding. How does the waste and water lines move when you've got houses that have plumbing in them that also move?
The waste and water lines are fixed on the surface. The tracks that we've laid, the simulation of the railway tracks, they will be a bit like levitated off of the surface. They won't exactly be levitating, but they will be like not directly connected to the surface. They will be a little bit heightened.
Okay, so my shower, my sink, my toilet, and all of those things, those interfaces to these fixed lines are going to not be connected, right? They're going to have to be disconnected when we levitate off. Is that correct?
Yeah. What she basically means is that the pipes that will be going up into the plumbing system, they will be easily detachable. Like they won't be sort of bolted on. You can easily remove, unlatch them, and they can be removed whenever the entire layout needs to be reconfigured.
Got it. For every single accommodation.
Huh?
For every single accommodation.
Yeah.
Okay, thank you.
All right, thank you so much for your presentation so far. Could we please go to slide 42? So obviously a very critical part of your design is going to be how you actually extract your resources and send them out, right? I'm really concerned with the design here because it's really hard for me to understand this. Can someone speak to the dimensions and also any contingencies and redundancies in this system? I see a giant balloon. What happens if something bad goes on? Can someone speak to that, please?
Essentially, the craft itself is slightly bigger than the size of a cask because it has space for an onboard computer that will be able to automate guidance for when it is in deep space travel, along with a small fuel tank filled with hydrogen for being able to exit the atmosphere. It has the balloon itself is filled with hydrogen, which will allow it to essentially rise up to around 65,000 kilometers in altitude. From there,
For the most part, what this is basically a transport system for the rocket launch, so that instead of us launching at where we are at our station, we're launching at the max height that we can get to. So we're using a weather balloon system design basically to transport a cask rocket that we make up to the highest height that we can possibly get it to for ease of access. It just makes the lowest thrust to weight design of our rocket so that we don't need to over design it and make it so that we are launching from a lower and higher pressure altitude.
Okay, I appreciate that. But any specifics on redundancies here? Any specifics on redundant systems in case something malfunctions?
Honestly, no. If we were completely honest, this was one of our most recent designs, which we didn't really have a lot of time to fledge out every redundancy.
Okay, and you'll get back to us, right?
Yes.
All right, can we go to slide 17, please? Looking at the atmospheric compositions, can you tell me what the pressure is inside of your settlement, and then what is the pressure inside of the overall kind of what are the different pressures in your different pressurized volumes?
Essentially, for the main settlement, it is just going to be very similar to Earth, 1 atmosphere. For the ballasts, they're going to be adjusted as time goes on so we can account for the extra weight for the settlement in its development.
Thanks.
That sort of addresses the question I had too. And so I'd like to clarify on slide 3, if you don't mind.
All right, Shane is going to prep you for, there we go. Do you want to talk or do you want Shane to do it?
If you could try all to come in front of the big screen, please. And if someone at the back could please turn the screen off so that we're not blinding people.
Presenters, please come back up. Judges, you have 5 minutes if you would like to take a quick break.
Okay, while the room is still a little bit empty and we're waiting for Dugaldine to get all settled in, I'd like to invite the speakers from Vulture Aviation to come up, get set up, and we'll get you all sorted. Him. Over here. So, yeah, well, should be asking me that question. I should be asking you guys that question.
Well, let's do sleepless nights, work for the hour.
You know that intro presentation I did?
Yeah.
Been sleeping time. So clearly that's not a secret recipe, right?
Follow Shane.
And just don't fall asleep. So Becca, over.
Yeah.
I assume. Yeah. Speak very well into the mic. You can pick it up. Take it out if you want. Remember, 20 minutes. 10 minutes questions. It's going to be a hard sell. Guys. Yourselves become them. Okay,
Oh, I have a laser. Oh. Yeah, I mean, I will be with the remote, so that you do it like this to me, and then. Yeah. So I won't.
Hey folks, I need everyone to get seated as quickly as possible so that we can get moving. Please get everybody seated as quickly as possible. We do have a lunch break built in after this. You will have some time to get up and move around. You'll have time to go grab something to eat. So please, everybody get seated so we can keep moving. Thank you so much.
Good morning. Let's focus.
That last one. So if you see me raise my hand, it's just because I need you to move the microphone a bit closer.
Okay, like
Like that. Eat the mic. Eat the mic. No, I'm not going to scream. I was going to raise my hand.
raise your hand. Where will you be? All right, guys.
All right, everybody, please be settled. Everybody get seated, please. Kelsey, are you ready to go? We are missing Jack. Shane, how are we on time? Ah, there he is. He's in orange. I just didn't turn around. All right. And go.
Oh, good morning. Dare to discover. Welcome to the dawn of a new chapter of resource exploration in Venus. Welcome, ladies and gentlemen, to Nubaron. Well, Nubaron in Latin means off the clouds, and there is exactly where the future begins. Our ship will be floating through the clouds of Venus with the most ambitious, efficient, and highly potential settlement ever designed beyond Earth. Remember, this is not just a settlement, this is a vision, and we are aligned with not only our vision, but your interests. So please get along.
All right, so Navarro is a floating settlement that lies 50 kilometers above the surface of Venus. To fulfill its objective, it is an efficient resource extraction station for 600 settlers. The following design prevailed over others. So to produce resources, 500 surface installments equally spaced deliver materials toward hubs. Navarro itself is essentially a floating airship that lies in the equilateral winds, circumnavigating the planet eternally, collecting resources from the drones that collect from the hubs as it passes. For the purpose of moving forward, externally exists 20 Flettner rotors, 10 on the top and 10 on the bottom, along with some side and rear thrusters. However, no settlement exists without an internal volume. Our settlement consists of all the required essentials for human functions on Venus: residential, agricultural, water, and energy, as well as the essentials for resource production, including extensive storage, refinement facilities, and command room, which consists maintenance. So based on the overall dimensions of the 800-meter long, 300-meter tall, and 300-meter wide, the chart represents our floor area based on the allocations. An external surface area of 80,800 square meters and a total volume of 33 million cubic meters. Our major systems such as water and air processing, cooling, and waste management are intertwined within the structure itself, going through the floors. Structures of the minor systems like the AI diagnostic feedback to detect minute changes are placed in the command center. We also have emergency evacuation systems with our escape pods, but to prevent emergencies in the first place, we have identified load-bearing areas as marked by the red image above, which is near the rotors with which produce force. Here we have a reinforced extra and added additional surveillance to watch for damage. So we have 4 systems of movement on our settlement. The first is the buoyant gas force. In the Venusian atmosphere, carbon dioxide serves as the main atmospheric gas. Since at equal pressures, oxygen and nitrogen have low density, this is essentially used like helium on Earth to help us stay afloat at our altitude. To move forward, we purposely chose to dive into the equator as there exists high-speed winds of 70 meters per second, which can utilize for both wind turbines and generate force. To do this, you can look at figure 4 with the Flettner rotors, and we have 10 on top that will be, we will have panels that will redirect the wind to make it spin to the right. And then for the bottom, we will have panels redirecting it to spin to the left in order to create a reliable transportation system. And our third and fourth system is a hydrogen liquid engine placed at the sides and rear of our settlement, and that will produce about 25 meganewtons. The back is used in case of emergency, and our side thrusts are to keep us in our path in case of possible wind changes in our navigation.
Any residue buildup of sulfuric acid on the exterior of the settlement will be removed by exterior maintenance pots, seen in figure S.7 up there. Any contamination of frequently entering and exiting objects will need to be sterilized to safeguard the people against exposure to irritants present on Venus. Done with the aid of the bot shown in figure S.8. They will primarily be stored in the docking station to conduct immediate cleaning and the nuclear reactor facility to help identify faults. These robots are connected to the command center with their cameras constantly monitoring nuclear reactors. These systems work to maintain the viability and livability of the settlement in a way that does not disrupt daily activities. In the case of an emergency, general maintenance bots seen in figure S.11 will be informed by command to travel to the emergency sites. These robots carry retractable arms that can be repurposed for different emergency situations, such as repairing hull breaches and fixing a range of potential issues, including agricultural, electrical, and purification. Logistical systems are designed such as they have a constant storage of a minimum of 2 weeks to sustain the population throughout maintenance. In severe events such as hull breaches, residents will be provided face masks to protect them from Venus's atmosphere and will be directed to escape pods, which will be discovered in human factors. Importantly, in the case of unstable buoyancy from the atmosphere or unpredicted weather patterns, thrusters perpendicular to the motion of a spacecraft supply forces that direct Nubarum back on course. Venus is corrosive, hot, windy, and irradiated. Lightweight materials are our #1 priority due to the reliance on weight for lift. Due to the very similar pressures from the interior and exterior, unlike interstellar travel, which have a pressure difference, there is less of a need for heavier elements, and instead, we present you these materials. For the whole, this includes the innovative Halostoy C276 basalt and metallic aerogels, such as titanium and steel. For the windows, we use aluminium oxynitride and silicon carbide. PFA coating and Hastoloy C276, which we predict will have a lower density as development continues, both have corrosion-resistant properties against the acidic Venus atmosphere. Thicker vacuum layers in the middle serve as insulation, while also allowing the system to be light. To prevent radiation, easily harvested basalt, which is low density, again to save weight, is used in the hull. For debris resistance, we use transparent aluminium oxynitride in the windows. Seeing here, we can see the materials are originally sourced from Earth, Moon, Venus, and the asteroids, and shall be replenished for mining on Venus. They will be shipped to Vulture condors for the orbit of Venus. To construct the vessel, the hull will be first built at an altitude of 400 kilometers in Venus orbit, where reduced gravity eases the transport. Construction will be carried out in disc pods, seen here, equipped with thrusters for maneuvering in zero gravity and solar panels to power tools. Once the hull is complete, nuclear reactors and airlocks will be installed, enabling energy production independent of solar power. Next, we install ports, refineries, thrusters, our Flettner rotors, turbines, mineral hubs, and transport robots. These surface-built systems allow immediate mineral refinement once in circumnavigation of Venus. A final coat of anti-corrosion PFA is applied before descending through sulfur clouds to the 50-kilometer altitude, using the rear engines to counter gravity until buoyancy from the breathable gases stabilizes at the equator, which is where the settlement will be located. Side thrusters align its direction, and after it's in circumnavigation, the system will be pressurized, and the disc robots finalize internal structures with life support systems to allow for humans to be transported on by condors. 400 people will be living in the settlement by 2087, with the addition of 200 more in 2092 and a further 200 more by 2099, reaching our maximum population.
Efficiency is our top priority, and venture. That's why for the gas extraction method, we have designed Venus atmosphere collection drones that are aimed to collect gas and sulfuric acid. How are we going to do this? To collect gas, we are having these drones descending from the bottom of the settlement up to 10 kilometers height from the actual Venus surface in order to collect the gas. Therefore, we need to wait to the route to be completed when the pressure within the tanks in the drones is the same as in the outside. Therefore, going back again to the own settlement for again recharge it, and also to get to the refinery process. Also, drones can be modified to collect sulfuric acid for later purposes from the atmosphere by modifying the interiors. That's why we need to collect, we need to have a coat of corrosive resistant Hastelloy C276 and internal systems with a larger compression chamber. At the same time, the flight path for the sulfuric acid drone would be above it instead of beneath it, since there's a higher concentration for it. So now regarding the Venusian gas refinery process, it is very simple. We need to take into account that nitrogen can be naturally found that way. So we just need an air filter system to separate nitrogen from CO2. And then CO2 would undergo a solid oxygen electrolysis, having as a result oxygen and carbon monoxide. Therefore, the oxygen and the nitrogen will later be cooled and compressed in airtight containers for transport to the docking storage in the own settlement or for later exportation. Now, regarding all the logistics regarding the 500 stationary mining sites, we have divided, so this is a top view of Venus. So we have divided Venus in 4 hubs. So we can have 4 hubs that are collecting 125 stationary mines each. How are we going to do that? In order to have constant rate for it, we need 7,500 drones that are going to be operating 24 hours in order to get the raw materials into the hubs in which all the refinery and the packaging would occur for later transportation to the own settlement. Each of the drones will have monitoring system that is going to be AI driven with a continuous checking status. Now, in order to get the extraction of the materials, we need to extract 317.2 kilograms a day, which means that these drones are going to be doing 12 routes per day, which I would get into more detail afterwards. And regarding the hubs, in the hubs, we will have the refinery and the packaging for later extraction. So how are we going to do this? So we are going to have 2 types of drones. The first ones are the ones that are going to go from the mining sites to the actual hub, which are the 7,500 ones that are going to be in constant movement every day. However, from the hubs to the actual settlement, we're having larger drones with a 187 cask capacity to afterwards transport that to the actual settlement for storage and exportation. So these are the 2 types of drones. As I said before, this one is the one in charge of basically moving all of the raw materials into the actual hub. And this is the larger one that is going to be operating whenever the settlement gets to the actual hub, then these ones will they would transport the already refined material to the actual settlement. So we go further than that, and we also consider the rest of materials that we can make profit for it. That's why we have 13 different refinery systems that consist of mechanical processing, also purification and solidification, which we can further get into detail. And this is the logistics behind all the different transportation until it gets to the actual settlement.
Okay, this is the Messenger of Venus, Hermes, an innovative single-stage to orbit rocket that exports up to 8 casks of processed resources such as metals and gases for our settlement to the inner solar system. To launch, it uses a mechanical arm located on the side of the settlement to hold the rocket, allowing the rocket to reach maximum velocity before releasing it, allowing the rocket to reach low Venus orbit. Here, to accelerate further from Venus, the hydrogen thrusters will need to be engaged again. And upon reaching its max speed, the hydrogen thrusters will disengage and allow the ion propulsion system at the back of the rocket to engage. This is because ion propulsion takes a long time to accelerate, but it is very fuel efficient, making them suitable for these long distances. An air braking system that consists of retractable flaps will be used together with the propulsion systems to better control the rocket in the atmosphere of Venus for docking. And most rockets will stay in Venus orbit for storage using these ion thrusters at the back to counteract orbital decay. However, 2 rockets at a time will be docked onto the settlement to be maintained and restocked for shipping. Maintenance in our settlement will be automatic using multiple types of infrastructure and robots as seen here. First, infrastructure will be embedded with nanomaterials that detect and repair microfractures by releasing nanocapsules filled with healing agents, for example, polymers and resins. Furthermore, nanobots will be used to detect and dislodge dust, and with AI scanning, drones are able to check for corrosion, detecting microfractures and repairing them. Now, if these drones are insufficient, specialized robots will be deployed with certain arms, equipped with certain tools for specific tasks to be carried out. Additionally, issues that can be predicted will be intervened, predicting system failures by running simulations and using historical data. In the worst case, though, we do have human override that can disengage any systems and handle the issues manually.
Now, although we don't need power to keep the ship up thanks to buoyancy, we will need power to complete our mission. So for this reason, we have our main power source, which will be 3 fission reactors. Each one has a 30-year lifespan, and we will be rotating throughout the 3 for extra safety measures. These will be able to cover most of our energy usage, but we still have backup and secondary options like wind propellers on the rear exterior of the ship, wind turbines again, power tiles, which we step on, and the kinetic energy turns into obviously electric energy for everyday appliances, and also the static gym bikes in the fitness center. We will be storing energy in molten salt tanks and lithium-ion batteries, and making sure there's enough in there to run all essential systems and start up a fission reactor in case that is ever needed. Now, these reactors and a lot of other equipment will need cooling, so we have settled on a liquid nitrogen cooling system. This works with circulating water from the hot facilities to our cooling system, and with this, we have changes in state of the liquid nitrogen absorbing heat and cooling the surrounding spaces and equipments. Now that we, please go back. Now that we understand what our system does, we're missing one critical part, and that's our nanophotonics. Our nanophotonics are heat vents that are made out of photonic crystals that use the next slide, please. Okay, so our beautiful vertical farming allows us to produce 20 to 30% more yields than our traditional soil productions. So here we're able to use 7 levels of vertical farming, but we're still missing something: meat. So the system that we use is called cell culture bioreactors and microbial protein from waste. During this process, we're able to produce a fast production of protein, and we start with our harvesting bots that send the processing and packages to our dry storage systems, which deliver it to our AI delivery system. So at Vulture Aviation, we believe in efficiency and in making the most of our resources. So we have developed a system to use the sulfur acid that is very abundantly present in the atmosphere around our settlement to produce water, breathable oxygen, whilst also treating our organic waste. So our main water source will be sulfuric acid electrolysis, and then we have multiple other backup choices too. Our waste processing system, we use 2 categories. For organic, we're going to it's going to come out as water, which is recycled and used into fertilized water. And then we're going to have carbon dioxide, which is recycled into oxygen. For our system, for the sulfuric acid that we're getting from our sulfuric acid chamber and organic matter, we're able to have more access to water, and the carbon dioxide is able to provide us more oxygen. So for our general AI runs the entire area for our maintenance. So it's able to have an overall control and emergency handling to ensure that our workers are able to be safe in the environments. The way that the systems communicate, the general AI sends signals to our swarm bots that go out and to the cautious areas and clear up the safe. During our emergency and our recovery, we're able to use stuff as wristband alerts to alert our citizens and zone seals.
So to maintain atmospherical conditions within our settlements, in the first few months during construction, we will be using a subcontractor to get the gases we need. But from then on out, we will be completely self-sufficient and independent. We will be bringing in air from the external atmosphere, separating from it nitrogen and carbon dioxide. The carbon dioxide then goes through our very own system called VORS, Venusian Oxygen Recovery System. This separates the oxygen from the carbon monoxide in carbon dioxide. So then we can use the oxygen and the nitrogen to keep the percentages in our atmosphere within the base at healthy and safe levels.
So in Vulture, we take good care of our employees. We're going to make the best possible ways to make them efficient, and we're going to give them the best quality of life. Here's how it's going to be structured. We have a living area and we have a working area. We want the living area to be as far away as possible from the engines to avoid noise and heat pollution. Here would be an example of how a living area would be. We're going to have 20 floors like this one that need to simulate such sort of a town, to make it interconnected houses with a lot of leisure spaces there, to make people connect, to make people be together and avoid that loneliness you may have in space. This would be the rooms. We're going to have 400 individual rooms and 200 double bedrooms. We're going to start off with 400 people there, and we're going to move up until 800 workers. To make the life there as more Earth-like as possible, we're going to try to incentive a light cycle phases for residentials. This is very important for humans to be able to know when it's time to sleep and when it's time to work and have your daylight. Here are some examples of green areas. We're also focusing in a lot on green areas. They are crucial for human beings and for their moods. That's why we're going to try to fulfill as many activities as possible in green areas. We want to do sports in green areas. We want to do arts crafts in green areas, and some also social activities in green areas. For our repurposing zones or activities, we're going to have a multi-purpose field, which is going to work for different sports not at the same time, but it's the same field for different sports. This works with a retractive system, sort of a belt, that can pull the different terrains up and downwards, depending on the demands and the interest of the people and what sports they want to play. Also, we're going to have some rooms that they're going to work for multi-purpose issues. They're very easy to change, and they can work for different activities such as arts and crafts, movies, dance, or board games. Lastly, it is hugely important to bear in mind some social norms. We're living 800 people, from 400 to 800 people are living in the same spaceship, and it's difficult to control that. After a lot of thinking, we thought that we're not going to be able to have kids allowed here because it is very complicated. It would not suit the kids, and their growing up wouldn't be as good as it would be on Earth, and it wouldn't suit also our mission statement, and it wouldn't be beneficial for a company. Imagine, regarding her mental health, imagine being stuck in a metal box up in space with the same people doing the same job for a long period of time. Your mental health would deteriorate very fast. That's why we're creating a method of incentives. It's a new coin, such of a currency that can only be used in the spacecraft. It can be gained not by doing your normal jobs, since these astronauts, they're having their salaries, but by fulfilling other activities such as community work, social activities, or maybe organizing a different thing. It can be very monotonous, and try to getting out of that line of monotony. You can also use these coins to get maybe better pleasures, or for example, a better pillow, a massage, something like that on board. We also developed a new method that is called the Custodia X. This is a wristband, which it works, it's very smart, and it has a lot of different purpose. First of all, it measures health of everyone on board. It measures itself and and their vitals. It also works for emergencies, since in case of any type of emergency, it will start beeping and it will say the cause of it. And lastly, it will also take into considerations the currency, the Nebo coin is the name of it. And lastly, the gender cultural diversity. We want a very cultural and diverse environment. That's why we have, except for the age restriction, we want to maintain a 40 to 60 gender balance, and also we want to maintain a cultural and age balance there.
Okay, so obviously, in addition to livability and comfort, we want to address the risks that are inherently with a settlement in Venus, right? So after careful consideration, we have implemented 6 ways that we can address these risks. So the first is the VORS process. This focuses on the operation of the drones in and out of our settlement. So with drones, this can obviously encounter sulfuric acid. We want to make sure that this is completely cleaned off before it enters the settlement. And while this is happening, the employees are required to wear protective equipment in order to cut off contact with the sulfuric acid in case of health risks. And then also with this, the distance from the reaction chambers during operation prevents risk from high temperatures. Okay. So then we have fission reactors, right? Obviously, how we get our energy, the chance of a fission reactor going off is very low, but never zero. So in order to counteract this, we have the fission reactors at the very bottom of our settlement. We require appropriate protection equipment for fission reactors, and since the nuclear reactors are on the bottom floor, in case of the meltdown, the hatches will drop, and then this reduces the risk of any nuclear meltdown affecting the settlement. Okay. All right. So laser broom. This is for sweeping the micro debris away to prevent damage from the hull. This includes live scanning for micro debris, and a laser camera redirects debris away from the settlement every 10 kilometers squared. All right. Custom spacesuits. These are subcontracted from Extreme Survival Technologies, and they are self-modified for Venusian atmosphere. So this includes sulfuric acid resistant PFA coating, and it is used in case of an emergency repair or an evacuation. So if automation cannot handle this, this will. It includes carabiners to attach to the railing around the hull so that the gravity will not affect it as much. Next one. All right, so weather radar. This is our Ares system. Obviously, acid rain is a big roadblock in drone navigation. We cannot risk sending out our drones in unsafe weather conditions. So, well, how do we plan to do this? So this is kind of like the Doppler system we use on Earth to predict weather, right? So the radio waves from here are sent to the acid rain clouds, and then from research that we've taken from the past few years from Venus and from Earth, we can observe the frequencies and then therefore predict the next weather patterns. The 3 radars will be spread out evenly along our path of travel on the equator, covering the surface. And this will allow us to follow and predict precipitation patterns, plan missions safely, and avoid unnecessary repairs and human endangerment. All right, lastly, we have our emergency evacuation pods, which relies on human. So these are modified vulture condors. There are 43 pods along our residential sector. These fit 20 people each. It's made out of alloy 20, and it's powered by preserved batteries. These include thrusters on the bottom and a helium balloon on the top. And then it takes around 45 to 2 minutes to reach from any given area, because the area is 200 by 200 meters.
Now, my teammates haven't explained the what and the how. I'm here to explain the why. First of all, revenue. We plan to make almost 600 billion in revenue, while only regarding operation costs, 41 billion in costs. So how will this scale? Well, we have the initial, the medium, and the full capacity, which will scale regarding employees, number of drones, and revenue. Now, we will not only bring money to your pockets, but we will also bring new technologies to to the market. For example, Ares, yes, the god of war of Greek mythology is working with Venus. If we can pull that off, imagine what we could do if you support us. Now, regarding the costs, this is assuming the worst case scenario. We are going for the most amount of materials with more than 1/5 of it could be of extra. Now, as you see, this is very vertical because you cannot build the 7th floor before you build the first one, but you can build the kitchen while you build the first one. So that's why our Gantt diagram is very vertical and very not very horizontal. Now, you asked us to calculate risk because with every investment there's risk, but our job was to learn how to mitigate using creativity and innovation. So we developed systems to mitigate this risk and break them down. But with every investment there's risk, but there's also opportunity, and we were able to identify opportunities that will have a high impact and extreme benefit. Now, I want you, Barbara, to picture yourself hugging Victoria with tears of joy running through your cheeks. Yes, if you want that to be a reality, if you want that tears of joy to be real, if you want that dopamine to be real, guess what? You need to trust us, because when you ask something to Vulture Aviation, we comply. Mr. President.
Well, to finish it off, thank you all. Thank you for us. Thank you for you for the opportunity. Thank you for our team for the amazing work. Thank you. And especially thank you to the CEOs, Alex, Rohan, and Will. Thank you for spending endless nights with us. So we are Vulture. Thank you very much. And
Thank you very much, Vulture Aviation. Thank you. You're going to go first, but I'm going to tell these guys what the plan is. No, because Nicole didn't get to ask. Brian has to do follow-up questions. Ty's going to go second because he didn't get a question. So, guys, what we're going to do is Nicole's going to go first, and then Ty, you're going to go second. You're going to come back down the line. Got it? All right. Right? Okay. Appearance first. Absolutely. All the idea instructions for you. Got it. They were right at. Yeah. All right, guys, quickly, please.
Thank you so much. The presentations have been awesome so far. I would hire any one of you once you're able to be hired. I have a kind of a two-part question because this is a very AI heavy plan. First and foremost, where are all the servers, where are the racks, where are the technicians are going to be working on these machines? Where is all that infrastructure and how are you going to deal with heat?
Servers. Oh, sorry. Regarding the servers, we had the original intention. If you look up there, we have a lot of storage, and this storage is meant to be general storage for a lot of things. It was meant to be storage for servers, your sort of spare parts, your ships, whatever, your escape pods, effectively whatever you could possibly need on a settlement. So that is most likely where our sort of settlement storage would go. So, sorry, not storage. Sorry, our servers would go.
Yeah. Okay. That'll work. And then.
Oh, sorry. On top of that, also the command center, because they would be close to the command center. So we. Oh, keep the mic. Keep the mic. Yeah. Okay. So we want the servers to be closer to the command center, so we have easier time to navigate between the two areas. So.
Good job. You fully answered that question. And then for the timeline. I'm sorry, I didn't capture which slide it's on, but in your project plan, you have March 2078. We're getting things constructed by bots. We have mineral hubs being built in 2079, but it isn't until October 2082 that we get communication systems to come online. So how are we communicating? with all of these bots, and how are we communicating what we need to happen?
So thank you for the question. So unfortunately, in this situation, those communication systems are communication systems between different areas of our settlement. So the bots themselves will be controlled via us during the construction process from a separate area, in which we'll be able to communicate with them without needing to be inside the settlement ourselves, because the settlement is currently not pressurized, there is no air, and so we will not be able to be there ourselves.
Thank you.
Could you go to slide 29? My question's a lot less technical, but I'm just curious here. So that was it. So there to the left, like it's a very important consideration that we are exercising, we are maintaining health, but with a blimp that's riding in a turbulent atmosphere, Venusian storms are notorious. What's the additional risk from playing these floor games and floor sports on a ship that's going to be hitting turbulence? How does that add to health concerns or hazards for our workers? How does the additional risk of these floor games being played in a turbulent atmosphere increase the hazard of risk or harm to the people living in this blimp?
So thank you very much for your question. And I think unique to this year's ISSDC is the fact that we are designing a settlement that is flying rather than orbiting or at a Lagrange point. So in that sense, we're trying to approach this much more like how an airline would, I suppose. We've all flown, 20 or something hours to get here. And I'm pretty sure, and like we've said before, we have sufficient safety precautions here. We have, with our smartwatches and all of our integrated systems, and as well about AI and also our Doppler radars, we have very sensitive equipment. We will be able to predict these weather phenomenon early on. And it's just a matter of putting on the fasten seatbelt sign.
All right. Can you talk me through on slide 15 a little bit more details about the ConOps of your Hermes rocket, how you get it off, how you launch it from the spacecraft and where it goes? Slide 15, please. Yeah.
So the way in which the rocket will be attached to the ship is it will be connected via a mechanical arm off of the side near the port that I believe was visible in the first diagram. And what will happen is the flaps will also act as will act as flaps to be able to angle it in a way which it will begin its climb, and then it will use the hydrogen thrusters originally to break through the atmosphere, and then once it breaks through the atmosphere, it will use the ion beam thrusters to continue moving through space.
All right, thank you so much for the presentation. Could we go to slide 9, please? Yeah, so I have a lot of questions about this. I'd like to start out with what was the rationale behind the 92 seconds of free fall? Can someone please speak to that?
So our initial idea was to make like a ballistic fall so that we don't capture the air that is within the fall, because we are at 10 kilometers that we want to capture the air because of its density, its pressure, its abundance of hydrogen and nitrogen and O2 and CO2. And that is why we wanted to make like, we calculated the time estimated for the fall based on the gravity of the planet.
Right. So you're falling 40 kilometers in a free fall state. Free fall is when you intentionally eliminate lift. I'm really, really concerned that it's basically just going to end up being a falling object with no aerodynamic control whatsoever. And I'm really, really concerned that you're falling 40 kilometers in 92 seconds. I'm a little bit worried about that. Second thing, there was a comment made that these are going to be docked on the side of bottom of the aircraft. If we could go to slide 1, please. Could you show us where they're being docked? Slide 1 more to the right. Yep.
I can't really tell what color it is from here, but labeled on the bottom right, it says gas collection hangar. That is where we will be storing our drones, and that is where they will be dropping from. And then again, the 50 to 10 free fall, that is to eliminate the collection of our own turbulence, our own debris, though that could be adjusted in the future in case we don't want to crash, we don't want to hit anything, we do not want to lose our drones. So that can be adjusted, and I do see why you would want to adjust that.
Thank you so much for your presentation. Can we go to slide 11, please? There we go. So you guys made use of this hub and spoke model where you've got these smaller drones that are delivering the materials to collection sites that then make use of larger drones. And what I'm hearing here is a lot of infrastructure on the ground to make this possible. What's the thinking behind that?
So our initial idea was actually to have most of our refining and processing facilities on our settlement itself, but it became very clear that in order to offset the economic benefits that this settlement promised to bring, that having all of these intensive refining and also these storage facilities on the settlement itself would be it would pose of a massive energy crisis. And considering that Venus itself and its environment at its surface is inherently more advantageous to these refining processes. We're talking about higher pressure, higher temperatures. So in that sense, we are requiring lesser energy costs to do these on the surface. And so our Nubarum can actually serve as more so of a logistical gateway and a massive command center for us. By offshoring all of these refining and by running this hub and spoke model, we can ensure a more cost effective, we can ensure a more, we understand it's going to be more maintenance heavy, but we definitely think that the economic benefits, we think that the strain on infrastructure and everything else is going to outweigh our current disadvantages of a larger model.
Okay, thank you.
Can we go to slide 23? I see that you guys use sulfuric acid in the waste processing. Can you tell me how you came to this conclusion that this is the best solution?
Right, so we've probably all seen like these science experiments where like we dropped concentrated sulfuric acid on like a cotton swab maybe, and we saw like how it chars and it burns like with steam. So generally with organic waste in general will contain carbon, and carbon with concentrated sulfuric acid will undergo a reaction that's endothermic, so it won't go too much, but obviously, we still have power within the ship, a lot of power from nuclear reactors that we can use to undergo this reaction where it turns it into sulfur dioxide, carbon dioxide, and water, which we can recycle and reuse again.
So while designing this, I actually spent a lot of effort on this. Like while designing this, I considered several alternatives, including some of the more popular bioreactors. So why did I not use that in the end? While one of our core objectives is to keep like a closed tab, a tight hold on resources that are not readily available on Venus, which includes water and hydrogen in general. The problem with bioreactors is that they're high maintenance, they're sometimes unstable, and their processing speed is slower compared to that of a chemical reaction. And sulfuric acid is already something that we gather for our purposes. So why not use it in trash processing too? The filter already takes out the 75% of water that's present in human waste, and the sulfuric acid reaction makes it even faster. That's the rationale. Thank you for the question.
All right, Vulture, please come up, get your photo. Please pay attention to Theo here in the yellow lanyard. squeeze in, do anything he asks as quickly as you can do it. Outside of Vulture, anyone with dietary restrictions, please exit over where Tammy, would you raise your hand? Where Tammy is to do. So Vulture, stay where you are, get your photo done. Anyone in any of the other teams with dietary restrictions, please exit where Tammy is to get your lunch. Dietary restrictions only, please exit now for lunch.
Thank you very much. We're not going to be kneeling on the front row, but if you are of the shorter persuasion, please could you diffuse your way towards the front, please? I'm going to need those of you over towards Alex, just maybe shuffle in just a tiny bit, make friends with your neighbors. That's looking good, just a tiny bit more. Over on this side, maybe you can just take a few steps over outwards because you're okay. But otherwise, we're looking pretty good. You, madam, in the back there, would you mind diffusing your way forward? Thank you. And you, sir, with the glasses, you're quite tall, so he'll have you in the back, please. You could just shuffle just that way a little bit, and then you could shuffle over that way a little bit, and then you can tuck in. Just take half a step back, and you'll be all right. Grace, could you come over just give it a bit, please? And perfect. That'll do. Don't forget it. File. Everyone say Vulture. Oh wait. Vulture. Alright.
Is this the mic? Is this the mic? Yeah. All right, folks, if you do not have dietary restrictions, please hold. Okay. If you do not have dietary restrictions, please hold. Please stay here for just 1 minute. Yeah. Hey, Jason, can you give me a status on the line for lunch? You can give lunch to somebody, lunch organization to someone else.
100%. I'm gonna have them go to 7030. Yeah. Need your help. I need one of the three of you to get on the stage and Thank you so much. You got it. However you decide.
Que sí que presentas al final. Ahora queda. Claro, queda. ¿A ti te hace ilusión? Que no, a mí no. Te hace ilusión a ti que no vas a hablar, ¿no? Yo lo hago por ti. No me acabo de caer. Esperas tú. Que tú quieres hablar. Hazlo desde la esquinita. Hazlo desde la voz misteriosa.
Pues tú quieres hacerlo.
Please go that way. The start of the line is over there and it's a narrow hallway. So if you're getting food, go that way.
Okay. Yes. No. You look like on the stage. Who's here?
Everybody has come out.
Do you want the mic? Explain.
Why not? Because I got these guys taking all of them.
Thank you. Thanks. It's all yours. I have no idea. Tell me that you keep the mic. Yeah. I'll take it.
Okay, where's Tammy?
Okay, somewhere.
Nobody listened. Like they had dietary restrictions and everybody. Yeah. And now they're taking all of this stuff. I don't know what to.
Regular food.
Salads that are in there. Yeah, but yes, we need to put them out if we need them. Ask if anybody is strictly vegetarian or vegan, they need to go
out here.
The table.
This looks like it has beef. It has turkey, maybe, and ham. Which one do you need? This is only ham, and this is turkey. Okay. Yeah, and they only get one. We've already taken. Is there anybody strictly vegetarian? Okay. I will. Do you want me to when we're ready? Do we tell them when we're ready?
I'm pretty sure that this is
Esta es la historia de un grupo de jóvenes que ha roto fronteras, construido puentes y que está poniendo a México y a Perú en el mapa de la industria espacial. El camino inicia con el torneo de diseño de hábitats en el espacio realizado en México y Latinoamérica desde hace 5 años, a través de Spaceport MX. Al concluir el torneo, se seleccionaron a 25 jóvenes destacados en esta competencia, los cuales trabajaron por 3 meses en el diseño de un hábitat espacial en la órbita de Marte. Así surge ARESAM, el hábitat que diseñaron estos 25 jóvenes para obtener un lugar en la final internacional del Space Settlement Design Competition. Más de 1000 estudiantes participaron, solo 19 jóvenes latinoamericanos fueron elegidos, y entre ellos 13 orgullosamente chiapanecos, 3 del Estado de México, 2 jóvenes guanajuatenses y una brillante representante del Perú. Juntos han imaginado ciudades en Marte, estaciones en órbita, hábitats donde la humanidad podrá soñar y vivir más allá de nuestro planeta. Estos jóvenes viajarán al Kennedy Space Center en la NASA para participar en el International Space Settlement Design Competition, la competencia que reúne las mentes jóvenes más brillantes en el diseño espacial. La delegación México-Perú va con el corazón lleno de sueños, con la certeza de que el futuro se construye aquí, ahora, con pasión, disciplina y visión, porque en México y en Perú ya estamos diseñando el futuro de la humanidad en el espacio.
Comunidad de Space por MX, hola, ¿cómo están? Buenos días. Estamos transmitiendo la presentación de los chicos que están en la competencia internacional de diseño de hábitats. Estamos ahorita en el descanso. Están haciendo un launch y en unos momentitos más se va a volver a restablecer esta presentación de proyectos que realmente nos han parecido bastante interesantes. Y pues bueno, enseguida vienen las dos compañías en donde están nuestros chicos de la selección México y Perú, que están divididos en 2 equipos, están en 2 compañías diferentes, pero pues bueno, están haciendo un excelente trabajo. Lo estuvieron dando todo en estos días de competencia y pues este es el día donde presentan los proyectos y empieza los jueces a deliberar cuál de los 4 proyectos fue el mejor o el que se trabajó más, ¿no? Lo más acercado es lo que sea más viable para la industria espacial, es el proyecto que sea más viable de realizar y que en la cuestión de costos no signifique un impacto tan grande, sino la cuestión es que sean un excelente presupuesto, reducir costos y que sea un proyecto que sea viable para realizarse, ¿no? Entonces, pues nada, vamos a estar en este descanso y en un momento van a empezar otra vez las presentaciones. Seguimos aquí.
Mama said, don't give up. It's a little complicated. All tied up, no more love. And I'd hate to see you waiting. They say it's all been done, but they haven't seen the best of me. So I got one more run, and it's gonna be a sight to see. Had to have high hopes for a living. Shooting for the stars when I couldn't make a killing. Didn't have a dime, but I always had a vision. tied up, no more love, and I'd hate to see you waiting. They say it's all been done, but they haven't seen the best of me. So I got one more run, and it's gonna be a sight to see. Had to have high hopes for a living, shooting for the stars when I couldn't make a killing. Didn't have a dime, but I always had a vision, always had high hopes. Had to have high hopes.
Esta es la historia de un grupo de jóvenes que ha roto fronteras, construido puentes y que está poniendo a México y a Perú en el mapa de la industria espacial. El camino inicia con el torneo de diseño de hábitats en el espacio realizado en México y Latinoamérica desde hace 5 años, a través de Spaceport MX. Al concluir el torneo, se seleccionaron a 25 jóvenes destacados en esta competencia, los cuales trabajaron por 3 meses en el diseño de un hábitat espacial en la órbita de Marte. Así surge ARESAM, el hábitat que diseñaron estos 25 jóvenes para obtener un lugar en la final internacional del Space Settlement Design Competition. Más de 1000 estudiantes participaron, solo 19 jóvenes latinoamericanos fueron elegidos, y entre ellos 13 orgullosamente chiapanecos, 3 del Estado de México, 2 jóvenes guanajuatenses y una brillante representante del Perú. Juntos han imaginado ciudades en Marte, estaciones en órbita, hábitats donde la humanidad podrá soñar y vivir más allá de nuestro planeta. Estos jóvenes viajarán al Kennedy Space Center en la NASA para participar en el International Space Settlement Design Competition, la competencia que reúne las mentes jóvenes más brillantes en el diseño espacial. La delegación México-Perú va con el corazón lleno de sueños, con la certeza de que el futuro se construye aquí, ahora, con pasión, disciplina y visión, porque en México y en Perú ya estamos diseñando el futuro de la humanidad en el espacio. Esta es la historia de un grupo de jóvenes que ha roto fronteras, construido puentes y que está poniendo a México y a Perú en el mapa de la industria espacial. El camino inicia con el torneo de diseño de hábitats en el espacio realizado en México y Latinoamérica desde hace 5 años, a través de Spaceport MX. Al concluir el torneo, se seleccionaron a 25 jóvenes destacados en esta competencia, los cuales trabajaron por 3 meses en el diseño de un hábitat espacial en la órbita de Marte. Así surge ARESAM, el hábitat que diseñaron estos 25 jóvenes para obtener un lugar en la final internacional del Space Settlement Design Competition. Más de 1000 estudiantes participaron, solo 19 jóvenes latinoamericanos fueron elegidos, y entre ellos 13 orgullosamente chiapanecos, 3 del Estado de México, 2 jóvenes guanajuatenses y una brillante representante del Perú. Juntos han imaginado ciudades en Marte, estaciones en órbita, hábitats donde la humanidad podrá soñar y vivir más allá de nuestro planeta. Estos jóvenes viajarán al Kennedy Space Center en la NASA para participar en el International Space Settlement Design Competition, la competencia que reúne las mentes jóvenes más brillantes en el diseño espacial. La delegación México-Perú va con el corazón lleno de sueños, con la certeza de que el futuro se construye aquí, ahora, con pasión, disciplina y visión, porque en México y en Perú ya estamos diseñando el futuro de la humanidad en el espacio.
Hola, hola, ¿cómo están? Nuevamente estamos aquí en esta transmisión especial. Yo soy Oscar Rodríguez, soy el coordinador de comunicación y cultura espacial de Spaceport MX. Y el día de hoy estamos aquí transmitiendo en vivo estas presentaciones que están teniendo todos los equipos que están participando en la competencia internacional de diseño de hábitats allá en el Kennedy Space Center en Orlando, Florida, ¿no? Y bueno, les doy la bienvenida a quien nos está viendo el día de hoy. Estamos pues muy emocionados, ¿no? Del desempeño que han tenido nuestros chicos y que van a presentar apenas en estos 2 equipos que vienen enseguida. Ahorita estamos en el receso, pero pues bueno, estamos esperando a ver el trabajo que van a presentar. Estas propuestas finales, cabe mencionar que son ante expertos de la industria aeroespacial mundial, ¿sí? Entonces, es importante cómo ellos van a presentar este proyecto ante personas que realmente trabajan en la industria espacial. Entonces, es importante ver cómo este tipo de competencias te acercan realmente a una experiencia como si fueras un contratista de la NASA, y tus CEOs y tus asesores son gente que realmente trabaja o ha trabajado en industria espacial como en NASA, en Action Space, etcétera. Y el día de hoy, pues bueno, tienen la oportunidad de presentar estos proyectos ante este tipo de personalidades, ¿no? Y pues bueno, estamos emocionados. No es cualquier cosa, es realmente defender un proyecto, presentar un proyecto, pero ¿qué están presentando exactamente? Es interesante ver que este proyecto, ellos les mandan una propuesta para el proyecto que tienen que hacer. Y este año la misión se sitúa en un escenario, obviamente, que es futurista, que es en el año, bueno, es el 26 de julio del 2075, ¿sí? Entonces, en el 2075, aquí tengo el dato, y bueno, la Foundation Society está invitando a los equipos a diseñar la primera nave, es como un crucero espacial, la primera nave que operará dentro de la atmósfera de Venus, ¿sí? Llamada VO1, donde el objetivo principal es el proyecto es desarrollar una estructura que sea capaz de extraer nitrógeno y oxígeno de la atmósfera venusiana. Otro objetivo es procesar las materias primas directamente del sistema solar interior y exportar los recursos a la órbita de Venus y el sistema solar. Entonces, estamos hablando de que son 3 cosas las que tuvieron que realizar los chicos en este proyecto, ¿no? Primero, situarse en el 26 de julio del año del 2075, y van a estar dentro de la atmósfera de Venus en un crucero espacial que vaya a extraer gas, nitrógeno y oxígeno de la atmósfera de Venus, procesar materias primas directamente desde la superficie del planeta y exportar a la órbita, exportar estos recursos a la órbita de Venus y el sistema solar. Entonces estamos hablando de que es un reto técnico, es un reto científico y creativo muy grande, y nuestros chicos están demostrando su talento y visión en una competencia de talla mundial como esta, ¿no? Y pues bueno, ¿por qué es importante participar? ¿Por qué es importante participar en este tipo de competencias? Pues porque pues no solo impulsa el pensamiento crítico, el trabajo en equipo y la innovación, sino que también nos va a permitir, en especial, que jóvenes de Latinoamérica, de México, se posicionen como protagonistas del futuro de la exploración espacial. Si cada uno de los participantes está resolviendo problemas reales que la humanidad pudiera o podría enfrentar en un futuro, ¿no? Sobre el espacio. Por eso queremos hacer también, bueno, hacer una observación de que hay que apoyar ese tipo de iniciativas que realmente les transforman la vida a los chicos. Queremos abrir las puertas para que más jóvenes puedan vivir de experiencias como esta. Y pues bueno, si nos están viendo chicos el día de hoy, pues hay que sumarse al torneo latinoamericano de diseño de hábitats, que es la mejor manera de empezar el camino que hoy nuestros chicos están recorriendo en este momento. Ellos primero entraron a un torneo de diseño de hábitats y empezaron un proyecto que los llevó a la semifinal y que por ende los pasó a la final del torneo de diseño de hábitats entre más de 10,000 estudiantes. Entonces es importante que podamos apoyar este tipo de iniciativas para llevar más talento, para incluir a México dentro de la industria espacial. Entonces sigamos esperando. Ahorita están en el launch los chicos. Faltan presentar los 2 proyectos en donde están nuestra selección de México, Perú, los chicos de Chiapas, los chicos de León, Guanajuato, los chicos de México, son los que van a presentar sus proyectos en las compañías que les tocaron. Entonces, síganos viendo, estamos aquí, dejen sus comentarios, aquí estoy viendo varios comentarios. Al principio no se escuchaba, pero ya lo solucionamos. Noemí Vivas, aquí está Alfonso Penagos, felicidades, abrazo a todos. Doris Carpio, que nos dice felicidades, Pau, estoy viendo el video. Tú puedes, Ari. Perú presente, saludos hasta Perú, que están viendo el desempeño de Ari. Noemí Vivas con todo México, felicidades, Pau, dice Alberto de los Santos. Noemí Vivas, bueno, entonces, muchas felicidades a todos, gracias Alejandra Estela. Vamos a seguir esperando que termine el launch para que se puedan presentar estos 2 proyectos que faltan de las 2 compañías restantes, donde están nuestros chicos de la selección México-Perú y que realmente están haciendo un papel extraordinario. Sí, he visto algunas fotitos o me han comentado que pues sí está reñida la competencia, y es lo interesante de esto, ¿no? Que se enfrentan realmente al rigor del ambiente de la industria espacial, de la competencia, de realmente que va a trabajar bajo presión, trabajar en equipo. La colaboración es sumamente importante en este tipo de competencias como lo es la industria espacial. Sí, Alejandra Estela nos dice que estamos emocionados. Sí, estamos muy emocionados porque, pues bueno, vamos a ver qué proyecto van a presentar estos chicos, y que realmente no es tan fácil pues, primero a ponerse de acuerdo con gente que es de otro país, porque vienen con toda una cultura diferente, ideas diferentes, de diferentes contextos, pero a final de cuentas de eso se trata, ¿no? De que se pongan de acuerdo para poder sacar adelante este proyecto. Entonces, aquí estamos hablando también de las aptitudes que tiene que tener y de las habilidades que tienen que tener los chicos para poder estar en esta competencia. Felicidades, felicidades, Jean Lee. Y queremos también agradecer al consulado de Orlando que les dio realmente una bienvenida espectacular a los chicos. Les dio sus reconocimientos por estar participando en esta competencia, y los recibieron, los reconocieron, y creo que eso nos ayuda a ser visibilizados y a hacer que estos chicos sean visibilizados para que otros chicos puedan inspirarse y seguir el ejemplo. Lilia Vargas, sí, dice felicidades Jean Lee, felicidades a todos los jóvenes participantes. Entonces todavía estamos, aquí estoy viendo que estamos todavía esperando a que terminen el launch. Dijeron creo que 15 minutos. Sí, así es. Y bueno, pues no solamente es venir, no es venir a competir por competir o que hablen excelente inglés, sino además del conocimiento técnico que implica diseñar un hábitat espacial, si esta competencia también pone a prueba y fortalece habilidades que son muy importantes. Por ejemplo, les decía hace ratito el trabajo en equipo, porque los equipos están formados por chicos de diferentes regiones, incluso países, que tienen que colaborar como si fueran una agencia espacial real, una empresa. Y cada uno aporta desde su área, por eso todo tiene que funcionar en conjunto, ¿no? El liderazgo, la toma de decisiones. En un proyecto tan complejo se necesitan líderes que sean capaces de coordinar, de delegar, de tomar decisiones bajo presión. Y aquí no hay respuestas únicas, sino solo soluciones creativas que deben defender con argumentos. También debe haber comunicación efectiva. Tienen que presentar estas propuestas, como les decía, ante los expertos de la NASA, ingenieros y científicos, y aparte convencerlos. O sea, esto requiere claridad, requiere confianza y habilidades de explicar y de saber comunicar esas ideas complejas de una manera simple y que sea rápido, porque tienen muy pocos minutos para presentar su proyecto y que sea convincente para ganar, ¿no? En este caso, o que los contraten, ¿no? En caso de esta simulación. También otra de las habilidades, pues, es la de resolución de problemas, que desde los desafíos científicos y técnicos hasta las diferencias de opinión, que son importantes, las diferencias de opinión que pueda haber en el equipo, todo se tiene que resolver de forma creativa, de forma constructiva, como en una misión espacial real. O sea, lo técnico es importante, pero ya están informando que ya merito, va a empezar otra vez, ¿sí? Entonces, todo tiene que resolverse de una manera creativa. Lo técnico es importante, pero aquí es cómo reacciones, cómo resuelves inmediatamente lo que está pasando, ¿no? Analizar los datos, bueno, todo tiene que resolverse de una manera creativa y constructiva. También el pensamiento crítico y la adaptabilidad. ¿Por qué? Porque los escenarios cambian. A veces también las reglas pueden cambiar. Los chicos tienen que adaptarse rápidamente a analizar los datos y repensar las estrategias en tiempo real. Aquí no tienen tanto tiempo decir, bueno, piénselo para mañana y lo hacemos. No, aquí es piénsalo ahorita, la solución que nos puedes dar en este momento. También la gestión del tiempo y la organización, porque tienen un tiempo súper limitado para desarrollar todo un proyecto espacial. Imagínense todo lo que requiere, ¿no? El diseño, la logística, la simulación, la presentación, el marketing, cada minuto es indispensable porque tienen que aprovecharlo. Sí, entonces es importante que hablemos también de que cuando ellos desarrollan estas habilidades, les abre puertas no solo para la industria espacial, sino cualquier campo profesional al que ellos se vayan a enfrentar. Y sobre todo les da la confianza de que pueden ser parte del cambio y liderar, bueno, proyectos grandes, no solamente a un nivel local, sino a un nivel también nacional e internacional. Entonces estamos muy contentos. Les repito nuevamente cuál es la misión que están haciendo los chicos. Es en el año 2075, es el 26 de julio del 2075, y una empresa que es la Foundation Society los está invitando a todos los contratistas a presentar las propuestas del primer crucero espacial o la primera nave que está dentro de la atmósfera de Venus con el propósito de extraer nitrógeno y oxígeno, ¿sí? Entonces, ¿por qué estos gases? Pues bueno, porque estos gases pueden usarse para crear aire respirable como materia prima o para procesos industriales, incluso también para combustible para cohetes, dependiendo del sistema solar, del sistema o la misión espacial. La atmósfera de Venus es muy densa y rica en dióxido de carbono, pero también contiene pequeñas cantidades de nitrógeno, lo cual es valioso para futuras colonias e industrias espaciales que se vayan a asentar ahí, ¿sí? Entonces, van a extraer gases, nitrógeno y oxígeno de la atmósfera de Venus, van a procesar estas materias primas directamente desde la superficie del planeta y van a exportar los recursos de la órbita de Venus al sistema solar. Pues todo esto lo tienen que diseñar los chicos, cómo van a extraer el gas, cómo es la nave, qué funcionalidad tiene, cuál es ese diseño, etcétera. Todas estas cuestiones técnicas las tienen que explicar. Orgulloso, dice aquí Flor, orgulloso de los chiapanecos, sobre todo de su hija Monse. Claro que sí, Monse ya ha presentado también un profesionalismo a la hora de trabajar, como todos los chicos. Felicidades, México, dice Gaby Pérez de Morales. Estamos muy contentos de que estén participando estos chicos, de que nos estén representando, a veces navegando contracorriente, pero están ahí, están ahorita representando a México y a Perú con toda la emoción, y yo les puedo asegurar que este tipo de proyectos pues les va a cambiar la vida para siempre, ¿no? Va a marcar un antes y un después de ellos, después de esta competencia, por el rigor científico que tiene, por el rigor mental, emocional que tiene, y que eso obviamente pues van a madurar increíblemente, ¿no? Saludos también, Esteban, de parte de su familia. Wow, todos los chicos han tenido que pasar una aventura para ser seleccionados, para el trámite de sus visas, los apoyos que a veces llegaban, que no llegaban, pero bueno, estamos aquí ya con ellos, y esta foto fue en el consulado de Orlando, donde les repito, lo recibieron de una manera increíble, ¿no? Y pues está abierta la convocatoria para el torneo latinoamericano de diseño de hábitats en el espacio 2025, del cual queremos sacar de ahí la siguiente generación que nos represente en el 2026 en el torneo, en la competencia internacional de diseño de hábitats allá en el Kennedy Space Center. Entonces, todavía están a tiempo. Díganle a los chicos talentosos. Tenemos chicos talentosos en diferentes partes del país, en rinconcitos que no nos pudiéramos imaginar. Existe talento. Tenemos chicos que hablan su lengua originaria, y que es emocionante ver cómo salen de su comunidad para proyectarse hacia el mundo de una manera increíble, y este proyecto es el que nos permite visibilizarlos y que este talento se empiece a difundir, ¿no? A todos. Les voy a dejar un videito en lo que vamos siguen en el launch, síganos haciendo aquí algunos comentarios, qué les ha parecido este torneo, cuéntenos cómo, si están ahí los papás, cuéntenos cómo vivieron esto con sus hijos, cómo ha sido este proceso como padres de familia, o como familiares y amigos cercanos para que también podamos conocer esa parte, ¿no? Por favor, coméntenos ahí, nos encantaría que nos dijeran cómo se sienten también ahí en casa, cómo se sienten los familiares, los amigos, los maestros también de ver a estos chicos participando. Voy a poner un video y regresamos con ustedes.
Esta es la historia de un grupo de jóvenes que ha roto fronteras, construido puentes y que está poniendo a México y a Perú en el mapa de la industria espacial. El camino inicia con el torneo de diseño de hábitats en el espacio realizado en México y Latinoamérica desde hace 5 años, a través de Spaceport MX. Al concluir el torneo, se seleccionaron a 25 jóvenes destacados en esta competencia, los cuales trabajaron por 3 meses en el diseño de un hábitat espacial en la órbita de Marte. Así surge ARESAM, el hábitat que diseñaron estos 25 jóvenes para obtener un lugar en la final internacional del Space Settlement Design Competition. Más de 1000 estudiantes participaron, solo 19 jóvenes latinoamericanos fueron elegidos, y entre ellos 13 orgullosamente chiapanecos, 3 del Estado de México, 2 jóvenes guanajuatenses y una brillante representante del Perú. Juntos han imaginado ciudades en Marte, estaciones en órbita, hábitats donde la humanidad podrá soñar y vivir más allá de nuestro planeta. Estos jóvenes viajarán al Kennedy Space Center en la NASA para participar en el International Space Settlement Design Competition, la competencia que reúne las mentes jóvenes más brillantes en el diseño espacial. La delegación México-Perú va con el corazón lleno de sueños, con la certeza de que el futuro se construye aquí, ahora, con pasión, disciplina y visión, porque en México y en Perú ya estamos diseñando el futuro de la humanidad en el espacio.
Mama said, don't give up. It's a little complicated, all tied up. No more love, and I'd hate to see you waiting. They say it's all been done, but they haven't seen the best of me. So I got one more run, and it's gonna be a sight to see. Had to have high hopes for a living, shooting for the stars when I couldn't make a killing. Didn't have a dime, but I always had a vision. Always had high hopes. Had to have high hopes for a living. Didn't know how, but I always had a feeling I was gonna be that one in a million. Always had high hopes. Had to have high hopes for a living. Shooting for the stars when I couldn't make a killing. Didn't have a dime, but I always had a vision. Always had high hopes. Had to have high hopes for a living. Didn't know how, but I always had a feeling I was gonna be that one in a million. Always had high hopes.
Bueno, ya estamos de regreso. Todavía, como pueden ver, siguen en el lunch. Entonces, pues vamos a esperar un ratito todavía. Y como les iba comentando, realmente esta es una experiencia padrísima que están viviendo los chicos ahí en Florida. Les repito la misión que están llevando a cabo, que es la primer nave o crucero espacial que va a estar en la atmósfera de Venus. Es el 26 de julio del 2075. Y van a extraer nitrógeno y oxígeno de la atmósfera de Venus, y van a procesar materias primas directamente también desde la superficie del planeta y en la órbita de Venus y el sistema. Ya vamos a empezar nuevamente. Estamos aquí y bueno, a empezar. Ok. Ya estamos por comenzar nuevamente y bueno, solamente quiero hablarles de cuál es la magnitud de esta experiencia, que bueno, no solamente es una competencia, como les decía, sino es una simulación de cómo se podría trabajar en una verdadera agencia o como una empresa en el futuro, ¿no? Aquí se toman las decisiones reales para los desafíos que un día va a tener la humanidad. Imagínense tener 16 o 17 años, 20, y estar resolviendo problemas que algún día tendrán que abordar ingenieros y astronautas en Venus o Marte. Eso realmente está pasando ahora, y esto es la semilla de lo que puede ser la inserción de México en la industria espacial. Cuando México participa, Latinoamérica participa, el mundo pues nos escucha, ¿no? Estamos demostrando que talento, visión, todo eso hay en México, y hay jóvenes con mucho talento para diseñar el futuro desde México. Y cada estudiante mexicano que está aquí y nuestra estudiante de Perú están rompiendo barreras, no solamente están soñando con el espacio, están diseñando el futuro de la humanidad en el espacio. Y si están viendo esto, chicos, o si conocen a ustedes, padres de familia, a chicos que tienen este talento y tienen curiosidad por el espacio, la ciencia, la ingeniería y el diseño, este es el momento de participar en el torneo latinoamericano Diseño de Hábitats, que puede ser el primer paso para llegar aquí a Florida. Este torneo no solamente es para genios ni para gente totalmente técnico, es para chicos y chicas con imaginación, con ganas de aprender, de trabajar en equipo y de proponer ideas, si tú lo quieres llamar así, ideas locas que pueden cambiar el futuro. Entonces, estamos a un minuto de comenzar, por acá están diciendo, y pues bueno, sentimos en Space por MX que el futuro de la exploración espacial necesita de todas las voces de ingenieros, de diseñadores, de científicos, de comunicólogos, de artistas, y lo mejor es que esto ya está comenzando, ¿no? Entonces, desde México, desde América Latina, podemos liderar misiones, construir hábitats y ser parte de esta historia del espacio. Bueno, ya van a tomar todos sus asientos. Ya vamos a comenzar. Alejandra Estela dice, arriba Esteban Rivera Pérez. Claro que sí. Está trabajando arduamente. Y pues nada, ya estamos por comenzar. Vamos a ver, bueno, van a empezar. No sé qué compañía vaya a empezar, pero van a presentar los proyectos restantes donde están nuestros chicos de la selección México-Perú, que es la competencia internacional del diseño de hábitats. Ya está por comenzar. Sigan poniendo aquí sus comentarios, estemos atentos a los proyectos que van a realizar, y pues bueno, que gane el mejor proyecto, ojalá en este proyecto. Yo creo que nuestros chicos van a estar en una de las compañías ganadoras. Yo creo que sí, porque vienen con todo, vienen realmente con... Pues bueno, vamos a empezar.
I might have a future as a launch controller. Anyway, we've had two stunning proposals so far from Dougal Dynastro Systems. Blue. And of course, Vulture Aviation. And we're going to keep the show rolling with our third presentation from Flectal Constructors. Before we get onto it, quick reminder, please be the audience that you want. Keep the murmuring to a minimum. In fact, to silence. Just like that. Thank you. 45 slides, 30 minutes to present, 10 minutes for questions. Remember, presenters, when you're done, please take your seats and the whole company can come up to answer questions. And then at the very end, we'll do company photos taken by the lovely Theodore Macklin. So without further ado, we will kick off with the presentation by Flectal Constructors. And I'm starting to hear those murmurs creep up a little bit. I think we're going to have to institute a little bit of a stricter rule. Any noise, if we can pinpoint where it comes from, will result in penalty points for your company. So, just like that. Thank you. Flectal, please come up to the front, get yourself situated. We'll flip over to your presentation.
Hello, ladies and gentlemen of the Foundation Society. Today, we'd like to introduce you to Flectal's Ariadne. Just like Theseus escaped from the Minotaur's maze, following Ariadne's path of logic, so too have we followed her path to design you a settlement which is spearheaded by efficiency, safety, and a fundamental understanding of the purpose of the base. Let's get into it.
Right, so our settlement is split up into two main halves. On the left-hand side, what we can see is the main operational facility for our settlement. So it's split up into two main trusses at the top. Sorry. The truss at the top is used to store nuclear reactors, and that truss is separated off from our main operational facility at the bottom. That is also separated from our secondary power source, and the fact, like, we are trying to make sure that there aren't any redundancies on top of each other, and this way we can, if one of our systems goes wrong, we can still ensure that the other system is operating without causing damage to humans or the other power system. Underneath that, we have another small torus, and in that torus, we're going to host a new novel technology for manufacturing solar anodes, which we're going to then export to outside the Venusian atmosphere. Underneath that, we have a cylinder disk, which hosts basically most of our nominal operational capabilities on our settlement. Here on the bottom, we have a docking surface for rockets that come in from the surface, and we have air intakes around that for processing. Now, on the left-hand side here, you can see our buoyancy structure. So on the first slide, you would have seen that this was above that. So this is basically a large hexagonal structure with multiple six specifically, airbags that go around the structure. The structure itself, the hexagon, has a side length of 3,500. And as you can see, the airbags themselves are very large at 6,000 and are made out of fabric filled with hydrogen gas. Okay, so now let's look at the internal layout of the structure. So for the diagram on the left, what we've done is we've omitted some of the airbags in the front so that you can see what our main load-bearing structures are inside our settlement. What we're showing here is that our hexagon itself is a honeycomb structure. It doesn't necessarily have to be solid because what we're supporting can be this is enough to support what we need. We have large trusses that connect it to the center, which then connects down a large rod to our operating facility. Here we've coded in exactly how we're splitting up the operational capabilities underneath for each individual department, as you can see here. Okay, so now let's get to the buoyancy system itself. The airbags themselves are large fabric made, there are large bags made out of fabric. And the way that these work is we make sure that the pressure inside the airbag is the same as the ambient pressure. We're operating at a height of 50 kilometers, which will justify later on in our presentation. And at the height of 50 kilometers, the ambient pressure is 1 bar, which we aim to make sure is the same inside. This way, if we have a tear in our airbags, there is not that much of a rate of fluid loss or fluid gain inside the airbags. So we have a lot longer to be able to fix the airbag. So what you can see here is that you can see divots, even at maximum inflation of the airbag, you can still see divots in the airbag. The reason that this is the case is because we want to make sure that we have redundancy inside our entire buoyancy system, a 20% redundancy to be very specific. This is so that in case that one of the airbags pops, say, the other 5 can take up the buoyancy that it would have initially contributed for. And yeah, this is the folding mechanism for how it folds when we remove gas from it. On the right-hand side, what we can see is a small part of the engine that we would use for more fine control of our settlement position. For larger control of how our settlement would move, well, we can see on the left-hand side that we can change the buoyancy of the settlement. So this can cause the settlement to go up and down. Now, on Venus especially, and also on other planets, when you go up and down, you have different wind speeds. And with different wind speeds, they come in different directions as well. So what we would like to use, very similar to how hot air balloons steer on Earth, is use the wind speeds on Venus to steer our ship from one A to B by using an algorithm to determine exactly where you would need to go up and down and what paths you need to take. This is a gas engine that we would use for more fine control over the steering, because we don't want large velocity changes on our system, which would disrupt normal operations. Okay, now we also need to consider the aerodynamic stability of our entire system. And to do this, we have 2 main systems. On the left-hand side, we can see one of the hexagonal assembly system. And what I'd like to point out here is that we can effectively, when you have a large resultant force, this could be due to a storm, say, or something that's pushing our entire structure forward, we can then, by keeping the entire mass inside the thing constant so that it's not moving up and down, we can change how much gas one bag has and how much gas the bag on the opposite side has, which would then create a moment. This moment we could then use to offset the problems that we would have by an external force acting on our settlement. And so this acts basically to mitigate large-scale changes. For smaller scale changes, we've mounted our entire operational capacity underneath to this hexagonal structure via a ball and socket joint here. And so this ball and socket joint itself has a 60-degree maximum sort of operational freedom. And this is also then dampened by cables here. And so this allows us to basically treat the system as a weighted pendulum. And by treating it as a weighted pendulum, the base structure where we have most of our operations stays flat, whilst the top can still have a little bit of give in case you have winds or other things to correct for. And so that ball and socket joint is shown on the right here. Okay, now I said earlier that we placed our settlement at a height of 50 kilometers. Now, the reason that we placed at a height of 50 kilometers was we'd done a lot of research on the different conditions at different points on the Venusian atmosphere. So what we determined was that we'd like to simulate conditions very similar to Earth, and this was the correct Goldilocks zone that we'd found, where temperatures weren't too far off of the temperature that we need to run the settlement at, but again, the outside pressure was also perfectly at what we needed. So this is why we came to this conclusion. As our president explained earlier, efficiency is at the heart of our entire settlement. You can see that in our entire system so far, we're using the wind to propel us along. We're using the conditions we have in our advantage. Okay, now let's go on to the settlement's main materials. Now, one of the points that was raised in the RFP was that we want to make sure that we need to point out everything that's exposed to the atmosphere. Everything that's exposed to the atmosphere is going to also be exposed to sulfuric acid and other strong, harmful materials. So to combat this, we have carbon-filled ETFE layers around everything that's facing the atmosphere, which acts as chemical resistance to any other outside interaction to our system. So for our dome specifically, those are the materials we're using up there. And that's basically mainly to do with impact resistance and thermal insulation, because that's the main issues that we have with our domes. And for our entire metal structures, so our hexagon structures and the connecting trusses that we were talking about before, we're going to use these main materials that we have on the left-hand side. And so this is the main connections. Okay, now for the windows and other residential areas in the settlement, we'll start with the windows. We have cerium oxide, a thin layer of cerium oxide, just because it's very, very highly transparent. Before that, fused silica for strength and vacuum for insulation. And aluminum nitride on either side for structural integrity, and electrochromic film to basically control the amount of light that we're letting in. So suppose we want to mimic a circadian rhythm, we can do this very easily with our window section. On the other hand, we can also think about the walls. The walls are also exposed to this harsh atmosphere, which is why they have ETFE, but then they need to be much stronger. So we have titanium and aluminide and a much thicker layer of that. We also have a carbon nanofiber structure that's for impact resistance, and peak pipes of aerogel, which are the pipes that carry along our coolant for temperature control along inside the settlement. Okay, now.
Right. At missions, our main focus is that our company, Flexible Constructions, prioritize efficiency, comfortability, and also safety of the residents. Particularly, let's see how the settlement entirely works. Well, we've got rocket land, we've got assembly docking mechanism on each of the rockets that is traveling from the Venetian edge surface to our settlement. Basically, we've got smart linkage. So, what happens is these stationary docks, these have magnetic latches that can attach quickly to the settlement for transport of the raw materials that we're getting. Primarily, these are also this features a rubber gangway. Since efficiency is the key, we've also taken note of space optimization. We've also ensured that the rubber gangway is compact, it's flexible, and it gets the work done. Next slide, please.
Right. So as you already know, our settlement has to process raw minerals we take from the Venusian surface. These processes will happen in the lower part of our settlement. As you can see on the outer circle top there, we can see nickel sulfide, titanium sulfide, and manganese sulfide. Each of them has their own facilities for refining where different processes will happen. In the inner circle, you can see casting equipment where the ingots will be made, and after they cool off, they will be taken to the elevators, and the elevator will bring them to the storage compartment. Right. Let's see at atmospheric intake systems processes. Another RFP point we have to check is export of oxygen and nitrogen. We are taking a large amount of air using a turbine from the atmosphere, 34 tons an hour to be specific. This has to be processed with a lot of filters. The most important one is like the sulfuric acid electrolyzer. This removes sulfuric acid from the air, and also we can use it for making hydrogen and later methane gas. Another very important process is filtering with graphene nanoporous membranes, which only selectively let oxygen and nitrogen pass, holding carbon dioxide in the filter. We can then use the carbon dioxide to create carbon fiber and also use the oxygen. Right. The storage will happen in 4 tanks for nitrogen and 4 for oxygen. They will be loaded in containers, cask containers. Can you skip next slide, please? All right. The containers will be manufactured inside our settlement. They will be assembled by robots, and we will have assembly lines which produce containers and fill them up with gas. They pressurize it to about 150 bars. We use a special aluminum alloy so they can handle the pressure.
On this slide, but you can see these are all the products. These are the things that the people they've known as waste. This is the byproducts that we have, but at fractal constructions, this is not waste, this is asset. We'll be using all of these waste materials, the byproducts, as efficiently as possible, and we're using everything, every waste material as part to operate the whole settlement. We've primarily used carbon filaments to be produced, like graphitization, total energy, and also surface treatment as sizing plasma. So these are all reactions that we're using to get the settlement running. Next slide, please.
Okay, so here you can get some understanding of just how we're making sure that we're getting the right number of consumables at all times. I think the key thing to bring your attention to here is the system in the middle, the monitoring system, which is tracking stock. This is tracking stock across all levels. It's tracking what we have in the mining settlements, which means that when we're sending rockets to and from them, we can make sure we're always sending them to the right ones. It also means that we can communicate most effectively with subcontractors and also with our own staff to ensure that we are always stocking the base effectively. Thank you.
So after we get all of the cargo and raw materials from the Venetian surface, it first goes to the cargo bay. After the rockets that we're getting, next to refining facilities, through the refining facilities, it goes from the freight trains, and then we go to the storage depot and we ship it out. Next slide, please.
Let's dive a little deeper in the refining process. So as we already said, we use titanium sulfide, manganese sulfide, and nickel sulfide. We use roasting processes to turn them into oxides, and then smelting and ammonium sulfate mixture to cast them, to purify them and cast them into ingots. For nickel sulfide, we use ammonium leaching, which is a newer technology which helps us cut costs and also deliver high quality products. Right. Another novel technology that we use is developing some sulfur dopant on titanium oxide film, which we can use to increase power conversion efficiency for solar panels. We can sell this technology to other companies.
Right. After we've got all the resources, primarily we're getting all of them from conveyor belts. These conveyor belts are operated, these are primarily made of titanium, so they're pretty strong. And then after these are loaded up into rockets and we ship them to the to our settlement. We also have this electric grasping transportation bot. The basic primarily reason is that it is intelligent, it is smart, it's able to determine whether we have the resources stored in and as well. We're using that with the help of our friends at ATS Subcontractors. Next slide, please. This is where the fun part begins. Well, we've used rockets. Why rockets? Because rockets are powerful enough to be able to overcome the drag which is present in the atmosphere. And primarily these rockets, the outer covering, it's made of the filament productions that we've talked about earlier. We're using the waste materials. So we've getting carbon from the atmosphere, pairing that with oxygen, we get carbon filaments. These carbon filaments can be used for carbon fiber, and this exponentially decreases the weight of the rocket to transport goods and materials, primarily about 10 tons of resources. And then we've got these rockets flying up perpendicularly to the settlement and coming back gliding. And we're doing that with the help of ATS and CCA. Sorry. This is where the human interactions come in. We've got dynamic profiles and dashboards for each profile. So there's admin preview, and there's also this general overview of how you're interacting with the settlement. We also have included the number of occupations, that 450 people who are going to have jobs, their positions, and also the number of people who are actually doing it. And this also shows the control they have over the settlement. And we've also included a kill switch. So basically, if things go wrong, which they won't because we constructed fractal constructors, that won't go wrong. But if they still do, we have included a kill switch as well. Next slide, please.
Okay, thank you. So now we have a good idea of what the shell of our settlement looks like. But now we need to go to what really matters in our settlement, the people. As Flectal constructors, we take pride in civil engineering and having human-centered designs. And so we take pride in what we've made today. First of all of our settlements, human residencies are all made of modular interlocking panels. This means that we can use all of these panels together to make on demand whatever sort of building that we want. And that means that whatever type of thing we need, especially as you see in this of animation, we can make that. The choice is up to you. If you're in your home and you want to have a bigger living room for the guests you're having over tonight, or if you're trying to change the basketball court in the local area, then you can change that as well. The choice is yours, and the level of comfort that you want, you can make with these tiles. Next slide, please. Okay, so we talked about what the units can do together. This is what they can do. Using this, we can see that this is just one of the examples of many different arrangements that you could have these tiles in to make a nice sort of home for you. The point is that you can arrange them in whatever way you want to come up with whatever arrangement you need. And the thing is that there's a lot of freedom because all of the utilities, so the heat, the water, and the electricity are all underlaid below the units. So you can slide whatever you want on top and rearrange whatever you need. Okay, so here's our community layout. We can see that from here, we have loads of amenities that we always want when we have a settlement. And you can see also the emergency exits. We've designed that being able to access emergency exits is one of the most important parts of a settlement because safety is part of our design and it's not just a priority. That's why all humans are always under 2 minutes away from any one of the 42 emergency exit pods around our settlement, 36 in the human living area and 6 more in the working area. Next slide, please. Okay, so whatever sort of residents you have and whatever you want to change with visitors, all of them can come and visit and do whatever you want to do with the spaces that we have. The gym can be used for exercise and everything else that comes with it. Next slide, please.
All right. So critical infrastructure is needed so that the settlement can fulfill its concept. So over here, we've shown all the locations for the amenities that comes under critical infrastructure, everything ranging from food processing to the waste management, and all this is located in the central disk of the cylinder. So now we move on to the power. So we are generating power using two primary methods, nuclear fission and solar panels. So we've subcontracted the nuclear fission reactors with a lifespan of 30 years. And they give the most energy dense source of power, which is required for the refining of the ores by mission systems. Now moving on, solar panel is a viable source of energy here because at an altitude of 50 kilometers, the sun's rays are not completely blocked by the clouds, and therefore solar panel is not only viable but a reliable source of energy. Moving on to the next slide, we have redundancies for the power supply. So we have different cases for what may happen when the nuclear fission reactors go down. But more importantly, we've also found a method to prevent arcing on the solar panels, which is usually a big problem while using those. Now, next we speak about the heat extraction system. So for residential areas, it follows a very simple air conditioning format. And for industrial areas, it follows a coolant heat tube. And there are also energy exchangers so that the coolant keeps getting recycled and reused and there is no wastage of the coolant. Now, coming to food production, we've implemented two main methods of food production. The first one being aquaponics, and the second one being meat production. The main reason we've gone with these particular methods is because they minimize the waste, and most of the sources can be recycled. For example, aquaponics gives us algae, which can be taken raw, but can also be used for the growth in agriculture. Now, moving on to the food processing, about half of the food that we make is used for distribution, and the other half is either stored or sold for the commercial viability of the settlement. Now, moving on to the waste processing, we've come up with waste processing keeping the vision of the settlement in mind, the vision of efficiency. So we've made sure that we reuse whatever possible and we recycle the elements in the settlement wherever we can, and we throw away as less as possible.
To enhance efficiency of waste management, we've divided waste into three parts: human waste, industrial waste, and non-recoverable waste. For human waste, we're decomposing the degradable matter and obtaining clean water. For industrial waste, in the end, we are creating methane, we are obtaining methane, water, and oxygen. And for the non-recoverable waste, we've further divided it into non-reusable and hazardous waste. Next slide, please. For air and material production, we are basically using three methods to ensure that proper air composition is maintained at all times. We are making use of a self-supporting photocatalytic membrane, which is mechanically supported by heterostructure catalysts and by automated carbon dioxide splitters, which track the solar movement to optimize angles to ensure that the amount of oxygen that is being produced is maximized. We are also subcontracting oxygen to TerraTech, and for emergency backup, we have pressurized oxygen cylinders. Next slide. This is the ideal air composition that we'll be maintaining. As a contingency mechanism, we are making use of closed loop systems where controller basically they collect information about the air composition at that particular point of time, and if the composition diverts from the ideal composition, gases are released to maintain the composition to ensure the safety of the people living on the settlement. And to deal with contamination of air, we also have a mechanism which makes use of particulate filtration and UV sterilization to clean up the atmosphere and air. This is the sensor that is going to be used to determine the air composition at that particular point of time, and these are the different deviations that might be possible and the methods to deal with them. Moving on to communication, though that was not mentioned in the RFP, communication is vital for a settlement. So for external communication, we are making use of stratospheric balloon mesh network, under which these balloons not only communicate with the settlement and with each other, they also communicate with the various mining sites that are there on the surface of Venus. And as a backup communication system, we are making use of ground-based HF systems, which though are slightly slow, provide a reliable communication system in case the balloon mesh fails. For internal communication, we are making use of a device called Orbi, which is an augmented reality contact lens, which has a number of features like settlement-wide broadcast systems, and it also has a number of health benefits, like it helps us deal with space flight-related neuroocular syndrome.
Okay, now let's look at how we maintain the system. So on the left-hand side, we can see that there are three main things that we're thinking about. We need to think about the maintenance of the ETFE in the dome, because that's going to be regularly interacting with acid in the atmosphere. So we've explained how that's going to work. And these are the other systems for other regular maintenance systems. That first one was an emergency. This is looking at the other different things that could go wrong and how we're going to maintain in a similar way. Next slide, please.
Okay, so in terms of emergency sort of evacuation, we have these pods. As I mentioned, there's 42 of them, and whenever there's an emergency, everyone can get to one of these within 2 minutes, and this is going to detach from the settlement and either hold until they can come back and resolve the issue on the settlement, or they're going to hold for at least for up to 2 weeks, where they can get a sort of rescue system from elsewhere. Next slide, please. And of course, before the emergency happens, we don't want to let that happen. So we have loads of contingency plans put in place to try and reduce the chance of doing that and mitigate any health risks to humans along the way. Next slide, please.
Now so far you've seen how the settlement works, what is the settlement, and what makes our settlement safe. Now let's get to seeing how we construct the settlement. So a majority of the big lifting is effectively done in space, just for efficiency reasons. In the first year, we send in the main truss that's built, the main hexagonal structure that's sent in from Earth, and then we slowly start to tension this truss so as to not just tension it directly. Then we start to install the CO2 compressor engines, and then also add the airbags. And then by the end, after 3 months' time, we fill the airbags up with H2, and then this can start to descend into the Venusian atmosphere to then continue with the construction. The reason why we do it this way is because of asteroid risk in lower Venusian orbit. So the quicker we can get down into Venus, the better it is for the safety of the settlement. Next slide, please. Okay, now this describes how we finish the overall construction. So we add the outer windows for our residential settlements, we add the transport system and the dock for the gases, and then we add the communication structure. And this is at this point in 2079, IOC is reached. So we have rockets that are ready to dock with the settlement and start transferring material from the different standardized points across the surface. And then FOC is reached when we increase the amount of storage we can have on the settlement and increase the number of rockets that can dock at the point. We have 120 different docking points on the bottom of the overall settlement. And on the top, we actually have on top of this plain hexagon surface, a rocket launching pad that the subcontractor will use to then launch the material away once it's been processed. Next slide, please.
Okay, so we've discussed almost the whole settlement. Let's just make it clear that we have a risk mitigation system ready for our construction timeline. We're well aware that things may not always go to plan. We've got a very ambitious timeline, and we're confident that we as Flectal can achieve this. But if not, we know how to resolve the problem. We've also worked hard to make a strong Gantt chart and plan for how we're going to achieve this. This Gantt chart you'll see essentially follows the construction timeline that you've already been walked through. And this shows you how we're going to increase the volume production, like the rate of production over time. You see how it levels off at FOC because obviously there is a maximum that we can get from the mines. And there's an initial quick rate of increase. This is because we're starting with a very, very minimal IOC so that we can start working for you as soon as possible. Okay, here you can see we're making some fantastic profits for you, and we're going to roughly 100 times your investment. And so we're very excited for this, and we really hope that you move forward with us. We're sure you won't regret it. Here you can see how we have largely met our RFP on our compliance. We've been quite strict with ourselves. We want to hold ourselves to a high standard of excellence. Thank you very, very much for watching today's presentation. I hope you understand how Flectal can bring you this fantastic settlement and how we have at every level understood the main purpose of this settlement. Thank you.
Thank you very much, Flectal constructors. You can hold on to that because we've got 10 minutes of judging. Actually, I'll take that. You're right. Bring up the, I'm tired too. Please bring up the remainder of the team and presenters, take a seat. Come on up, guys. Let's get situated so that Shane can be very proud of us all for running ahead of schedule some more. All right, keep coming, keep coming. All right, which one of you is going to run the clicker? Got it, Molly. All right, I'm going to start with the first question. Kelsey, you get the timer going. Kelsey, can you give us a 2-minute heads up? All right, I will take slide 3, please. This is going to be a question between slide 3 and slide 20. But we'll start with slide 3. Okay, beautiful. Thank you so much. Can you tell me who has worked out, based on the thrust of the rocket that's leaving in the center of this, how that affects your buoyancy as a settlement as part 1, and who has calculated the clear zone required for that rocket so that you don't light the hydrogen on fire?
Yes, so the buoyancy has been calculated and it actually works. And the hydrogen is not going to be a problem for getting set up on fire because we're on Venus and the atmosphere is different. And basically, there's no other substance with which it can easily react in our conditions, so that can represent a significant issue.
Okay, so the question on the thrust. So when that rocket pushes down,
Yeah.
how are you adjusting so that your settlement doesn't go down?
I think the man that did the calculation can answer that.
So yeah, thank you for the question. The force of the buoyancy from the balloons is capable of sort of counteracting the weight from the settlement that's pulling it downwards. So it ends up being around the same altitude, which we can then have a constant pressure. Thanks.
Okay, thank you very much.
Okay, can we go to page 31 to 31? And I have a goes in a question and I have a goes out a question. So we'll start with a goes in a. So I didn't quite catch the details of your waste management system, and this is a very interesting flow chart. And I look at the second row there and it says, hey, we're going to separate stuff into biological waste and non-biological waste. And we'll do that with IR spectroscopy, if I said that right. I would expect biological and non-biological waste to start out or separated to begin with. So are we combining the two and then separating them later? That's question one.
Yeah, so thank you for that question again. There are a few applications where biological and non-biological waste are combined, and also some of the waste management systems consider them.
So the check here to find or separate the two is really just for a percentage of the waste.
Yeah, so it's also to make sure that in certain applications where they are together, they are always ensured.
Got it. So my goes out a question is the block on the bottom, and all these fine gentlemen here are standing in front of it. Okay, things are sent out of the airlock. So we have a requirement in the RFP to do responsible deposition of waste products, onto the surface. How are you guys going to make sure that what you send out is not going to adversely affect the Venusian surface, and it's controlled and it's regulated and it's well kept? This looks kind of like you're just tossing stuff overboard.
Of course. So that's a really good question. So for the waste that is non-reusable, however, is non-hazardous, we're going to use it that it's put into a capsule that it disintegrates firmly. So when heat is applied to it, the catalyst within it will decay it. And the residue produced is CO2 and vapor. So it is non-hazardous to the atmosphere and it does not affect Venus. And on the right-hand side of the flowchart, to any waste that is non-reusable, however, it is hazardous, we're putting it into a crush and decay capsule. So when it is put into the atmosphere, it will be compressed and crushed due to the pressure, and it will burn up when going down. And the only residue of this will be various gases. So we're using Venus's atmosphere to our advantage and to only provide as the residue gases and no other litter to not pollute Venus's.
All right, thank you. It would be helpful to have that further annotated as we go forward. Thank you.
My question is around the financials. So my first question is over the 55-year period.
What slide?
That's perfect. So over a 55-year period or so from the previous slide, is that 7.4 trillion across that period? And how is that spread? If I'm going to give you $7.4 trillion, at what general timeline are we dispersing those funds?
So the 7.4 trillion from the expenditure?
Yes, from the previous slide. Are the costs spread across that timeline? And if so, how?
Yeah, so you can see exactly where they come from. So obviously the construction, it all adds up as you go along. But over this period, it's a bit variable because obviously we don't know the exact costs. But because of the efficiency, and we're going to make sure that we ensure it's all set up properly, it should be that much, yeah.
Sorry, just to clarify there, that is over the whole 60-year period.
Okay, so just to clarify, this is about the whole 65 years of life after settlement. Okay, thank you.
Flectal, thank you so much for your presentation. And I thought it was interesting to see some of your divisions of responsibilities that I believe on slide. We'll skip that one. Let's go to slide 20. Your means of transporting things from the surface settlement to the main refinery itself. Interesting vehicle. 2 tons of payload for 140 tons of mass, including 92 tons of wet mass. What's the fleet size and what's the cost of this vehicle?
There's been a side technical glitch in this. These rockets will be fueled by methane, and this methane is produced by the carbon dioxide which we are absorbing. So we'll extract the carbon from that, and from the sulfuric acid we get the hydrogen. So from that we'll produce methane, as we have the vision of efficiency, and from that from that methane we'll be powering these rockets. There'll be 90 rockets in the whole settlement, out of which 76 of them will be active and 14 will be kept as emergency periods. And this calculation which you're saying here is actually a technical glitch. Each rocket will have a capacity of 10 tons when the total payload is 10 tons and the total mass is 60 tons.
Got it. Okay. And fleet size of 90, what's the cost? You said it's a fleet of 90. What's the cost in total?
All right, so the costage for the reason we've used methane, so the exterior of the entire thing of the rockets will be made by carbon fibers. The carbon fibers we are getting with the help of the carbon also that we're extracting from the CO2, we are processing that and we are making carbon fibers. And also to resist the pressure, we are using the titanium that we're refining. So basically, with the help of that, we are basically making the entire thing in situ. So we're reducing the cost by a lot. And we're only using 90 of such rockets because we have developed a scheduling system which makes it so that no mining station is ever overfilled and it's not attended to by a rocket. So as soon as a station gets that 10-ton capacity, a rocket's gonna go to it, it's gonna extract the material and it's gonna take it, and it's gonna be like a cycle.
We have 90 seconds left, so I'm going to hand over to the next question.
All right. Thank you so much for the presentation. Is the fuel being manufactured on site or is it going to be exported into it?
So as I said, the fuel will be methane and liquid oxygen. So both of them will be produced inside the settlement as we are getting it, as they are apparently the waste products. We'll be using it for our benefit and we'll not make it waste.
Yeah, just because of time. Can we go to slide 26 really quickly? Where on this slide are we manufacturing it? Because I don't see it anywhere here.
So if you see our products for waste management, one of them is methane. So we are having our waste management factories over there in the pink one, the industrial waste management and the human waste management as well. So those are the regions where our methane is going to get produced after different processes. And that's how we're going to supply the methane.
Yeah, the last thing I'll add is where are the docking ports where they're going to be refueled? It's going to be, is it all around this ring? Is that where?
So this is the operational facility.
Right.
This is only where the methane is going to be produced. There's a separate dock on the bottom of the settlement where the docking ports are going to be there. So the methane will be processed here and the fueling will be done in the docking ports.
So as the structure of the
All
settlement.
right, that's it. Thank you very much, Flecto constructors. Everybody give them a big hand. Thank you so much. Please stand here and prepare for your photo. Flecto constructors, thank you so much. Okay.
No, I'm happy. Okay, could you have the tall people at the back, please? And probably some people on this side start spreading out over because I think there's a bit of a distribution bias. Morgan, please could you go back to the middle row? Javi, could you come and join the photo, please? Are they- Need to fit you into the 3 rows. So round here, we've only got 2 rows. So could some people start forming a 3rd row in the back, please? And some people on this side are going to have to bunch in and join the 3rd row. Yeah, you probably need to be in the front. You guys can probably join a middle row somewhere. We're missing a 3rd row on this side. So could some of the tall people over here please shuffle around to the edge? Could the entire back row just shuffle along a bit, please? And some people, you guys are very tall. Please, could you join a middle row? Can you join the back row? 4th row or kneeling down? No. You don't need it. That's looking much better over on this side. This side's starting to look good. Could we swap you two, please? Yeah, could you? Thank you. Thank you. And you can step back in and stand in front of him. Cover him up. Thank you very much. You can just shift a little bit. Perfect. Thank you very much.
Hi, everybody. Apologies. Can I get one CEO per team to come up here for me with real quick? One CEO per team. Thank you. Carry on with your conversations. You have a few minutes. Thanks so much, guys. We are going to start promptly at 2:20. 2:20. Please make sure everyone is in their seats at 2:20, 2:18. Make sure everyone is in their seats at 2:18.
Okay, could we please have everyone in their seats? Please take your seats. "60 seconds. "30 seconds. "10 seconds. Three, two, one. Not as good as the first time, but we'll give it a pass. Thank you all so much for taking your seats. We're now on to our last but not least proposal from Rock Donald. As before, please treat each other as you would wish to be treated during your proposal. Any noise that we can trace back to a company will result in penalty points. And after this proposal, once all the companies have sat down, our Foundation Society judges, the head CEOs, and the compliance judge will be heading back to the Foundation Society headquarters, and they'll be the ones first to leave. I'm saying that now just as a reminder to take a seat once everything is said and done. Don't go walking around anywhere, but I'll remind you at the end once all the proposals have been done. Without further ado, Rock Donald, please come up to the front.
Good afternoon, Foundation Society members. We are very grateful to have the opportunity to present our proposal for the first in-atmosphere Venus settlement, Urania. Urania's name comes from the Greek goddess of astronomy, something that we thought was very fitting for a settlement that is not only interacting with other settlements that are mining on Venus, but also other settlements in the solar system. Our big vision is Inspiramus. We breathe, we inspire. As you will see in the next few slides, our settlement is literally breathing, and you will see that in everything that we present today.
So I guess we'll first go to the location. So the Urania will be located 56 kilometer perpendicular to the surface of of the planet, and this is gonna put us right in the purple section of the atmosphere. This proportion of the atmosphere have an average lower temperature than the other part, and this also put us right in the middle of the clouds, which allow the settlement to absorb all the not absorb to get in all the airs and generate gases. So that part is for the pressure of the for the pressure and the altitude relationship. And so we see at 56 kilometer, we have really ideal pressure for human living. It's gonna be 92% of the sea level pressure on Earth. And we also have a special location on the top of the atmosphere. That location is for landing into the atmosphere after construction phase. With the listed condition, we believe this could give us a better chance of succeed. And I know we've been seeing a lot of design today. We've seen a lot of blimps. We see a lot of balloons, but we're gonna bring you guys really new things. This is our design. During the designing process, we adopted
we adopted biomimicry, and we are inspired by mentor ray. So as our vision say, we breathe, we inspire. So we really see how Manta Creek could swim in the water, which is a fluid with so many current in so many different direction, but still maintain a stationary middle body in the water. And we really want our settlement to achieve that goal too, to hold all the strong winds, all the strong storm, and all the thrust. We want to provide a stable environment for the residents and also manufacturing facilities. So this is a more detailed look for all the dimensions and the functions of each of the area. We can see the middle part, the black cylinder, is the central function region. And this is a part where people will live in and also where the manufacturer will located. It is divided into 3 layers. The top surface part will be the docking port for inter-orbital transportation, and the first floor will be the residence floor. Second floor is for the buoyancy gases, and the third floor is for manufacture, utility system, and storage. We will also have a port at the bottom surface. It is for the shuttle that is constantly travel between the settlement and the surface of the planet. Oh, and also for this whole thing will be one component of our whole uranium, and we're gonna have 3 identical of this thing in the atmosphere of uranium. This will not only create us more reliance redundancy, but also create let us to accommodate more people during the initial construction period, and so give us like a greater avenue. This is a more detailed look into each layer of the construction of the central part. That part I say is a residential part. Second layer, we're storing buoyancy gases. Buoyancy gases, we're using helium because it's light density. The reason why we don't use hydrogen, although it have a lighter density, is because it's really easy to caught on fire, and we always value the safety of the residents first. And this part is the bottom part, is for storage, manufacturing, and a utility system. We can see for the utility system, we have 2 copies of them, the energy system, waste management, and water filtration. This is because we always want to have a backup plans. In case any of them are down, there are still backup plans to can keep the normal routine in the residence area.
Orania's propulsion system incorporates 16 multi-directional thrusters capable of achieving peak speeds of upwards of 410 kilometers per hour, which is more than enough to accommodate for the wind speeds and the environmental conditions, enabling us to have full control over all 3 settlements individually. Power generation for continuous movement and maneuverability is achieved by extracting hydrogen directly from the atmosphere due to the high potency of those natural elements within the environment provided to us in Venus's atmosphere. That allows us to fulfill the functional requirements of the settlement by extracting nitrogen and oxygen, but also enable us to utilize further amounts of nitrogen. And this also has an advantage in Pinnacle as it is very cost efficient and energy efficient. 2 thrusters are on the tail and provide an aerostatic propulsion against strong side winds, whilst 4 thrusters on the back side of each wing and 2 on the front counteract unwanted rotational motion. This comprehensive system ensures stable linear with rotational control, ensuring we have full stability over the aircraft. Airfoils are primarily promoted through biomimicry of the manta ray, maintaining a controlled pressure and velocity of fluid around the structure and ensures precautions for maintenance as we further grow the stability not only of this settlement but all 3 at the same time. The wings features are sophisticated inner frameworks comprising high carbon fiber alloy steel skeletons with vertebrae-like formations for rigidity, incorporating a more biomaterial approach to the entire exoskeleton and structure of the settlement. These bone-like structures stretch longitudinally from the central pivot point to the wings and throughout the cross-sectional area of the structure. Articulated joints intersections provide controlled movement and flexibility for the membrane and muscle systems. The carbon fiber mesh between the bones allows proper signal reception and attachment between the fibers and the cells. Corania's self-reliable and self-repairable membrane incorporates the novel 6 bases of DNA strands and the 4 original bases. This will allow us to start tapping into what is scraping the surface of current biological and genetic research, and how we can then take that to on a more structural level to increase modularity and adaptability for future innovations, so we can tap into features such as self-healing and adaptability with not only the environment, but the stresses and strains on the structure itself. Shape memory alloys enable electro-stimulated maneuverability of the wings. Internal maintenance will be handled with autonomous bots, ensuring continuous operation and resilience of the environmental stresses, with these synthetic materials having innovative features to inspire new life towards material research and biological development beyond our Earth's reaches. So the hull materials include a multi-layer system designed for extreme protection, from composite membranes to intake gases and acids, in order to look more into buoyancy and acid resistance, along with the integration throughout the structural stability. In addition, layers integrated for that protection in particular are comprised with silicon dioxides and aluminiums and titanium alloy frames to additional structural integrity on that. And we also have our window compositions, which constructed to promote circadian rhythm, allowing us to have protection, but also promote the outside lighting within the human components of the base, with the thrusters located on the sides of the wings, allowing us to stay afloat, with the wing breakage acting as a critical fail-safe for these compositions.
Now, atmosphere is the basic unit of life. So for air, we have a precise composition as shown on the screen. We have a specific air composition for our settlement and one for our vertical farm. So for air, we are getting nitrogen and oxygen from TerraTech. Apart from that, we'll be using residual gas analyzers, which will check for leaks and air contamination, and it'll make that the air purification works correctly. Now, the pressure outside and the pressure inside is a bit different. So we obviously need a control system, right? So we'll have an air pressure system. It will contain outflow valves, air circulation compressors, pumps, and variable speed compressors. Apart from that, now if contamination occurs, there will be a huge contingency inside our settlement. So for that, we'll have 3 mechanisms avoiding this. Firstly, we'll have a 4-layer filter system. It will comprise of a pre-filtered, a silver ion HEPA filter, a activated carbon filter, and a titanium oxide filter. All these filters will be integrated with plasma wave technology, and they will ensure good purification of the settlement. Secondly, we'll have decontamination doors. So before all the industrial areas near the entry doors and the exit doors, these will act as purification systems so that no contaminants or VOCs or dust particles enter the atmosphere of our settlement. They will be of 3 types: dry, wet, and vapor. They will depend on the type of industrial activity being performed. Then we'll have electrostatic vortex cleaning systems. So all the raw materials we're getting, all the inputs and all the exterior materials, they might also carry dust particles. So we need a system ensuring that These are also get filtered. So therefore, we'll be using electrostatic technology, a rapidly spinning vortex system which will use electrostatic attraction to separate out dust particles and ensure a clean settlement. But apart from all of these, we can still have many probable accidents inside our settlement, like air leak, depressurization, carbon dioxide excessive, and oxygen deficits. So we'll have solutions for each one of these as shown on the table below. Next, in 2075, power generation is a crucial component. So for primary source, we'll be using wind. So as we know, outside Venus, the wind is around 60 times as much as more as Earth. It's very high. So we'll be harnessing wind power. So we'll be having RATs. These are basically RM air turbines. So these air turbines will use the wind energy and harness it and will make power using it. These will be very efficient since they can make a lot of power. But obviously, what is a settlement without a backup source, right? So for backup, we'll have a specialized superheated steam system. Okay, so I'm sure you know about nuclear reactors, right? So they'll work very similar to these, except they will have water. So, since the atmosphere of Venus is extremely hot and will have a lot of facilities like waste and farms which will generate a lot of heat, what we'll do is we'll take all of this heat and combine it with water, and this will make a very superheated power energy system, and this will act as a backup source for our settlement. The power allocation system is also given below. We have also shown a cross section zoomed in of our hydraulic turbines, which we'll be using for our wind energy. These will be used using coil magnets, and it will ensure a sufficient power source throughout the settlement all the time. Yeah, so like I mentioned, heat removal is essential so that we maintain a good temperature inside. So for heat management, we'll be using all the heat from waste management. And this heat will be trapped with carbon dioxide. And the carbon dioxide will transfer this heat into radiators, and radiators will release this heat as infrared light into the atmosphere. A diagram is also shown showing our system of heat management.
A quintessential component of every settlement is the way that its residential sectors are designed, which is why all community plans will feature a well-structured road layout with all of the facilities and the utilities in the heart of the sector to ensure equal and open access for everyone. The residential areas on the outskirts of the sector are also split into 4 components to create more communal harmony and for increased walkability. Over here, we have the residential designs, which will provide accommodation for all of the residents at Urania. At the top part of the slide, you can see the 2-bedroom individual housing design available for potential future families or married couples. And to the right side of the slide, you can see the respective interior floor plans and the specifications. At the bottom part of the slide, we have the 1-bedroom condominium design, and each home design will also feature an emergency exit and will be supplied with contingency packs. So a tri-zone strategy will combine commercial, recreational, and entertainment facilities into one area to ensure that we not only provide a functional environment for the residents, but also an aspirational and a fulfilling one. So commercial and social facilities will include a central plaza and a community hall, which will act as the main gathering point for the residents, and a workspace district will include business incubators, startup accelerators, offices, and co-working spaces. As for entertainment, a Magnetag arena for thrill seekers will be designed in a dynamic parkour zone combined with soft projectiles and a tag-based team sport. To ensure that the facility caters for all types of demographics, the entertainment complex will also feature non-rest leisure activities, non-active leisure activities. In a hustling work environment and an industrial environment such as Urania's,
recreational facilities are incredibly important. So as for recreational facilities, we will be including parks, gardens, a neuro spa for cognitive reset, a Vitalis recreational center with earth rooms and a solarium for light therapy and homesickness relief, and Aurea Vallis, a biological conservatory split into thematic sections which can be reconfigured on a seasonal basis.
All right, for Aurelia's integrated business program, we have all of our revenues for our four main sources of business, that being our two novel technologies, our membrane and our carbon production, and our operations, including extraction, which includes the three materials mentioned in the RFP, that being titanium, manganese sulfide, and nickel, and our atmospheric processing includes the appropriate revenue and time periods as well. I'd like to draw attention to the return on investment in atmospheric processing, which is 340% over 20 years, and in excavation operations, a 6-year profit of 230.5 billion United States dollars.
In an industrial settlement such as Urania in the Venusian atmosphere, it is almost impossible to mitigate risks entirely. But at the end of the day, what matters is that we have figured out ways to consider them and mitigate those risks. So here you have the 5 high-risk, high-priority settlement systems and their mandatory operating procedures, along with their overviews. Here are the following risks and the mitigational features that we have provided for the settlement. So moving on to provisions for comfort and productivity, circadian lighting within the homes to mimic Earth's 24-hour cycle, along with optional in-sound natural soundscapes for for homesickness relief for Earth and for increased productivity. Focus pods, smart assistants, and adaptive workspaces will improve the work quality. For safety provisions, as for safety provisions, Primorvia IVA spacesuits will feature emergency locator beacons, a rapid inflatable insulation system which will activate upon suit breach or an impending collision, along with a biofeedback distress signal, which will identify unusual biometrics and along with high stress signals, and will automatically log the user's last actions and transmit an SOS signal. Contingency packs with medical and nutritional supplies, along with emergency life support supplies, will be supplied to each household. So, to ensure optimum safety for the residents, we've put in place a rapid evacuation plan with the help of internal maintenance bots being repurposed as helping with evacuation, along with directional markings and along with directional markings and evacuation sites. The presence of multiple sub-settlements will also ensure that in case of an emergency, the residents can be transported from one sub-settlement to the other. Fully modular units of furniture and architecture will ensure that the facilities in the settlement keep up with the changing demands and environment of the settlement.
Now, food production is essential because all of us need food, right? So we're using aeroponic farms for food production. Now, why aeroponic? Why not hydroponic or aquaponic? So aeroponic farm is the one which uses the least amount of water, the least amount of space, since it is vertically stacked, and it is the most efficient since it grows diverse amounts of plants. So we will feature 5 steps: production, processing, storing, packaging, and delivery and selling. So in production, we'll have an ultra fogger aeroponic system, which will have Vortex air recyclers, nutrient remixer, sensors with precision farming, and much more. In food processing, it will be pretty basic since we'll have a food processing unit, which will convert raw materials into cookies, bread, and basic things. Then for packaging, we'll have 3 types of packaging: rehydratable, bite size, and beverage packaging, and their components are shown in the screen below. Next, we have storage. For storage, we'll have a refrigerated area, which will have around a 15% humidity and 6 degrees Celsius temperature. And every month, 12% of the food will go into storage as backup food in case of contingencies. And we'll also have meal blocks. So meal blocks are like meal plans. They're also a part of contingencies. They'll be of three types: carbs, proteins, and fats. The components of the meal blocks is on the bottom of the screen. And the types of plants grown in our aeroponic farms is also given in the table shown. Yeah, so water is again a very essential component of our settlement, and so is waste. So for filtering waste, we need sorry. So waste management is essential for having a healthy and a safe environment inside. So we'll use a comprehensive process for waste management. Next is water management. For water management, we'll again have a huge system which will have three types: primary, secondary, and tertiary. It will include chlorination, screening, electrolysis, microbes, which we will import from earth and have our own microbe cultivation inside. And all of this will ensure a healthy and a safe settlement inside. The water allocation is on the bottom of the screen. Then we have operational contingencies. So a lot of things can go wrong in operations, like something can go wrong with aeroponics, water, waste. But do not worry, we have something for each one of these. So we'll have a contingency system, we'll have combined autos, HF, and we'll have robots. So that everything can go smoothly and we can facilitate all the processes inside the settlement without any problems.
So now we're going to talk about one of our novel technologies, which is the tardigrade-based membrane. So we have taken inspiration from the tardigrade proteins and cell membrane since they're flexible and tardigrades can live in extreme environments. So why did we do this? Because this allows our outer membrane to be flexible, heat resistant, acid resistant, and also it is self-healing, so it can automatically repair itself, and it blends in with the other aspects of our living system. Also, go back. On the top right, we can see a cross section of how our membrane looks. It has sensors embedded to continuously measure external stuff. So now another important factor that we have to consider is the extraction and packaging of gases, specifically nitrogen and oxygen. So we will have a central filtration system that comes right after our outer membrane. And in this process, to summarize, it'll basically separate all the gases. So it'll separate carbon dioxide and nitrogen first, and then the carbon dioxide will be broken down into oxygen. And any acid that we have specific places where acids can enter, and those will be broken down for fuel. This is an image of our robot that will help collect raw materials from the surface. We will be getting some of the robot parts from Vulture Aviation. For the refinement of our materials, for manganese sulfide, we'll be using lead leaching with the sulfuric acid that exists in the atmosphere. We'll be doing the same process for nickel. For titanium, we'll be doing a chloride process instead. Next. We already talked about this. So we have two different designs for our shuttles. The top two designs are smaller and they're used for transportation of raw material from the ground of the Venus's surface to our settlement. This can transport people as well within the settlement. The bottom one is used for long distance transportation to the inner orbits. For the spaceships we just showed, they're made of materials that are acid resistant, heat resistant, and thermal protected. So for some of our contingencies, the main two include conflagration and life support failure, and we have systems in place for those. We also have a priority system to handle any emergencies. For maintenance and interaction, in the top left corner, we have the structure of our holographic control room, one central control room that is controlled by humans. And on the top right, we have an image of our maintenance robot that's made of materials specific for Venus's environment.
And now after so many design introduction, we can finally get to our construction process. So for the construction process, we'll break it into 6 steps, from 2077 to 2093 span of 16 years, we first use a construction shack, and then we build the structures and we wrap around it, building multiple layer on it. And finally, we build the central layer, and we will then land it into the destination we mentioned in the first slide, and it will use all the buoyancy force and all the structure to keep a balance in the atmosphere.
Looking into Orania's business operations, this is going to be our first nanotechnology, the target membrane. Is going to follow this wheel as a process. We're going to get the materials done, then its exact mechanism, then marketing partnerships, et cetera, et cetera. Here we have the data and information on how exactly we're going to sell it to people, and it will also be sold as intellectual property. Here we have our revenue for our carbon printing. We have the revenue on the left side, and we have our production capacity right here. Basically, the gist of it is we're going to use our membrane tech to take in the carbon dioxide, and then we're going to use carbonate electrolysis to separate the oxygen and the carbon, and then use the solid carbon for whatever processes we need. Here's our operation scaling. I'd like to draw attention to our revenue growth, and overall, this is just how our business operations are going to grow throughout our settlement's lifetime. Naturally, when it comes to producing things, we're also going to have to move and store them. So we have the appropriate docking mechanisms. We have androgynous docking systems to allow for docking in any orientation, considering the wind speeds in Venus's atmosphere. And we have warehouses connected to that. Warehouses will have casks tracked by RFID tags. And along with that, we're going to have autonomous forklifts. And the reason they're mounted to the floor and the roof is so that they can be as space efficient as possible. Next up, we're going to have industrial facilities. This is the general layout for an industrial facility at one manta ray per se, but it's going to be identical at each structure. Same is true for our research facilities, and that's going to be our main area where we grow and test our membrane technology. This is our schedule. We're going to have IOC by 2090, and then we're going to have whatever's appropriate after. And here's our revenue streams.
Last up, we have our compliance matrix over here. But before we finish, I want to talk briefly about what makes Urania the settlement that you guys should invest in as a foundation society. Of course, we've heard from a lot of great settlements today, but at the end of the day, what matters the most is being able to not only get a structure that works very well with Venus's winds, but something that adds some creativity and ability for the foundation society to continue to expand. A manta ray by itself is an idea that will allow us to revolutionize the way that we look at spacecraft in the future. And by applying these ideas of the way that things move through water to air, we are able to continue to progress. Some key things I want to draw your attention to before we finish are, first of all, our great food systems and contingency plans. Though we weren't able to cover everything in detail, every single risk that we could imagine for all of these systems has been documented and considered. And overall, I want to thank you guys for taking the time to listen to our presentation. And we're looking forward to hearing your questions. Thank you very much.
Thank you very much, Rock Donald. Thank you. All right, let's bring up the rest of Rock Donald presenters. Please take a seat. Who from Rock Donald would like the clicker? Get us going. Everybody, let's get settled, please. Shh. That is magic. All right, we are going to start down at the end with Ty and move towards me. Kelsey, the same 2-minute reminder, please. Go ahead and start.
I apologize. I'd like to start with just 2 clarifying quick questions here. The first is that external membrane actually a living surface? And if so, what is the nutrient media that keeps it growing?
So the membrane located on the outside of our aircraft or structure is a living organism. It is based on the 6 DNA bases that run on the outside, as well as the 4. It's
replication allows us to, anytime it is injured or it is damaged by any part of the actual environment, to replicate the part and continue on living with a minimal amount of water and small nutrients required.
So what's actually stimulating that genetic expression?
So the do you have?
We're so sorry about that, but the membrane is not a living organism. So just to clear that up, it's not living.
So the second question I wanted to clarify, I'm sorry, is I'm not actually sure if this is like the space station in falling orbit, or if this is a plane with wings, like we keep saying.
It is more similar to a mix between a blimp and an airplane, as it has helium systems that keep it buoyant. However, it also has propulsion systems, so it can ride the lift through the atmosphere.
All right, can you please take me to slide 26, please? I have a question about the capacity of your black water management system. On the right-hand side, it lists that your capacity is will support 150 people at the full load. What happens to the other 350 people on the settlement?
So part of the cool thing about our settlement is that it's actually 3 separate mantas. So each manta ray has around 200 people at full capacity. And on a normal daily capacity, we like it to run at around a 70%, so 150 people.
Okay, thank you so much for the presentation. Could we please go to slide 30? So the first operational concept of the RFP pretty clearly outlines that you must identify a maintenance and contingency strategy for some of your systems. I'm a little bit concerned because, again, if maybe there's some clarification here on what are the contingency strategies for the excavation bot in particular, because I didn't see that on the slide of contingencies.
There are many different excavation bots on one facility. So there's not just one single excavation bot on one mining facility. There are multiple of them. And in case there is some catastrophic failure on one of the excavation bots, our shuttle, the smaller shuttle that can go down to the surface, has a small crew station that which can fit up to 5 crew members, 5 humans that can come down to the surface and can physically repair the bots if need be.
So can we go to slide 35 for me? So you're saying that the humans themselves will go down, and that's your contingency plan. And what will they do? They have the equipment needed to fix the robot. Can you speak to that a little bit? What's the next step there?
So humans coming down to the surface is one of the last steps. It's an ultimate contingency, like it's the last step if everything else fails. First, we have multiple different robots on the surface that can take over the job of the robot that has failed. But if the contingency continues to exceed the limitations of that particular solution, then the humans can of course come down and fix that issue.
Okay, thank you.
I'm not sure what slide this is, but for the evacuation, can you go to that slide? I'm not sure which one. 21. Can you go a little bit of more detail there? I think I'm a bit confused on what's going on in the diagram.
So in the an event of an emergency, like say there's a radiation breach or a depressurization, there's immediate systems, so the multimodal alarm system that runs through the entire station, depending on which one it is. People move very quickly to their assigned shuttles and their shuttle bays. The shuttles are let me see. They've been reconfigured from the mission systems that go down to the surface to do whatever their purposes were. I don't remember what that was. Once everyone's boarded,
the shuttles actually leave the station and then try and head for the next, the other two stations, whichever one's closer.
Okay, so they just go to the next station.
Yeah.
Okay.
Okay, I got another two-part question. Maybe overdoing my due, but I'm gonna. Okay, page 37, please. And actually, this is one question per each page. I got 2 pages. 37. It's your construction sequence. There we go. Oh, almost. There we go. Okay, so I'm looking at your notes here, and you've got a construction shack, and we appreciate that, by the way. We always like to see that. And you're in low Venus orbit. Okay, so that tells me you're at orbital altitude and orbital velocity. So the first question, and wait for the second question to answer the first. The first question is, what is your orbital altitude and what is your orbital velocity? And if we go to page 38, it's just the next, okay, I guess it's your next to last picture there. You're coming from orbit down into the atmosphere at your target altitude and velocity. Most vehicles that do that, they use an aerobraking method, which means you're going to change velocity for heat. So the question here is, what's your heat shield, or do you have a different method than aerobraking to go from orbit to your final atmosphere? So orbital altitude and velocity, and how do you get down without being cooked?
Please make sure you're using different speakers for different questions. Thank you.
First of all, our operating altitude will be 56 kilometers off the ground, and our orbiting speed is around 256 kilometers per hour. Now, how we brake and how we, in fact, counteract the wind movements that are there on Venus is that there are muscle fibers inside our wings.
Do those muscle fibers withstand the heat of re-entry?
The heat of the entry,
And how hot are you going to get?
I don't have a specific number on how hot they can get, but if we awarded a contract, we can research upon that and provide you a number.
Oh, well, you definitely might want to look at that. The shuttle leading edges were at 3,000 degrees Fahrenheit, and they use a carbon-carbon reinforced material. So I'm concerned. I like the idea,
Yeah.
but I'm concerned when you get down to altitude, you're going to be a toasty marshmallow.
Yeah.
Thank you.
Okay, so let me.
You're done.
All right, we're done.
Thank
Thank you so much. Can I go to slide 14? Okay, so I have also a two-part question. So down here in the bedroom permanent and transient residence, 871 square meters. Can you tell me what that 871 square meters is?
That's, I actually forgot to change it. It's actually 871 square feet.
Okay, that's it for me because that was a 10,000 square foot one bedroom apartment. Nope, that's okay. Shane or Nicole? Shane?
Sure. Can we go to slide 20, please? 20. At 20? Yeah. 26. Sorry, can't even read my own handwriting. There we go. 3-stage wastewater management for the black water. Interesting mechanisms that's taking place here. In your second treatment, it's going through a number of different steps. And the one that really stuck out to me that seems like a pretty high power step, and also I'm confused about, is the electrolysis in the secondary treatment. Very quickly, could someone just explain to me what's the decision behind doing this?
So to clarify, it's about it being in the secondary treatment and not the tertiary.
Well,
So
not if it's secondary or tertiary. Why is it there?
why is it just hydrolysis?
Yeah, why electrolysis?
So we chose hydrolysis because we realized that a lot of the feces water and black water that we typically.
Okay, well, thank you.
All right, thank you so much, Brock Donald. Thank you very much. Presenters, come on up. Screen one.
Thank you very much, Rock Donald. You know the drill. Please could everyone crunch right in 3 rows, please, with the tallest at the
All right, just a second. While they're going on, Theo, keep going. Interrupt me if you need to. Right after this, right now, can I have that list that I put down somewhere? Thank you. Beautiful. We're going to take all 7 judges, 1 head compliance judge, that's you, Jack, and the 4 head CEOs to the Foundation Society headquarters. For those of you that don't know, that's where several of us have been hanging out. That will be closed to everyone except for the 7 judges, 1 head compliance judge, 4 head CEOs while we go through judging.
Thank you very much, Rock Donald. If you could all try to crunch in a lot more, please. I prefer we avoid people's kneeling at the front. If we can just have all standing in 3 rows, please. So if you folks here just dive towards the end over here, we've got someone in the back. Do you want to hide particularly? Okay. Bring on to the end, please. Can you be less of a huddle and more of a line? Thank you. Could you maybe push slightly back, more towards the back? I know it's really tight back there. I'm just trying to flatten this out a little bit. And if you look, just tuck right in and make really close friends with people. It's going to get, I'm sorry, it's going to be a bit tight, but you're quite a wide company. Just, sorry, you, yeah, perfect. Thank you.
Pues bueno, ya estamos aquí terminando las presentaciones. Y bueno, vamos a ver qué es lo que deliberan los jueces. Proyectos muy interesantes, realmente, obviamente, pues se nota el trabajo de los chicos que han estado realizando estos días. Y bueno, vamos a tener un break para que los jueces deliberen cuál va a ser la compañía ganadora. Muchas gracias a todos los que nos están comentando aquí. Y pues bueno, para comentar, bueno, vamos a llegar casi al cierre de estas presentaciones. Nos emociona bastante pues ser testigo de estas ideas increíbles, de mucho trabajo en equipo, de creatividad, muchos nervios, me imagino, pero sobre todo de pasión por el espacio y por construir un excelente futuro. Y bueno, unos momentos más será la premiación. Pero mientras tanto, queremos aprovechar este espacio para conversar con alguien muy especial. El día de hoy nos acompaña, nos hizo este gran favor también de estar aquí con nosotros. Alejandra Estela, fundadora de Andrómeda Astro Shop. Ella es una gran aliada también de la divulgación científica, astronómica en México. Además, una gran amiga también de Spaceport MX y emprendedora también. Vamos a darle la bienvenida. Hola, Alejandra, ¿cómo estás?
Hola, ¿qué tal? Buenas tardes, ¿no? Muchas gracias por
Sí, buenas
invitarme
tardes.
acá
a la transmisión, de que aquí estoy, mira, con los nervios de punta, súper emocionada, siguiendo muy de cerca, ¿no? Todo lo que desarrollaron estos chicos, la verdad es que es súper sorprendente, me han dejado con el ojo más que cuadrado, por todo lo que han presentado, de verdad que no me imagino cuánto trabajo hay detrás, ¿no? De cada uno de estos proyectos, todo lo que tuvieron que estudiar, de todo lo que han tenido que enterarse, pues estar al día, ¿no? Con todas estas cosas que, bueno, al menos yo ni siquiera me imaginaba que se podían hacer. Entonces, sí ha sido también muy, muy educativo el ver todos los proyectos presentados y pues la verdad es que te llena de orgullo ver que los chicos mexicanos están a la altura o sea, de cualquiera, ¿no? En el mundo. Sí,
Exacto.
sí,
Fíjate
ha
que
estado muy padre.
este proyecto, como tú lo dices, a veces pudiera ser pues decir, es una competencia ya, ¿no? Pero todo lo que hay detrás de los proyectos de los chicos para llegar a este punto es una preparación de bastantes meses, al igual que los chicos que están al otro lado del mundo, ¿no? Los que vienen de Europa, los de la India, etcétera. Entonces, aquí es donde te das cuenta que realmente hace más visibilización de los chicos, ¿no?
Ujú.
De los chicos, del trabajo que están haciendo. En
Sí,
este, en este ejercicio, ¿estás oyendo la transmisión ahorita?
no, no se escucha.
¿Verdad? Ah, ok,
No.
es que yo todavía lo estoy escuchando aquí.
Ah, qué
Ahorita van
padre.
a regresar, están en el descanso, ahorita van a regresar ya, como nos dicen, está la deliberación de los jueces. Pero
Ujú.
imagínate, este proyecto bueno, esta misión específicamente es una misión para el 26, es como si estuviéramos en el 26 de julio del año 2075. O sea, la proyección hacia el futuro, ¿no? De lo
Ujú.
que va a ser la exploración espacial, ¿no? Entonces, les decía a la gente en un principio que las 4 compañías son contratistas en este caso, para la Foundation Society, invitando a que preparen un proyecto con las siguientes características, porque todo es súper detallado técnicamente, como ya lo pudieron ver, es técnicamente detallado, las preguntas que les hacen, ¿cuánto cuesta? ¿Por qué esto? ¿Por qué lo otro? Porque así es realmente el proceso de contratación de una empresa, ¿no? O sea, desde
Exactamente,
los
como si de verdad estuvieran defendiendo un proyecto que ya lo van a vender, ¿no? O sea, ya está bien estructurado. No, hombre, está padrísimo, como ensayo, ¿no? De lo que podría ser su futuro.
Exacto, es una simulación de acercamiento a la industria espacial, ¿no? De cómo puede ser esto. Y obviamente la gente puede decir, bueno, es que es en el 2075, pero no, es
La vuelta
algo
de la
que
esquina.
se proyecta, exactamente, que ya está a la vuelta de la esquina. Y en esta misión específicamente estaban en Venus, entonces es extraer gas como nitrógeno y oxígeno
Ujú.
de la atmósfera, es lo que estábamos viendo, cómo extraen el gas para llevárselo a la nave
Y poder
y
aprovechar.
procesar algunas materias primas directamente también de la superficie de Venus, ¿no? Y exportar estos recursos a la órbita de Venus y el sistema solar interior. Entonces, este reto es un reto porque tienes que solucionar muchas cosas, ¿sí?
Así es.
Muchas cosas, técnicamente, la navecita, los robots, o sea, toda la infraestructura, dónde van a vivir las personas, qué van a hacer para entretenerse en esa órbita, etcétera. Entonces, es un trabajo complejo técnicamente, es un trabajo innovador,
Que
porque es
requiere
algo que
mucha
sí, que es algo que requiere mucha atención, mucha concentración y sobre todo si lo quieren hacer lo más real posible y con el menor costo posible.
Sobre todo eso, ¿no? Yo creo que esa es la parte crucial de todo el proyecto, porque tú puedes diseñar algo muy padre o que solucione muchos problemas, todo, pero si no es costeable, pues desde ahí ya, ya nos quedamos, ¿no?
Exactamente.
Sí,
Y tú,
ujú.
sabemos que uno de los integrantes es tu sobrino, ¿no? También.
Sí,
¿Quién
sí, mi
es?
sobrino Esteban Rivera.
Ese es Esteban, que ha trabajado muchísimo también por estar dentro
No
de la
tienes idea.
competencia. Sí, claro.
Sí,
Detrás de cada chico hay una historia.
una historia, exactamente, sí es lo que pensaba. Uno no sabe cuánto esfuerzo, cuánto sacrificio, cuántas historias hay detrás de cada uno de ellos y sobre todo, o sea, no es por querer hacer como drama, pero pues tú sabes que pues Chiapas es de los estados como un poco más olvidados, ¿no? Rezagados, en el que este tipo de temas, a este tipo de temas se les presta muy poca atención y por lo mismo hay muy poco apoyo. Entonces, pues todos yo creo que han tenido que hacer, no me imagino, si con Esteban, o sea, tuvimos que hacer un montón de cosas para que pudiera irse, y no solamente hablando de lo económico, porque no sé si supiste que le negaron la primera visa.
Exactamente, sí,
Hizo
sí,
el
sí.
trámite de su visa y se la niegan. Entonces, él ya se estaba dando por vencido desde ahí. Y pues yo le dije, no, a ver, espérate, hay que intentarlo otra vez. Y me decía él, no da tiempo. Sí da tiempo. Ahorita vemos qué movemos, cielo, mar y tierra, pero yo pienso que todavía estamos a tiempo de poder lograrlo, ¿no? Y contra todo pronóstico positivo, pues otra vez hicimos el intento y mira, se pudo.
Claro, se pudo. Y creo que es importante como hacer hincapié en esto, ¿no? O sea, realmente todos los chicos han hecho un esfuerzo por
Ujú.
ir a esta competencia, por estar ahí, por visibilizar a su estado, por visibilizar a su comunidad, por visibilizar a México, que empezamos a entrar en estos temas espaciales, que como dices tú, muchas veces mucha gente no cree todavía en el
Ujú.
potencial que tiene, pero bueno, o sea, lo estamos viviendo en este momento donde estamos tratando de insertar a Latinoamérica en un tema espacial, ¿no? Esta competencia lleva más de 40 años realizándose en Estados Unidos y es la segunda generación de mexicanos que va.
Ah, ok,
Entonces,
ese dato no me lo sabía.
entonces estamos hablando de
Sí.
que nos falta mucho por trabajar en la socialización de estos temas, ¿no?
Ujú. Sí, sí, totalmente. O sea, imagínate, 40 años ya de esto y apenas la segunda generación, pues
Exacto.
cuántos años tenemos como por así decir atrasados, ¿no? Pero pues qué
Ajá.
bueno que están ustedes para poder hacer pues visibles este tipo de oportunidades, ¿no? Y
Sí,
apoyar a los chicos y brindarles las bases para poder entrar en este mundo. La verdad es que hacen una labor súper, súper, súper padrísima. Le decía a Katy, te admiro porque de verdad, o sea, la labor que hacen ustedes está muy bonita, muy padre, o sea, va más allá de, como de, siento como que también, o sea, lleva una parte de ustedes, ¿no? De una entrega personal, o sea, un compromiso de
claro.
querer hacer pues que los chicos entren en todo este mundo, en todo este ambiente. Pues yo los he visto, los encontré en Chiapas, en el evento
En
del año
Querétaro.
en Querétaro, ajá, sí los he visto que están pues en muchos lugares trabajando y pues detrás de todo, de todas esas presentaciones o lugares a los que van, pues también hay un gran esfuerzo. Viajar, estado, estar procurando fondos, apoyos, todo eso es complicado y pues qué padre. La verdad es que muchas felicidades a ustedes también por todo el trabajo que están realizando y por hacer que pues nuestros chicos puedan estar ahora, ¿no? En esta competencia. La verdad es que, híjole, le digo a Esteban, yo estoy más emocionada que tú. Le decía
Es que,
rato, yo creo que yo estoy más
¿sabes?
emocionada que tú.
Claro, a nosotros nos da mucha emoción de ver a los chicos, ¿no? ¿Por qué? Porque muchas veces a lo mejor ni se la creen, ¿sabes?
Sí.
No creen que puedan llegar ahí. Tenemos un chico que es de la comunidad de ICOTS de Oaxaca, que es una pequeña comunidad allá, pero que está estudiando en ¿cómo se llama? En Tuxtla. Entonces, toda su comunidad, el apoyo de la comunidad es de lengua originaria, pues lo apoya, ¿no? Entonces, es el ejemplo de cómo en los rincones de México, en cualquier rinconcito, hay talento y que busca ser visibilizado, ¿no? A veces el talento está, pero a veces no las oportunidades. Sí, a veces no las oportunidades. Y eso es lo que nosotros buscamos, ¿no? Tratar de que el espacio, de la democratización del espacio, que todos puedan hacerlo, que todos puedan ir. Por eso estamos en friega así como que échenos la mano con las becas, gobierno, municipios, para poder becar a chicos que realmente necesiten esa oportunidad y que tengan ese talento y que, como ahorita lo estamos viendo con varios de ellos, con Anet, que es de Chicomucelo, que de otras comunidades que también son los chicos que a veces se tienen que trasladar 2 o 3 horas de su comunidad hacia Tuxtla, ¿no?
Hasta más.
O hasta más. Entonces, acercar estas oportunidades a ellos es integrarlos a este tema del desarrollo, de la innovación, y que no porque estés en una comunidad de alguna manera alejada, quiera decir que tú no puedes acceder o que tú no puedas participar, pero sí se puede, claro, que cuesta, ¿no? Y lo que cuesta es el asesoramiento de la gente real que trabaja en la industria espacial, que ellos son los que están mano a mano con los chicos, asesorándolos para poder ir a la semifinal y después llevarlos a esta competencia en Florida, ¿no? Entonces, no es por dinero, no es ni siquiera que uno quiera cobrar los millones por los chicos, no, sino que es el asesoramiento. Es el asesoramiento, es el traslado, porque tenemos que andar de aquí para allá viendo quién quiere, pero bueno, si no, pues buscar que todos los chicos busquen la manera de solventar este gasto de la competencia, ¿no? Y allá para ir a Florida, pues obviamente sí hay, todavía es remar contra viento y marea en muchísimos aspectos, ¿no? Pero al final de cuentas sabemos que unos chicos no lograron conseguir la visa, aunque están en la selección, lamentablemente no se pudo, pero muchos otros sí, y pues bueno, todos están representando a México y a Perú, ¿no? En este caso, pero cuéntanos un poquito, ¿no? ¿Qué hubo algo que te sorprendiera o te inspirara especialmente de las propuestas que viste?
Me llama mucho la atención las propuestas que hacen los chicos para poder precisamente extraer estos elementos, ¿no? O sea, el nitrógeno, el oxígeno, sobre todo de un compuesto venenoso de Venus. Porque sabemos que el ácido sulfúrico, pues es veneno, ¿no? Entonces,
Claro.
o sea, cómo ellos están proponiendo que a partir de algo que es venenoso, van a poder obtener cosas que van a beneficiar a la población, ¿no? Que esté en estos hábitats. Esa parte creo que es la parte que más me ha sorprendido y llamado la atención, porque pues muchos tenemos el concepto, ¿no? O sea, de que, o sea, ves una botella de ácido y eso es como de ahí puedo obtener algo que sea beneficioso, ¿no? Entonces sí se me hace como un proceso muy creativo, se me hacen propuestas muy interesantes precisamente creo que antier, cuando les dijeron, cuando les dijeron que el proyecto iba a ser en Venus, yo traía la idea de que iba a ser como en el concurso pasado, que iba a ser en Marte.
Ajá.
Y me cuenta Esteban, no, fíjate tía, que ahora va a ser en Venus. O sea, desde que me dijo Venus, yo me quedé, ¿cómo? O sea, no es posible, o sea, es el planeta más caótico del sistema solar, ¿no? La presión, la temperatura, los elementos presentes en la atmósfera de Venus, o sea, es totalmente venenoso, corrosivo, o sea, no pudieron haber escogido un planeta más feo,
más hostil.
Más hostil para llevar a cabo esto, y entonces Esteban me empezó a platicar, pues es que encontramos un artículo de la NASA que precisamente dice que a 50 kilómetros, o sea, estamos como en un área segura para poder extraer estos elementos. y estamos pensando hacerle así y acá y allá. Y me quedé así, wow. Dije, o sea, no, ¿cómo? Me voló la cabeza. O sea, incluso, o sea, hizo que yo me pusiera a investigar acerca de esto, porque yo no sabía que a
Claro.
50 kilómetros uno ya estaba como en un área segura para poder hacer este tipo de trabajos. Y creo que te digo, esa parte es la que, como que la que más me ha sorprendido.
Sí, es interesante cómo obviamente, pues lo más cercano podría ser la Luna, Marte, etcétera, pero las misiones no se van a detener ahí, ¿no? O sea, no se van a detener en los planetas más cercanos de alguna manera, sino, por ejemplo, ahora toca Venus. ¿Qué solución le daríamos a Venus para poder extraer ese producto que pues de alguna manera va a beneficiar a la humanidad, ¿no? Exactamente, nos va a ayudar incluso a terraformar, o simplemente para combustible, etcétera, ¿no? Entonces, el diseñar, obviamente, un planeta, estar en un planeta hostil como Venus, pues no podemos estar mucho tiempo abajo, sino simplemente podemos estar, como dices tú, a 50 kilómetros para poder sobrevivir en primer lugar, ¿no? Y ahora, ¿cómo extraemos esto y cómo nos lo llevamos incluso, ¿no? Entonces, estas soluciones que dan los chicos es el preámbulo para imaginar mil cosas, ¿no? Y cómo la creatividad del ser humano nos ha llevado a sobrevivir en los ámbitos más hostiles, ¿no? Si aquí mismo en la Tierra, ¿por qué no allá afuera, ¿no? O sea, obviamente la gente que vaya a Venus, pues no va a regresar porque va a empezar a vivir en estos ámbitos.
Exactamente, pues la historia de la humanidad ha sido siempre evolución, ¿no? Entonces ahora tenemos que aprender a evolucionar, pues ya no dentro del planeta, ¿no? Sino fuera de él. Y pues, o sea, contar con todas estas ideas, o sea, de los jóvenes y todo, pues se me hace muy interesante las propuestas que hacen, ¿no? Para poder llevarlo a cabo. Sí, son cosas que, pues, o sea, hasta hace un tiempo todavía yo creo que eran cosas impensables, ¿no? Pero pues también estas mentes frescas de los chicos, porque también me preguntaba, ok, o sea, ¿por qué invitar a los jóvenes, ¿no? A participar en ese tipo de proyectos? Pues es precisamente por eso, porque ellos traen como muy frescas las ideas, no están todavía como con paradigmas metidos, ¿no? Como nosotros ya los adultos, de que no, pues esto de entrada no se puede. O sea, sí tiene la mente más abierta y todo, y entonces dije, pues tiene mucho sentido precisamente, ¿no? Ocupar mentes jóvenes para poder desarrollar todas estas ideas y dar soluciones a todas estas problemáticas, ¿no? Que se van a venir cuando todo esto tenga que volverse una realidad, ¿no? Para nosotros, para la humanidad.
Exactamente. Y ahora imagínate chicos de 16, de 17, 20 años solucionando cosas del futuro de la humanidad, ¿no?
Sí,
Entonces,
sí, como en las películas, ¿no?
Exacto, es un trabajo arduo, es un trabajo sí de imaginación,
Sí.
con un rigor técnico muy interesante,
Aparte,
como
¿no?
si fuera, exacto, el rigor técnico de realmente una empresa que está inmersa en industria espacial, ¿no? Entonces, es como, ¿por qué los chicos, como dices tú, o sea, las mentes jóvenes empiezan a imaginar porque ellos son la semilla, porque a lo mejor a ellos sí les va a tocar ver todo esto, a ellos sí les va a tocar estar ahí, a sus hijos y a sus nietos. Entonces viene esa generación que ya va a estar hablando acerca del espacio, acerca de Venus, acerca de Marte, acerca de cómo podemos irnos al cinturón de asteroides, que ahora lo vemos solamente a través y de las imágenes. Bueno, tú eres también astrofotógrafa y yo creo que es fascinante descubrir este mundo a través de la lente, ¿sí? De ver qué habrá más allá y aún así el tener que estudiar de cada planeta, de lo que está allá afuera y que desconocemos bastante, pero ahora estos chicos, la visión de ellos, e incluso más de ver ese planeta, es de cómo vamos a vivir en el planeta, ¿sí? De cómo vamos a sobrevivir allá afuera. Entonces, creo que, ¿cómo es tu perspectiva como astrofotógrafa de esta situación?
Uf, fíjate, ahorita precisamente estoy viendo mi imagen en la transmisión y veo la foto que tengo atrás
Ajá.
de la galaxia de Andrómeda y pienso, todos esos puntitos que vemos ahí, todas esas estrellas, son precisamente sistemas solares en los que precisamente puede haber miles de posibilidades de planetas muy parecidos a Venus, a la Tierra, a Marte, a todos los que tenemos aquí, ¿no?
Claro.
Entonces, pensaba, pues, o sea, si podemos solucionar el poder vivir en Venus, pues cuántas posibilidades hay ahí atrás, ¿no? Exactamente, ¿no? De poder habitar en algún planeta que esté rondando cada una de estas estrellas, cada uno de estos soles. Las posibilidades son infinitas. Entonces, pues, o sea, sí es muy interesante ver, o sea, cómo se le da solución a este reto que les pusieron, ¿no?, a los chicos, porque representa el modelo a seguir para solucionar todo lo que está ahí atrás, todo lo que está afuera en el universo. Entonces, sí está bien padre, porque te digo, te vuela la cabeza el hecho de pensar que pues cada una de esas estrellas puede ser nuestro hogar futuro, ¿no?
Exacto, ¿hasta dónde vamos a llegar? ¿No? Tú ya te fuiste más allá todavía, ¿no? Detrás
Sí,
de
del sistema solar.
diferentes soles, en diferentes galaxias. Y fíjate que incluso el estar pensando en resolver los problemas de la vida futura del ser humano o la sobrevivencia del ser humano en otro tipo de ambiente fuera del planeta, nos ayuda a bajar esas soluciones con la tecnología hacia lo que está aquí en la Tierra todavía, ¿no? Muchas
Claro.
veces dicen que están pensando en solucionar cosas allá afuera cuando hay mucho que solucionar en la Tierra, pero ese pensar o ese imaginar las soluciones que tendríamos fuera del planeta ayuda a desarrollar y ha desarrollado tecnología a base de
Aplicable.
tecnología espacial que se aplica en la Tierra. Entonces,
Sí.
sirve para todos.
Exactamente, sí, fíjate que hay una controversia muy, muy grande, por ejemplo, con lo que se gastó en las misiones para ir a la Luna, que fueron miles de millones de dólares no invertidos. Y precisamente luego te topas con personas que dicen, o sea, como que qué sentido tiene invertir a estar mandando misiones a tal planeta, a la Luna, o pensar en regresar a la Luna y todo. Pero lo que pasa es que muchas veces es el desconocimiento de que precisamente ese tipo de misiones se ha tomado mucha de esa tecnología para aplicarla aquí en nuestro diario vivir, ¿no? Por ejemplo, no sabemos muchos que un simple panel solar fue diseñado para poder aprovechar la energía solar allá arriba para poder proveer a los satélites, a la ISS, a las ondas, ¿no?, que se han ido más allá del sistema solar, ¿no?, las Voyager, por ejemplo. Entonces, o sea, de todo ese desarrollo de esas misiones se desprende precisamente mucha tecnología que ha sido pues muy útil, ¿no?, para nosotros aquí en la Tierra.
Tan simple como la camarita del celular.
La cámara del celular, el GPS,
Los
el mismo
pañales.
celular, o sea,
Ajá.
las comunicaciones, ¿no? ¿Qué se me ocurre? Pues los mismos
Los
trajes, ¿no?
pañales también.
Materiales que se utilizan
Ajá.
para los trajes de los astronautas, todo eso, ha servido para beneficiar a la humanidad aquí en la Tierra. Entonces, ¿quién dice que no, con el desarrollo de estos proyectos podemos obtener muchas cosas para aplicarlos aquí mismo? Imagínate, si estos chicos están proponiendo poder extraer materiales beneficiosos para la humanidad a partir de algo que es tan tóxico, pues entonces a lo mejor esa misma tecnología se puede aplicar aquí, por ejemplo, para aprovechar el CO2, se me ocurre, ¿no? O sea, que en algún
Exactamente.
momento
Ajá.
podamos aprovechar o dividir, ¿no?, en sus elementos el dióxido de carbono que es tan malo, ¿no?, para nosotros, pero que entonces se pueda volver algo beneficioso, ¿no? Entonces,
Incluso para hacer combustibles un poco más amables
amigables,
con el
ajá, sí.
ambiente. Exacto. Entonces,
Ajá.
hay muchas cosas que a final de cuentas, quieras o no, estamos involucrados en la tecnología espacial, estamos involucrados en el desarrollo de tecnología para seguir sobreviviendo, a final de cuentas, ¿no? Para tener herramientas, para seguir sobreviviendo, para seguir evolucionando, y todos estamos inmersos en esto, o sea, todos, porque quizá algunas personas, como dices tú, podrán decir de qué nos sirve, o por qué yo tendría que ir a una competencia de diseño de hábitats, o yo no puedo porque mi carrera, no, o sea, todos podemos participar de esto, ¿no? Incluso, como veíamos en algunos de los proyectos, cómo tenían diseñado el área especial para la gente que vive ahí. Es súper importante cómo vas a tener viviendo a los astronautas, a la gente que está trabajando ahí. ¿Por qué? Porque no tenemos como esa visión, o no nos podemos a pensar que, bueno, aquí pues te aburres, te sales a tomar el aire, te vas a la plaza, te vas a leer, te vas a nadar, lo que
La
tú quieras,
playa,
¿no?
la montaña,
A
¿no?
la playa, ajá, para desaburrirte, para descansar, para lo que tú quieras. Pero cuando estás allá, ¿a dónde vas a salir? No puedes, te mueres, te quemas, de lo que tú quieras, ¿no? Entonces, tienen que diseñar un espacio que sea amable, amigable para las personas que están viviendo ahí, porque vas a estar meses, años en aislamiento, ¿sí? Entonces, es algo que la psicología estudia. Entonces, vamos a necesitar psicólogos espaciales, vamos a necesitar quien regule las cuestiones de la legalidad allá
Legales,
arriba,
ajá,
¿sí?
sí,
De
claro que
que de si se comete un delito, de quién va, cómo se va a hacer, o sea, cómo se va a legislar el espacio. Necesitamos
todas las
abogados
disciplinas.
espaciales,
Ajá,
todas
todas
las
las
disciplinas.
disciplinas sí tienen que estar involucradas en estos proyectos, sí es correcto. Ajá, la
Desde
salud,
salud, medicina espacial,
constructores, ajá, arquitectos, como dices tú, psicólogos, todos, todos,
artistas,
todos.
diseñadores. Porque
Ajá,
imagínate, algo de las pláticas que a veces tenemos es las nuevas tradiciones que esto va a traer, al final de cuentas, culturalmente, socialmente hablando, como que las nuevas tradiciones que se van a crear, las nuevas culturas a partir de que el humano se va, ¿qué se va a llevar? Se lleva lo que es, ¿no? Su cultura, su tradición, pero van a surgir otras nuevas a partir del lugar
claro.
donde... O sea, es todo todo un mundo de posibilidades, y todas las carreras entran en esta industria, ¿no? No solamente lo
Claro.
técnico, no
Ujú.
solamente lo que tiene que ver con una estructura, los físicos, como dicen, no, todos.
Sí, maestros, imagínate, o sea,
Educación espacial.
cuánto vamos a necesitar, ¿no? De los educadores, sí, de todos, sí, prácticamente, o sea, es todo. Y cómo se van a ir adaptando estas disciplinas, pues, a las nuevas situaciones, ¿no? Sí, porque como bien dices, o sea, a futuro, aplicar la ley, pues no va a ser lo mismo que lo que es ahora. Sí, el entretenimiento para nada va a ser lo mismo. O sea,
Los deportes.
y los deportes, ajá, y es algo a lo que nos tenemos que ir adaptando, ¿no? Yo creo que el éxito del ser humano es precisamente ese poder de la adaptación. Porque si no tuviéramos esa capacidad de adaptarnos a lo nuevo, a los cambios, imagínate, ajá, que quisiéramos seguir, por ejemplo, comiendo carne cruda, como, como,
Imagínate.
como lo hacían los primeros hombres, ¿no? Los primeros habitantes de la Tierra, pues entonces estaríamos fritos, ¿no? Ahorita. Y es esa capacidad la que nos va a permitir precisamente adaptarnos a los nuevos retos, a las nuevas situaciones que tengamos que vivir. Ujú.
Y como seres humanos, pues, digámoslo en palabras más coloquiales, pues somos tercos, ¿no? Y si decimos para allá vamos, para allá vamos. Entonces, a final de cuentas, creo que estos temas, por eso nos gusta mucho socializarlo con la gente, porque es un tema que pensamos en Spaceport que debe ser de tema de café, de tema de la cena en tu casa, ¿no? Y sabemos bueno, yo hablo por mí en este momento, pues yo soy comunicólogo, no soy astrónomo, no
Científico.
estudié física, no soy científico, y a lo mejor no tenemos las credenciales específicas para hablar de un
Del
tema
tema.
tan
Ujú.
difícil, pero como sociedad nos interesa
Claro.
saber y
Ujú.
dónde nos insertamos nosotros y realmente buscamos la posibilidad de insertarnos de acuerdo a lo que estamos haciendo, ¿no? Entonces, es para todos, no solamente para unos. Y tú como divulgadora, como amante del espacio, como astrofotógrafa, ¿tú por qué crees que estas experiencias son valiosas para los jóvenes?
Pues precisamente porque, o sea, todo este tema de que vamos a tener que, en algún momento abandonar la Tierra, irnos a querer continuar la vida, ¿no? En algún otro lugar del espacio, pues es una realidad, ¿no? Que se viene. Entonces, es importante porque tenemos que hacer conscientes a las generaciones que vienen de la problemática que van a enfrentar. No es como meterles miedo, como le digo a mi hija, ¿no? Porque a veces me dice ella, es que cuando empiezas a hablar de esas cosas me da miedo. Cuando empiezo a hablar de esas cosas, o sea, pienso así como en un futuro apocalíptico o sea, y me entra como cierto temor. Le digo, no es platicar de eso, como bien dices tú, en casa, con esa intención, ¿no? Sino
Ajá.
más bien de volverlos conscientes de que tienen que pensar en cómo solucionar todos esos nuevos retos que vienen adelante. Y entonces, si desde ahorita empiezas a hacer que los jóvenes empiecen a encaminar sus esfuerzos, ¿no? En poder imaginar cómo podría ser la vida fuera de la Tierra, pues yo creo que sí es muy valioso, ¿no? El hecho de tener ya a chicos pensando en esos temas, no solamente en el TikTok, ¿no? En hacer un reel.
Exactamente.
Ajá, en distraerse en otras cosas, sino qué padre que ahorita en este momento hayan un montón, un grupo ahí de chicos que ya están pensando en solucionar estas cosas. Entonces, por eso te
Sí.
digo, sí se me hace muy padre este tipo de actividades, este tipo de proyectos. Y también, precisamente por eso le digo a mi hija, es muy importante la divulgación de la ciencia en general, de todo, de la astronomía, de la física, de la química, porque pues, o sea, necesitamos hacer que haya una base, ¿no? De jóvenes que vengan con estos conocimientos, con estas inquietudes, pues para hacerle frente precisamente al futuro, ¿no? Imagínate que
Sí.
tengamos toda una generación de tiktokeros, de youtubers, o sea, y luego, de aquí a que empiecen a surgir este tipo de problemáticas, ¿no? De retos, ¿qué van a hacer si todos nada más saben hacer videos o reels, ¿no? Tiene que existir esta base de chicos que van a hacer frente a este tipo de problemáticas, ¿no?
Sí, y además se vio mucho, nos decía Katy que se veía mucho con la pandemia, se
Exacto.
vino, bajaron ¿cómo se llama? La cantidad de alumnos que
Ujú.
entraban a carreras científicas, ¿no? A carreras STEM como ingenierías,
Ajá,
etcétera.
sí.
Durante la pandemia bajó.
Sí,
Entonces muchos se dedicaron como a crear, como dices tú, a crear videos, a ser youtubers, etcétera. Pero entonces cuando termina la pandemia, se ve el incremento de otro tipo de actividades, pero una baja en la cuestión de chicos haciendo ciencia o
ciencia.
estudiando alguna carrera científica. Entonces, eso nos deja en una situación complicada porque no se está logrando que la mayoría de los chicos o muchos chicos se interesen sobre las ciencias del espacio, sobre la ingeniería, y eso sí es un problema.
Claro, es preocupante. Por ejemplo, le platicaba también a mi hija, le digo, ¿quiénes fueron los que salvaron la misión, no? Por así decir, con el COVID. Pues los médicos que estuvieron trabajando a marchas forzadas para poder hacer una vacuna. O sea, estamos hablando de que, pues, lo bueno, ¿no? Que en nuestra generación había mucha gente preparada para hacerle frente a este problema. Ok, entonces, pensemos en una pandemia a futuro. Le digo, no sé, de aquí a 10 años, o sea, todos los que están ahorita como jóvenes, o sea, o sea, no se están preocupando por estudiar ese tipo de carreras o hacerle frente a ese tipo de retos. Entonces, viene otra pandemia dentro de 10 años. ¿Quiénes van a solucionar eso, no? ¿Quiénes van a salir a trabajar 24/24 para poder ahora hacer una nueva vacuna? Nadie. Entonces, sí es algo que como sociedad debe de preocuparnos, pero de preocuparnos precisamente para poner manos a la obra, y hacer que pues precisamente las nuevas generaciones se preocupen, se preparen, ¿no? En este tipo de carreras, pues precisamente para hacerle frente a lo que venga, ¿no? Y pues
Claro,
nosotros que
imagínate.
estamos metidos en estos temas, yo creo que sí tenemos una responsabilidad muy grande, que pues tenemos que echarle ganas, hacer pues mucha divulgación, mucho trabajo en este sentido para poder hacer que muchos niños o jóvenes todavía se interesen en este tipo de carreras o de temas.
Sí, despertar esa curiosidad en ellos de que es posible, de que ahí están. Y como por ejemplo aquí tenemos a muchos familiares o papás de los chicos. Un saludo a Noemí Vivas, que es mamá de Paola Penagos, a Tobón Sandra, que es hija de Jean, y que realmente son papás que se preocupan por que su hijo salga adelante, compita, que se enfrente a este tipo de concursos, porque realmente te templa, te curte para la vida, realmente, ¿no? Entonces,
Claro, sí.
si aquí hay alguno de los papás que nos comente que sienten de que sus hijos estén presentando estos proyectos, díganos, porfa, aquí mándenos un mensajito,
Sí,
díganos, aquí está
sería
Net.
interesante, sería muy interesante
Ajá.
saber cómo
El
fue que
punto de
sus
vista,
hijos,
claro.
ajá, no, y cómo fue que que a sus hijos les nació el amor por este tipo de temas. O sea, ¿qué hicieron como papás para sembrar esta semillita en sus hijos? Porque el rol que juegan los papás es súper importante, pero súper importante, desde el hecho de, por ejemplo, llevarlo a un planetario cuando están chiquitos,
Ajá.
llevarlo a no sé, un zoológico, un museo, desde ahí uno ya está sembrando esa semillita de la curiosidad, para hacer, ¿no? Que se encaminen, hacia este tipo de temas, los niños, ¿no? Desde ahí.
Claro.
Entonces sí sería
Y por
interesante
ejemplo,
saber qué hicieron cada uno para que sus hijos estén ahorita allá.
ajá. Mándanos un mensaje, Noemí, ¿cómo te sientes de que tu hija esté concursando?
Ujú.
Aquí estaba Tobón Sandra también. Ángeles, ella es pariente también de Esteban, ¿no?
Sí, es mi tía. Ajá, sí.
Tu tía.
Sí.
Está Manuel Peregrino Martínez Escobar, me imagino que es pariente de Manuel Peregrino. Díganos qué sienten ustedes, pero tú como tía, ¿qué se siente ver a tu sobrino representar un proyecto, podríamos llamarle, tan ambicioso aquí, bueno, ahorita en Estados Unidos, en esta competencia y en un lugar tan icónico como el Kennedy
Ay,
Space Center?
sí, sí, mira, la verdad es que yo soy todo un mar ahorita de emociones. Estoy súper feliz, no sabes, o sea, súper orgullosa de él porque, como bien decías, todos tienen una historia. Esteban tiene una historia de vida muy, muy, muy fuerte, y me da tantísimo gusto verlo cumplir sus sueños, pues que todos los esfuerzos que ha realizado en la vida ahorita se esté, llevando a cabo, ¿no? Un sueño de esos. Como dices tú, muchas veces pensamos que porque vivimos en una ciudad pequeña o no tenemos los recursos, pues no vamos a poder lograr algo de esto. Le contaba a Esteban, para que yo conociera el Kennedy, le digo, o sea, tuvieron que pasar 40 y, ¿qué? Más o menos 44 años. Le digo, porque apenas yo conocí al Kennedy hace como 3 años. Le digo, y era también un sueño. La verdad es que o sea, para mí era de niña, o sea, siempre veía las imágenes de la NASA, ¿no? Y todo eso y decía, no, pues
De
quién
los
sabe,
Shadows.
voy a ir, ¿no? Entonces tuvieron que pasar 44 años. Le digo, entonces siéntete privilegiado porque pues tienes 21 y ya vas a poder realizar ese viaje y vas a poder conocerlo no solamente desde la perspectiva de turista, sino que tú vas con un proyecto, con un trabajo y con esta competencia, ¿no? Tan importante. Entonces te digo, sí, me siento súper feliz de que esté allá, súper emocionada, sobre todo te digo porque teníamos como los nervios encima de que pues ya le habían negado la primera vez la visa, pues también juntar los recursos, ¿no? Para que pudiera tener para sus gastos. Sí, la verdad es que sí, me siento muy orgullosa de él. Yo sé que va a llegar muy lejos de este niño, tiene todo para poderlo lograr, es inteligente, le echa ganas, se compromete, cuando dice voy a hacer algo, lo hace. Entonces, pues sí, haz de cuenta que es como si estuviera viendo en él mis sueños cumplidos, ¿no?
Sí, claro.
Y imagínate lo que hubiera dado yo por haber tenido las oportunidades también que él ha tenido y estar ahí. Sí,
Exacto. Las oportunidades ahora son un poco más, digamos, sencillas, pero falta mucho todavía por trabajar, ¿no? A final de
sí,
cuentas, falta más, como seguimos diciendo, ¿no? Falta más de difusión. Y realmente nos da mucho gusto que te hayas sumado también a este apoyo, a esta campaña que hicieron ellos, ¿sí? De recaudación de recursos y donaste un telescopio que se fue hasta el Estado de México. Y que realmente les ayudó, ¿no? O sea, y eso creo que también es parte del aprendizaje como jóvenes, de que pues a veces pues no hay, o sea, ¿sabes? A veces no está el recurso, pero
Claro.
entonces, ¿qué vas a hacer?
Sí.
Igual que la industria espacial, ¿cómo lo vas a solucionar?
¿Cómo lo vas a solucionar? Ajá, sí, vas a echar mano de tu creatividad para ver, o sea, con qué cuento y qué puedo hacer, ¿no? Con lo que tengo en ese momento para poder hacerme de recursos, ¿no? Sí,
Sí,
o sea,
para
todos son
poder
retos,
llegar.
que te enseñan a sacar lo mejor de las situaciones.
Claro, entonces, igual que les decía a algunos chicos, ahorita que nos están preguntando en redes sociales por el torneo de diseño de hábitats, como te decía hace rato, tiene un costo, pero porque no hemos tenido ahorita las becas, que algún estado diga, ¿saben qué? Yo pongo las becas para estos chicos, o 100 becas para los chicos, 200 becas, solamente son 200, ¿sí? No son muchas. Pero bueno, todavía falta ese convencimiento de muchos de los estados, ¿no? De los gobiernos principalmente, de las administraciones, que volteen a ver este tipo de proyectos, y si no hay becas, pues ni modo, vamos a tener que buscar cada quien cómo pues meterme a la competencia, ¿no? Porque si tú realmente quieres, si tú realmente te interesa participar o ir a ser parte de la selección el siguiente año que vaya a Florida, pues obviamente pues tienes que ver cómo le vas a hacer y cómo lo vas a solucionar. Le decía a un chico de acá de Irapuato, ¿sabes qué? Dice, no hay becas, digo, no amigo, pero vamos a buscar la manera de que pues no sé, una carta, que vayas con una institución, que vayas con un patrocinador, que hagas una rifa, algo, pero si quieres estar, pues vas a estar. Nosotros vemos cómo te podemos apoyar,
Sí, claro.
pero tenemos que buscar la manera. Y yo creo que desde ahí ya te está preparando para que cuando seas un profesionista ya sepas cómo buscarle, ya sepas por dónde, que no te dé miedo ir a solucionar un problema, que no te dé miedo ir a tocar puertas o a vender
Pedir
algo,
ayuda.
así hacen mucho en Estados Unidos, claro, ¿no?
Sí.
Dice Pame López, dice que es la abuelita de Esteban.
Sí, mi
Y
mamá.
está muy ligada,
Sí.
súper bien, mucho gusto, señora.
Sí.
Está muy ligada a él y me siento súper orgullosa de sus logros y doy gracias al universo por darle esta grandiosa oportunidad. Saludos, saludos.
Sí.
Sí, es
Sí, es
importante el apoyo, como dices tú, de las familias, de que si tu hijo tiene una inquietud, acércalo a este tipo de temas, porque entonces vas a ver que va a empezar a desarrollar otro tipo de habilidades, va a empezar a desarrollar una personalidad más curiosa, una personalidad que vaya a ser una persona de bien, sin limitaciones, pero que busque la manera de solucionar.
Exactamente, sí, es lo que creo que todo este proceso nos deja muchas enseñanzas tanto a Esteban como a mí. También a mí me dejó mucho aprendizaje en el sentido de que algo que me llevo aquí en el corazón es haber visto tanto apoyo de parte de mis clientes, de la gente que conozco, de la familia. Eso estuvo precioso, porque te voy a platicar, hicimos la rifa,
Sí.
o sea, aparte del telescopio que
Otra rifa.
rifamos, para todos, hicimos la rifa de 2 telescopios inteligentes.
Ok.
Fueron 200 boletos, de 200 pesos. Entonces, fue todo un reto y los vendimos en una semana. O sea, de estarle picando y se logró. Y no sabes, te digo, cómo me llenó de satisfacción el hecho de ver pues tanto apoyo, tanto cariño de la gente, no solamente con el hecho de comprar un boleto, ¿no? Sino también de desearle éxito, de decirle palabras de aliento, ¿no? Pues de que qué padre que todo lo que ha logrado y pues que mucho éxito, ¿no? Ahí en la competencia. Y aprovecho este espacio para agradecerles
Sí, ¿no?
a todos los que nos estuvieron apoyando ahí con los boletos y también con esto, ¿no? Con el apoyo moral. Eso estuvo padrísimo. Y yo creo que también la enseñanza que le queda a Esteban es precisamente eso que le decía, hijo, tienes que aprender a pedir, a pedir ayuda. Yo sé que no es fácil, muchas veces nos da como pena, ¿no? El hecho de decir, necesito esto de ti o alguna cosa, ¿no? No es sencillo, pero precisamente el aprender también a pedir te abre muchas puertas, muchas puertas. Entonces, luego tú estás en la posición de pedir ayuda, pero ¿quién dice que el día de mañana tú puedas ofrecer esa ayuda?
Exactamente.
Que tú ya tengas los recursos y eso y veas otros chicos que vienen detrás de ti, entonces tú digas, ok, ahora voy yo a tenderles una mano, ¿no? Entonces, creo que ha sido todo un proceso muy padre. El hecho de que hayan calificado y pues de que existiera la posibilidad, ¿no? De que se pudieran ir para allá. Sí, ha sido muy constructivo.
Claro, imagínate, dices tú, de pedir que tengan que no les dé pena, ¿no? Buscar esa solución, pero
Sí.
también el retribuir, ¿no?
Claro.
El agradecer
Siempre, el
también.
agradecer, exactamente.
Decían, acá en el municipio de León apoyó a los chicos que son de acá de Guanajuato. Pero
Ok.
algo muy importante, decían, híjole, bueno, fue también gestión, entrevistas, ir a ver qué onda, pero al final de cuentas se logró. ¿Por qué? Porque creen en el trabajo que están haciendo ellos, creen en el trabajo que van a retribuir como a su comunidad, porque es lo que nos decían mucho, ¿no? O sea, sí te apoyamos y ¿qué hay para León?
Sí,
¿no?
exactamente, ajá, sí,
¿Qué hay
tú
para
qué
León?
vas a hacer, ajá, sí, a cambio, ¿no? O sea, no
¿Cómo
es
no?
así como una forma de pagarlo, pero sí es como una forma de comprometerse uno, ¿no? Estoy recibiendo un apoyo, bueno, pues entonces, ¿cuál es mi compromiso? ¿Qué voy a hacer con ese apoyo que me están dando para entonces yo retribuir
Ajá,
eso, ¿no? Que
que
estoy
con lo que
recibiendo.
aprendí, con lo que aprendieron allá, ¿qué nos van a enseñar acá en León, no? Por ejemplo, ¿no? Los chicos decían, es que nosotros como comunidad, ¿cómo vamos a ser retribuidos con el apoyo que se está dando? Entonces
Claro.
decían, no, pues vamos a armar algo para cuando llegue, vamos a hacer, no sé, unos talleres, lo que sea, ¿no? El chiste es, y veía un comentario en alguno, de otro de los chicos, que apoyó también su comunidad, y alguien por ahí decía, ¿y eso qué nos beneficia a nosotros? Sí, es parte de cómo piensa muchas veces también la sociedad, nuestra
Sí.
sociedad, y como decíamos, porque tenemos que solucionar otros problemas cuando aquí hay uno súper grave, ¿no? Y
Ajá.
decía, ¿eso en qué beneficia a la comunidad? Pues
Ajá.
totalmente la va a beneficiar, porque a final de cuentas es una inversión a un mediano o largo plazo, ¿no? Que un
Claro.
integrante de tu comunidad pueda abrir esas puertas, que sirva de inspiración para que más chicos puedan decir, sí se puede, para que más chicos digan,
Claro.
yo quiero hacer
Sí.
eso, es inspiracional. Y obviamente los municipios también, no manches, yo quiero tener a más, en este caso, leoneses, que se preparen, porque así vas insertando a tu comunidad en la industria espacial de alguna u otra manera. ¿Sí?
Claro.
Llevar
Ujú.
talento y que no se fugue, sino que ese talento empiece a desarrollar aquí lo que hace falta en México para estar en esta industria espacial y no quedarnos atrás.
Exactamente, sí, eso que dices es súper importante, porque imagínate, pues cualquier compañero, ¿no? De estos chicos de la escuela, ¿no? Que ven, voltean a ver ahorita a su compañerito y está en la NASA y está compitiendo en este torneo, ¿no? O sea, de decir, bueno, pues entonces yo también puedo, ¿no? O sea, ¿qué hizo él para que yo lo haga, lo replique y entonces yo también pueda asistir a ese lugar, ¿no? Y llevar a cabo un proyecto como tan importante como el que están haciendo ellos, ¿no? Sí, eso
Y te
es
aseguro
totalmente cierto.
te aseguro una cosa, Alejandra, que después de esto, obviamente, por ejemplo, Esteban no va a volver a ser el mismo.
No,
De
no,
verdad.
estas experiencias te, te llevan a cambiar totalmente el rumbo de tu vida. Sí,
A
totalmente. O
reiniciar tu carrera,
ujú.
a emprender en negocios de base tecnológica.
Sí,
Entonces, es toda una experiencia y aparte que también desarrollan algunas habilidades blandas que también hace muchísima falta dentro de lo que están haciendo nuestros chicos, ¿no? Por ejemplo, el trabajo en equipo, la
ujú.
resolución de problemas, la creatividad, obviamente el poder hablar otros lenguajes, otros
Otros
idiomas,
idiomas,
¿sí?
sí.
La
Ajá.
adaptabilidad, ¿sí?
Sí,
Que lo que veíamos en algún momento en el desarrollo de microcredenciales para la educación, que nos invitaron a una mesa de trabajo. Y
ujú.
obviamente se hablaban de estas habilidades blandas dentro de la ingeniería y en general de los estudiantes, que estaban muy preocupados de que pues falta liderazgo, falta creatividad, falta trabajo en equipo, falta resolución de problemas, falta también pues cómo voy a reaccionar ante el estrés. Sí,
Exactamente, sí, porque
acción.
ahorita han sido días maratónicos para ellos. Ujú.
Claro, fíjate que el formato de esta competencia es de que ellos solucionen esto en 2 días prácticamente, ¿no?
Sí,
O
no,
sea,
van
sin dormir, o
a
sea,
competir,
sin
sí.
dormir, o sea, están trabajando toda la noche para solucionar este problema, esta misión. Entonces, imagínate ya cuando tú te presentas en una empresa, ¿qué te va a dar miedo? ¿No? También es
Exactamente, ajá, es lo que te iba a decir, o sea, se están entrenando para el mundo real, porque así
exacto,
es, cuando tienes que solucionar un problema y lo tienes que solucionar rápido, pues esas son las condiciones en las que vas a estar, tal vez sin dormir, sin
exacto,
comer, sin tener tiempo para irte a distraer, ¿no? A jugar o salir. Vas a tener que hacer sacrificios, pero ya vas a estar
exacto,
entrenado para eso, ya sabes, o sea, qué es lo que tienes que hacer. Y eso también
exacto.
es una experiencia que no la vas a vivir en ningún otro lado, ¿no? El simple hecho de salir de su
Sí,
país para todos estos chicos ya es una lección bien grande y una experiencia súper importante. No todo mundo se atreve a salir de México, ¿eh? Yo me he topado muchas personas en esa resistencia, o sea, a lo mejor incluso tienen las posibilidades, pero pues no, o sea, como que les da miedito, como que no, ¿para qué? Este, pero viajar enseña. Sí, viajar
sí,
te deja muchas
aprendes mucho.
experiencias. Ujú.
Y por ejemplo, ya que estamos hablando de este tema, ¿qué mensaje le podrías dar a las familias si nos están viendo, que aún no, y a los chicos que aún no se han atrevido a participar en este tipo de convocatorias o apoyar a
Ajá.
sus hijos en este tipo de experiencias?
Pues a los papás que hagan todo lo posible por apoyarlos. O sea, de verdad, no saben cuánto ¿cómo decirlo? ¿Cuántas satisfacciones van a tener después de ver el objetivo ya logrado, no? Sí, yo sé que es complicado, es difícil, es mucho trabajo, pero la satisfacción después de ver a sus hijos en este tipo de competencias o en estos lugares es algo que no tiene, no se compra, ¿no? Como dicen, ¿no? El comercial no se compra con Mastercard, ¿no? Con dinero. Sí. Entonces siempre apóyenlos. Traten ustedes, por ejemplo, si tienen niños pequeños y detectan que ya tienen gusto por este tipo de temas, busquen los espacios. Siempre hay, nada más es cuestión de investigarle un poquito y dar con este tipo de espacios. No sé, utilicen las redes sociales, los museos, los planetarios, las instituciones educativas para hacerse de información de dónde pueden sus hijos desarrollar este tipo de habilidades, ¿no? O llevar este tipo de cursos o hacer este tipo de actividades. Eso, pues el apoyo, ¿no? El apoyo de ustedes, porque ustedes como papás, como les decía al principio, todo lo que ustedes como papás hagan va a tener un gran impacto en cada uno de ellos y va a sembrar la semillita de la curiosidad y de que ellos pues se sigan desarrollando, ¿no? En este campo de las carreras STEM, por ejemplo.
Sí, tú, por ejemplo, como divulgadora, ¿cuál es el impacto de que unos chicos o una familia o unos niños vean, por ejemplo, tu foto de que tomaste de la galaxia, del planeta?
Ajá.
¿Tú qué ves ahí? ¿Cuál es el impacto que genera en la familia?
Uy, mira, hemos hecho exposiciones de fotografías y aunque uno como adulto le parezca como que no va a tener más trascendencia, ¿no? En un niño, no sabes, o sea, cómo nos hemos topado con niños que se quedan embobados con una foto del sol y entonces ya les explicas qué es lo que están viendo o sea, y ves sus caritas como, ves en sus ojitos cómo se prende esa llamita del asombro y de la curiosidad y de querer saber más. Y los niños son, por naturaleza, como gatitos, curiosos. curiosos, o sea, empiezan a hacer más preguntas y esa pregunta los lleva a otra pregunta y entonces todo eso que se queda en su cabecita ya es como la semillita para que empiecen a investigar por ellos mismos, ¿no? Ciertas cosas, ciertos temas. Las fotografías, yo siento que son una manera son como, les decía a los chicos de allá del planetario de Tuxtla, son como el anzuelo para atraer a la gente hacia el conocimiento de todas las ciencias, porque la astronomía, al final de cuentas, está ligada a todas las ciencias. Entonces, siempre, este tipo de fotos, pues como, aparte visualmente son muy atractivas, pues te quedas así, ¿no? Como embobado viendo, ¿no? ¿Esto está allá afuera? ¿Esto realmente existe? ¿Esto qué es? Para empezar, te empiezas a preguntar, ¿no? O sea, ¿esto cómo se llama? ¿Qué es? ¿Por qué se forma? ¿No? ¿Por qué está ahí? Y desde ahí ya comienzas a sembrar, te digo, la semillita de la curiosidad. Entonces, sí suele ser como un material muy, muy valioso y muy atractivo para poder hacer divulgación de la ciencia. Si como papás pueden mostrarle este tipo de imágenes a sus hijos, no sé, la imagen de un planeta, de una nebulosa, de una galaxia, por ahí pueden comenzar a introducirlos a todo este tema de las carreras STEM, ¿no? A sembrar esa semillita, la curiosidad y del querer aprender un poco más acerca de esto. Pero sí, hagan eso, papás, hagan eso. Yo creo que nunca se van a arrepentir de apoyarlos, ¿no? En este sentido. Ahorita, por ejemplo, a mí me gustaría hacerte una pregunta, Oscar.
Dime.
¿Qué sigue para los chicos después de esta competencia?
Híjole, pues es muy interesante ver cómo después de esta competencia, primero, que baje toda la adrenalina, que baje toda la emoción y que baje pues todo este cúmulo de vivencias y de emociones que están viviendo allá, ¿no? Posteriormente es cómo ellos van a encontrar este camino para desarrollarse profesionalmente. Entonces, es interesante ver cómo algunos de los chicos, después de este tipo de competencias, empiezan sus emprendimientos. Por ejemplo, tenemos un ejemplo ahí en Chiapas de uno de los chicos que empezó su empresa de impresión en 3D.
Ok.
Otra de las chicas está haciendo un modelo de educación con otra chica de la India. Y entonces están colaborando en diferentes proyectos y se van insertando poco a poco en otros proyectos. Los que van en prepa se redireccionan a estudiar una ingeniería o algo, pero ya con una conciencia de que eso es lo que quieren estudiar. No de, pues bueno, pues es que aquí me metieron mis papás, o pues no hay otra, pues aquí me meto. No, ya van redireccionados sabiendo hacia dónde van. Eso es prácticamente lo que sigue para ellos.
Sigue para ellos.
Un objetivo que ellos ya van a empezar a perseguir. Muchos de ellos repiten en los torneos porque quieren todavía seguir preparándose para estas experiencias. Muchos de ellos se vuelven divulgadores de este tipo de experiencias también y se vuelven también agentes de cambio en su comunidad, ¿sabes?
En sus comunidades.
Porque entonces ya es como de vénganse a participar a este torneo. Y me tocó algo bien interesante de ver, y le mando un saludo a Pablo, de ahí de Chiapas, de la comunidad de Villacorso, que nos invitó a dar una plática ahí, y que dices, wow, o sea, yo le decía, aquí tuviste que navegar contra corriente, ¿verdad? Y me dice, sí. O sea, él, después de haber participado en el torneo, uno de los torneos, se fue de salón en salón invitando a la gente. Tienen que participar. Entonces, se les abre un mundo de posibilidades. Ahí ya se fue de intercambio también a Colombia. Entonces, busca la manera de salir, de aprender, de seguir aprendiendo, de seguir expandiéndose, porque ya no hay un limitante, ¿sí?
Sí.
Entonces, eso es lo que sigue para ellos, y que ven la posibilidad de que realmente pueden insertarse en esta industria, no solamente por una cuestión de mero entrenamiento, sino van buscando los apoyos, van buscando las áreas de oportunidad, que sí las hay, ¿sí?
Claro, sí las hay.
Y que están ahí, y entonces es cuando dices, aquí es donde vale la pena, ¿no? Cuando ya ves a todos nuestros chicos, apenas es la segunda generación, pero ya están empezando a dar esos pasitos hacia lo que sigue, estas colaboraciones que tienen con chicos que han conocido en otras competencias, ¿sí?
Wow.
Entonces, ese es el impacto, y esta es nuestra segunda, generación, pero vamos a estar atentos a lo que sigue con estos chicos, ¿no? Vamos a estar atentos porque muchos se vuelven los mentores de los chicos que ya están. Entonces, es esa cadenita de favores, ¿no? O sea, vamos a ayudar a los que siguen, vamos a ayudar a los que vienen, y vamos a tratar de insertar a México, porque muchos tienen esa convicción, porque me ha tocado escucharlos y verlos, de decir,
Ajá.
es que tenemos que llevar a México a la industria espacial, tenemos que traer a México todo este aprendizaje. Entonces, hay un convencimiento de que se tiene que hablar de esto, es un
Sí.
convencimiento de ellos de que quieran aportar a la comunidad, ¿sí? Con un plan estratégico para que haya educación espacial en las escuelas. O sea, muchos de ellos todavía están como en ese sueño de decir, tenemos que hacer esto, claro, tenemos que empezarlo y tenemos que picar piedra porque eso es lo que se está haciendo. O sea, tanto los divulgadores científicos, por ejemplo, también como ustedes, que se dedican también a la divulgación desde, en este caso, desde de la observación, de la
Sí, ajá.
fotografía, de los campamentos, o sea, el inculcar en todas estas personas que eso se puede, ¿no? De que eso está
Claro.
ahí y que
Ujú.
también es un producto del que se puede crear una empresa
Claro.
con enfoque espacial y que no
Exactamente.
es imposible y que no está loco y que no es algo tirado de los cabellos. No, 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 existe, está. Lo
Sí.
veíamos en una plática con esta empresa, se me olvidó su nombre, que ya te lleva tú le mandas unos gramos de la ceniza, ¿sí? De
Ah,
cuando
sí.
mueres,
Sí, que la
te
llevan al
incineran
espacio. Ujú.
y la sueltan en el espacio
Sí, ajá.
como un memorial, ¿no? Entonces, eso es
Sí,
una empresa.
claro, sí.
Entonces, es parte de, y es algo que ya está, es algo que ya existe y es algo que la gente paga por hacer.
Claro.
Entonces, no
Ujú.
está descabellado que tú busques
No.
una solución para el espacio basándote aquí en lo que falta aquí en la Tierra, porque solucionando, como decíamos, solucionando a lo mejor esa parte del espacio, vas a solucionar
Vas
muchas
a
cosas
encontrar una
aquí en la Tierra.
solución a algo, a una problemática de aquí.
Exactamente.
Ay, sí.
Ya casi vamos a comenzar, ya me están diciendo por acá que ya mero va a comenzar. Estamos a unos minutitos de empezar. ¿Cuáles son tus predicciones para para esta
Híjole.
final?
Uy, está bien complicado. Siento yo que está muy reñido. Yo no sé, desconozco qué criterios, ¿no? Sean como los más ponderados, ¿no? Para decir este equipo va a ganar, sí, equipo se llama, ¿no? Empresa. Ujú.
Sí, empresa,
Va a ganar,
compañía.
porque cada una siento que ofrecen soluciones diferentes, muy, muy creativas, muy innovadoras. Todas tienen como sus puntos fuertes. Entonces, sí desconozco, como te digo, qué sea más importante para los jueces,
Fíjate
qué
que una
parte del
de las
desarrollo.
principales es que sea viable. La viabilidad, lo
Viable.
más cercano,
Ok.
lo más cercano a la viabilidad. Otra importante es el picheo, o sea, cómo se le hayan vendido también a ellos y cómo hayan respondido las preguntas técnicas que
Oh,
les hicieron, ¿sí? Porque a lo mejor a veces hay soluciones como demasiado descabelladas
sí. Ujú.
que, o sea, siguen siendo soluciones, pero que realmente no
No
están
tienen pie
en
ni
esa
cabeza, ¿no?
posibilidad, exacto, en ese momento de realizarse o de cómo la
Ok.
justificas. Entonces, eso es básicamente así a grosso modo, porque imagino que ha de haber como rúbricas muy exactas en la cuestión técnica, sobre todo,
Sí.
de cómo pensaron que van a sobrevivir ahí arriba, los espacios donde van a vivir. Eso es súper importante, ¿eh? Los espacios donde va a vivir la gente. Cómo se van a transportar o cómo va a ser esa parte entre la superficie del planeta y en este caso la nave que está arriba,
Ujú.
el tamaño, las dimensiones, o sea, todo tiene que ver que digan, bueno, si es viable, ¿no?
Sí.
Si vamos a estar aquí mucho tiempo, pues de qué tamaño va a ser el lugar donde voy a estar, ¿no?
Ajá.
¿Qué tan agradable va a ser? O sea, todo
Ok.
eso y también la cuestión del dinero, o sea,
Ajá, sí.
el costo, el
Costo.
presupuesto, sí, que
No, ok.
digan, ok, este proyecto está padre, este proyecto cumple con, yo diciendo padre, ¿verdad?
Sí.
Este proyecto cumple con las especificaciones de este presupuesto que me agrada, entonces, este es, ¿no? O sea, porque lo que se
Ok.
busca es que sea también lo más económico posible. Y no económico significa que no vas a, o sea, no se escatima en seguridad. Claro,
Ajá.
en cosas de sobrevivencia o de que tengas que estar seguro allá, sino en la cuestión de que se abarate el costo, es que lo podamos hacer realmente. Es lo más cerca, esa viabilidad viene de que realmente pudiera hacerse con un presupuesto. Entonces, ese es de los criterios. Y eso es lo interesante, ¿no? No es de que solamente imaginemos cómo vivir en el espacio, sino que
Ajá.
imaginemos una solución que sea lógica, que sea
Ajá.
justificable, que sea sustentable incluso, ¿no?
Sí, 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 que sí sea real, ¿no?
Que pudiera, sí, que en esta, que en
pueda
esta,
llevar a cabo.
que en esta, que en esta suposición o en este ejercicio de imaginarlo, realmente no te vayas, ¿no? O sea,
Sí, ajá.
cosas que
Era
no
nada más
puedes,
una
sino que
película de ciencia ficción.
exactamente, sino que tenemos que solucionarlo con cosas reales. El agua, por ejemplo, las necesidades que tiene cada persona ya, o sea, todo eso está plasmado en este tipo de proyectos. Entonces, ya
Ok.
estamos casi a unos minutitos, yo creo que
Qué
ya
nervios.
van a empezar. A ver, Javier, mi
Nervios. Corre,
corresponsal
corre.
allá en el Kennedy Space Center que me diste,
Tú que tienes un poco
dicen
más de experiencia en
que ya
esto,
casi.
bueno, ya el año pasado tuvieron esta experiencia. ¿Quién crees tú que gane?
Híjole,
Está
pues
cañón, ¿verdad?
mira, está cañón, o sea, pero, bueno, me estaba más o menos viendo algunos comentarios y todo eso,
Ajá.
que el equipo donde están los chicos de Chiapas está pesado. Entonces,
Pero
vamos
¿cuál de los
a,
dos?
vamos a
Porque están en
esperar.
dos equipos, ¿no?
Sí, están divididos, pero la mayoría de los chicos de Chiapas creo que están en uno solo.
Ah, ok.
¿Cómo
En
está
el
Rob Donald,
de,
que es este último, el anterior?
ajá, sí.
Este,
Ahorita te digo cómo se llama. Se me fue el nombre.
sí, a mí también.
Sí, ya. ¿Dónde lo puse? Sí, y sí me dijo Alfredo,
Eh,
digo, Esteban. Ay, ¿cómo se llama? Ah, 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 ah. Y lo
Aquí
acabo
le
de
están
escribir.
echando porras.
Lo acabo de escribir y ya no me acuerdo. Flectel.
Flectel,
Ajá, Flectel.
sí.
Ujú.
Dicen que está fuerte Flectel, vamos a checar, a ver qué
Ah,
deciden los jueces, porque en estos dos últimos equipos vi como preguntas muy incisivas, ¿no?
ujú.
En algunos de los datos que
Detalles
estaban
más
proponiendo los
finos.
chicos,
Ajá.
detalles. Es que, como dicen, ¿no? El diablo está en los detalles y por una cosita
Muy
pequeñita,
pequeñita,
pum,
ajá. Se
es
deshace
como
todo.
cuando me imagino que ustedes ajustan un
El
telescopio, ¿no?
telescopio.
O sea, es
Sí.
milimétrico, ¿no? Si no, o sea,
Sí.
yo digo que tenía un telescopio hace mucho tiempo, newtoniano, que me regalaron alguna vez, y híjole, era un rollo, enfocar
Enfocar. Sí.
algunas cuestiones. Y
Sí.
pues mira, creo que voy a agregar esto al escenario. Ya casi estamos por
Wow.
empezar. Y pues esperamos que los chicos que están representando a México y a Perú,
Sí,
¿sí?
pues
Entonces,
qué emoción, qué
ya está por
emoción.
empezar. Pues bueno, nos vamos a
Sí,
desconectar un poquito para dejar
sí, la transmisión.
esta,
I'm glad you
esta
guys like me
transmisión
this much
y
because you're not going
ahorita
to like me
nos
by the
vemos.
time I've
Nada
stopped
más quiero
talking.
agregar algo.
Sí, sí, dilo.
Pues muchísimas felicidades a tanto los papás y los chicos que están participando. Como le dije a Esteban, ya por el hecho de haber ido, son ganadores. O sea, que no se vayan a sentir, o sea, si no ganan, que no se vayan a sentir derrotados porque ya el estar allá es un premio y fue el producto, el resultado de algo muy grande que lograron, ¿no? Entonces, mucho éxito, mucha suerte y pues vamos a ver quién gana, ¿no?
¿Me acompañas aquí? ¿Nos vamos a quedar aquí?
Sí, claro que sí. Sí, sí, sí.
Vamos a ver, ya
Aquí
puse
me
el
quedo.
sonido.
Ay,
Noemí Vivas, Flecter, dice Flecter, Noemí Vivas.
Flecter, sí, arriba Flecter.
Vamos a ver.
I'm glad sleep got a cheer. If you want to go back to the hotel, please start getting on the buses from 5 p.m. They'll be waiting outside this building, I believe, from 5 p.m. So we're at 4:20 right now. We're going to try and get through this, but they'll be waiting for us out there. They should depart around about 5:30-ish, or at the very least, half an hour after you depart. We're going to try and get people on as quickly as possible. Dinner will be served at the Holiday Inn from
Bueno,
6
están dando
p.m.
indicaciones
It's pizza
ahorita
night.
que salgan de ahí de la competencia.
Sí, de la competencia, sí.
Ujú.
¿Qué diferencia de horario tenemos para allá? ¿3 horas?
2 horas.
2 horas, ok.
And as we've been doing
De allá son las 4:24 por regular.
for every meal that we've had at this competition, those with dietary requirements, you guys go first. But specifically for this one, could those with dietary restrictions go to the Holiday Inn restaurant? For those of you who haven't been to the Holiday Inn for any time during this competition, if you go straight through the lobby and keep going, it's not the first left, it's the second one. You'll see it, it's a nice big nook, you can't really miss it. And if you do, you can ask at reception. We'll have our team posted out there. Look for Tammy. Everyone give a big hand to Tammy Lutz for all the work she's done in putting together the catering. Just got one more job. And then here's the bit you're going to hate. We have a hard curfew at 10 p.m. today for everyone. We have got a really good reason for this. We've done very well over these 2.5 days to be respectful to those around us, because whilst we do take over Titusville and KSC, we're not the only people who are here. And it's worthwhile being respectful to all those around us. And we've all worked incredibly long 2.5 days. Everyone from the staff, organizers, volunteers, and most importantly of all, you. The only reasonable thing to do from a safety standpoint is to make sure that everyone gets some sleep. And remember, you guys gave a pretty hefty cheer to sleep. So I hope you guys can understand that. Now, I do have a slightly better news. Who wants to explore Kennedy Space Center? After we're done here, you can go and explore, but you have to be in lot 4 by 6:20. That's when the next bunch of buses will be there to collect you. Okay? So those are your two choices. You can either go, as soon as this is done, to the hotel, or you can go and explore the center. Thank you, Barbara. Those are your two choices. You can either go straight to the hotel. Thank you. You can go straight to the hotel, or you can go to KSC. But if you visit the park, you have to be in lot 4.
No se pueden ir sin visitar el Kennedy Space Center. Si ya están ahí.
No.
Make sure you get on the buses.
Tienen que vivir esa
Back to the hotel,
experiencia
and we can
también.
get you pizza.
Sí, sí, imagínate haber estado ahí, no haber ido.
Please travel with your chaperones around the park. We want you to be safe. And again, it's a hard curfew at 10 p.m. for everyone. For everyone. Can't stress that enough. Now, with that out the way,
Y es que esta logística está de locos también.
Let's go on to the fun stuff. Welcome to the closing ceremony for the International Space Settlement Design Competition 2025.
Listo, ya vamos a la ceremonia de clausura. Muy bien.
And we're going to start off with some awards that are long overdue, ones that have been sitting with us since Saturday. For those of you who won the quiz, we've had a number of you on this list. If your username is here, please come collect your prizes from Kelsey and Barbara here at the front. Now, we know that Caleb, the real Bambi, Robinson, USA Zachary have collected their prizes. But regardless, we would still like you guys to come up to the front. So if you recognize your username, please come up to the front and see Kelsey and Barbara. Give them a massive round of applause. Do you want to take a photo? Okay. Helvi and Johnny. Helvi and Johnny, come to the stage, please.
Creo que les dieron un premio por algo.
Going twice.
No escuché bien por qué.
Great. Well, that deals with that. Oh, wait. Helvi? We got
Son
ninth
como
place.
menciones especiales antes de mencionar al
Round of
ganador.
applause for ninth place.
Ah, ok.
Okay. Now, that's one of the set of awards out of the way. We now move on to a set of awards that requires a speaker who can give it the right level of appreciation and dignity. And I'd like to please invite to the stage Hannah Renz. Everyone, a round of applause.
Thank you. Thank you. All right. Welcome, everyone. Fantastic presentations today. I had the absolute joy and honor of getting to be your judge and getting to come in with a fresh face this morning. I had read the RFP, kind of had an idea of what to expect, but you all blew me away this morning and this afternoon. It was a total joy to get to see your creativity and your expertise. So we've got 2 awards that we will go and award 1 presenter from each company. This first one personally means the most to me because Anita Gale was such a big force in changing my life. So this first award, we're going to go in presentation order by company to award the Creative Genius, the Anita Gale Award for Creative Genius. And what this award really summarizes and what it is really about is coming up with that vision with a capital V. Someone who had a really crazy idea, maybe they noodled on it all night and totally went for some out-of-the-box thinking, some really unique solutions, and really kind of drove home that so much of what we get to do here is on the cutting edge. It's coming up with concepts that have never been developed before, that are brand new. So we wanted to take some time to recognize so much of Anita's legacy in this way, and so much of how if you think it's hard to come up with a proposal to this, imagine how Anita used to have to write the RFP that generated all of your proposals. But she was also fantastic at maniacally torturing teenagers. So there's a little bit of that essence that we also like to acknowledge here. So in company order, we will award the Anita Gale Creative Genius Award. So like I said, we'll go in presentation order. So for Dougaldine Astrosystems, our Anita Gale Award goes to Beatrix. Yep, you were right on over there.
Están integrando un premio que se llama Anita Gale, que fue la fundadora de todos los torneos.
And next up
Sí.
for Vulture Aviation, our Anita Gale
en
Award
orden.
winner is Sean.
Es un reconocimiento a la creatividad, al genio creativo. Es un premio al genio creativo.
Ok.
¿Sí? Y los primeros que vimos, ellos hicieron al principio, hicieron un Kahoot y son los chicos que ganaron en ese Kahoot en la primera parte.
Ah, ok. Ya.
Un
I love the
saludo
excitement here. Yeah, let's keep this
a
going.
Oscar Toala que nos
All
está
right.
viendo.
Next
también.
up for Flectal Constructors, we have Oliver.
¿Qué quiere decir eso?
Son ¿cómo se llama? Es como un reconocimiento personalizado
Ok.
porque destacaron en este torneo por algo que hicieron, ¿no? Por ejemplo,
Ok.
de Flectel se lo dieron
A
a
Oliver.
Oliver por pensar en una idea como más loca, ¿no? Entonces,
Ok.
And last but not least for Rock Donald,
Donald.
we have Nahar. You're right down there. Right. Congratulations, Anita Gale Award winners. Now we do have another award that we give in honor of, I'll pause just for a little silence. We give the Dick Edwards Award in honor of Anita's husband, who was quite often known as a man of few words, but the words that he did say and the words he did contribute would often completely shape the conversation and completely bring things in a new direction. He was known for quiet leadership and was known not always as someone in management, but often someone who came and was a guiding force for all of the teams that he worked on. So same situation here. We're going to go company by company. So first off, for Duggledine, we've got Adaya.
Son otros reconocimientos, ¿no? A los líderes silenciosos.
I love the web. Right.
No te escuchas, creo, Oscar.
ay, perdón, que este es uno de los reconocimientos que tiene nombre del
Next up
esposo de
for
Anita Gale,
Vulture, we
que
have
como dices tú,
Caitlin.
era una persona de pocas palabras, pero que lo que decía
Era
moldeaba todo el proyecto, ¿no?
Sí.
Entonces, estos son los chicos que trabajan de esa manera, calladitos, pero haciendo las cosas, porque que llevan las cosas en una dirección totalmente nueva y que también era conocido por el liderazgo silencioso, ¿no? Como decíamos. Y que, sino más bien como guía, como guía para los equipos de trabajo.
Next up, looking at Flectal
Qué padre, ¿no? Que
Constructors,
también
we
reconozcan
have
este
the
tipo
Dick
de
Edwards
actitudes.
Award winner of Maria Karina.
Oh, mira. Deflected.
And finally, for Rock Donald, we have Anna.
Deberían también pasarnos imágenes del
Sí,
lugar.
pues, ajá. Sí.
To all of you, Dick Gale and Anita Gale and Dick Edwards Award winners, we just want to recognize that your service to your team is really what separated you and what stood you out from the crowd. So we wanted to take a moment to recognize you all today. Thank you. But moving on, now it's time to talk your proposals. So I've got a few different things that we're going to go through here just to keep, the anxiety up a little bit longer, keep it a little more interesting. We're not going to cut right to the end. So we've got a few things we're going to talk through here of overall,
Estamos hablando.
across all of the 4 different presentations today, what were some things that as a judging panel, we thought the teams as a whole could have done better. Then we're going to talk through strong points company by company of the things that really stood out to us, the things that we really liked. And then maybe we'll get to talk about the winner, but you're going to have to listen to me for a little bit longer first. So first off, let's talk about as a whole across all 4 proposals, some of the things that we saw that we would have liked to see represented a little bit stronger, and things that maybe you consider for next year, maybe you consider bringing back to your regions, but also may show up in a future training. So keep an eye out for that. So the first one is that the story sells the product. So across the presentations today, what we would have liked to see is a little bit more of that vision with a capital V of don't just sell us a product, really sell us an entire story of what does it look like to live there? What is a day in my life as a human on the settlement? What does that look like for me? What am I going to be feeling and seeing and experiencing? So we were really looking to see a little bit more of a comprehensive story, recognize that this is a hard RFP to pull that off with. But that's something the judging panel would have liked to see. Additionally, we noticed that we saw some missing functional requirements, and we just would have liked that those had been recognized. Would have liked to see that, hey, we didn't make, we as a team decided that we weren't going to meet this functional requirement, but just call it out. Give us a little bit of rationale, give us a little bit of something, versus just feeling like it was missing from the proposal. And finally, and this is one that was near and dear to my heart because it was the one that I brought up because it's part of my background, is the line between order and disorder is logistics. So much of what made this RFP unique and what really made this RFP a viable business plan in the year 2075 is logistics, is how do you take natural resources from Venus, from both the atmosphere and from the surface, get them to the settlement, get them processed, but then also get them out through the rest of the inner solar system and actually start to make a profit on them. So we saw lots of concepts and lots of things that were almost there, but very similar to the story sells the product, is we wanted to see a little bit more of a comprehensive handling of logistics. And really, since that was the big way to make money on this settlement, really drive home, don't make us judges, don't make your customer have to jump through hoops and try to understand and make some guesses.
¿no? O sea,
make it the clearest and
consideración es lo que
simplest
decíamos,
story
¿cómo
for us
vendes
to
este
understand.
producto?
So logistics is a really hard thing, especially if it's something that typically, logistics, you most often experience it with just ordering something on Amazon and it shows up at your door 2 or 3 days later. But thinking through all of the processes and all of the infrastructure, all of the systems and the people that have to touch that package from the time that you actually place the order on the website to the time that it comes to your house is a really challenging problem, and one that we encourage continual thought about moving forward. But on to the fun stuff. Got through the hard stuff. Now time for the fun stuff. So we're going to talk through some strong points of each company. And one thing you will note, there's the same number of bullet points on every single slide. Everything is one line. Do not read into this. This is simply us judges going through company by company, talking through what we liked. So nowhere in here will you find who the winner is. We're not giving you any hints. We're just giving each team honest feedback about things that stood out to us about their proposal, stuff that we found was really interesting. So you're not going to find any secret codes, any secret meanings hidden in these upcoming bullet points. Take the feedback and celebrate the wins here. So first off, with Duggledine, we loved the bug powder. Bug powder is fertilizer. Bug powder is a kind of a multi-purpose different tool. That was a really cool innovation that we liked to see.
Están hablando de los puntos fuertes de cada compañía.
And additionally, the magnetic reconfigurable settlements. This was kind of a unique inclusion in the RFP that we thought you had a really innovative solution to and liked kind of the way that you implemented it. Additionally, you had really clear operations from ground to settlement, and it was easy for us judges to understand, easy for us to see, okay, I understand how a product is going to move across those different areas. And then we also appreciated that you had a failure matrix, or the FMEA matrix. Sorry, I'm a little sleep deprived, so acronyms are a challenge right now. But we love to see that you had really put some true systems engineering and reliability thought into your proposal and included that matrix, even though that was kind of above and beyond, I think, what we really line by line required in the RFP. So great job, Dougaldine. Right. Next up is Vulture. So one of the first things that stood out to us on Vulture was that you addressed corrosion. The atmosphere of Venus is a horrible environment to work in, but your settlement design took into account corrosion and ways to mitigate it and how to deal with it. And you showed that throughout multiple slides of your presentation, which we really appreciated. Additionally, we thought you did a great job at demonstrating in situ resource utilization and really how do you use all of the products that you have on Venus to create some really innovative solutions and also deal with the byproducts of some of the more common processes that you're going to do. How can you still turn those byproducts into a profit? We also liked your detailed construction and production plan. Construction plans, just like logistics, can be hard to show and just difficult to really accurately convey, especially for a settlement that is so big, so far away, and so complex, floating and flying through the atmosphere. So we really appreciated that detailed construction plan. Additionally, we noticed your predictive operations planning. It was a really innovative use of AI that we are actually starting to see in industry now, and it was a really good way to extrapolate that current technology into the future. So well done, Vulture Aviation. Right, next up I've got Flectal. We're just gonna keep moving, folks. All right, we liked in your construction phases, specifically how you designed around and accommodated for tension in your design, especially with the unique design that Flectal had. We thought your particular attention to tension in your initial construction stages was very detail oriented, and we really appreciated that. Additionally, your use of airbags and your changeable airbag buoyancy for moment control was another innovative way to use the unique shape of your settlement to your benefit. Give you a little bit of redundancy, give you a little bit of extra flexibility in your ConOps. Next up, your communications plan. Our communications expert on the judging panel really made a point that you had a very well thought out communications plan, and it was well communicated. So good job communicating on communications. And next up, the power planning. We liked some of the details that you had in your power planning, including having specific details about the battery and the way that you were going to store extra power, but also your generation and some of the thought that went into how can you produce less, how can you need less power? So again, well done, Flectal constructors. And Rock Donald. All right, first thing that stood out, again, from the very first slide, we liked your use of biomimicry. You had some really innovative and really new concepts that we hadn't seen before when it came to both the shape of your settlement, but also your external muscle, skin, structure, sheathing, kind of. I'm going to struggle getting all of the words out to accurately describe it, but we liked your use of biomimicry there. But then also your concerted effort to include different plants and different microbiomes within your settlements for the people that come from Earth to actually go and be able to interact with the same kind of plants that they recognize from Earth. We also recognize you did a great job at providing natural views and really accounted for how windows and your dome structure could actually come into your habitat ring so that humans could get some good natural views outside of the settlement. We also noted in Rock Donald, you had really detailed figures and analysis. You had lots of numbers, lots of concrete calculations. We could see that a lot of thought went in behind the scenes to actually inform a lot of your slides. We appreciated kind of getting to see some of that thought process laid out on the slides. And we also, I know Jack gave a shout out for this earlier, but we do love to see a construction check, especially the folks doing construction. There's got to be a home base. There's got to be something to start from. So love to see that as well. So well done, Rock Donald.
Nos la están haciendo de emoción, ¿no?
Sí, ya sé.
And I
Ya,
believe
ya va a empezar, ahora sí.
I actually am going to hand the microphone back to Shane to do this part. So you're going to have to wait. You're going to have to wait. But here we go.
Ay. Bueno.
Híjole, ahora sí la están haciendo de emoción.
Sí.
Thank you so much, Hannah. Everyone, please give a warm round of applause for Hannah Renz. Well, there's been a lot of change this weekend, and there is one more thing that has changed, and not by choice. We've lost a lot of time over the past 3 days, and 2.5 days even, and some things have to be cut. Some beloved things have to be cut. So we're going to announce the winner straight away. Drum roll, please. The winner is... Louder, louder, louder. Us.
Ay,
Gotcha.
todos somos ganadores, claro.
You know, we started this weekend talking about the journey that you had all taken to get to this point. And that journey keeps going on and on. But first, we have to thank a bunch of people. We have to thank your parents for everything that they have done to ensure that you could make it here. Thanks to your chaperones for keeping you safe.
Primero los agradecimientos, ¿no? A
Thank
todos.
you
Sí,
to
ya
our
sé.
very many sponsors, including the Astronaut Memorial Foundation.
Nuestros patrocinadores
Ah,
como tú, Alejandra.
mentores. Ajá,
Without their
Nuestro
support,
show,
none of this would
todo.
be possible.
sí.
To our hosts, the Astronaut Memorial Foundation and KSC. To our very many volunteers, from your CEOs
A los voluntarios.
to the red
Sí,
team,
a los CEOs,
to our judges,
que los asesores de
to
cada
the wonderful
compañía.
photography team. Thank you all.
Sí, que lo están haciendo de emoción.
Ya
And a
sé.
huge thanks goes to the board of the Aerospace Education Competitions for continuing to allow this event to keep going. But of course, the biggest thanks are due to all of you. Without you, none of this would be possible. The 3,800 or so participants who have gone through an ISSDC in the past 12 months are represented by you here today, and you've done them proud as to what is possible to do when you have a very short period of time, a near impossible task, but no will to give up. So there are great things about to happen in the next couple of slides. Because in the next couple of minutes, the 4 companies that are here are going to have one champion. But leaving here today are 254 new stories.
250 chicos
Hang on.
en esta competencia.
And each of your stories were coupled by the journey that you took to get here. But you've all had a very similar journey coming to an event like this one. SAT. sat in a room just like this one, hearing someone like me and the fantastic presentation team that we've had this weekend tell you about the impossible task you have ahead, going into company elections, which are definitely
Ahí está
awkward.
Manuel Peregrino en esa foto.
And whilst we have a wonderful smiling bunch here on the stage, deep down inside, in the back of them, they are absolutely terrified. And of course it's terrifying. You have to put yourself out there. But once the companies have the RFP and they have
Sí,
their
Annette, ahí
leadership
está
structure in
atrás.
place, it's time to lock in. It's time to lock in and start designing. But this year's RFP was really hard. And this year had a lot of changes. And it felt like you were in the dark for a little bit. But again, you all persevere. When you design, you realize you've got to do more. So you collaborate with one another. And out of all of what takes place and out of all of this darkness, things start to gain a little bit of clarity. All of this. And as your team gains greater clarity, you design and you create. You collaborate with one another.
Esteban ahí con Annette.
You ask hard questions to one another.
Sí.
You create. You collaborate.
Paola Penagos ahí atrásito.
Ah, sí.
You lock yourselves out your hotel room. You create. You collaborate. You feel like a deer in the headlights.
Alguien quiere estar aquí en la transmisión también.
Sometimes you just need to sit down and chill out and think to yourself,
We also noted in
but everything's going to end up being all
really
right.
detailed figures and analysis.
Despite the
You had
fact that
lots
I'm
of
sure there were a bunch of moments where you thought you weren't going to get something in that you could truly be proud of. I hope you recognize that you were proud of what you did. Maybe you don't realize it in the moment,
Quiere ver al ganador
but
también.
we saw it. We saw it on everyone's faces. Everywhere that we looked. The next two images are the most important. Despite everything that we saw, there's one thing that hasn't changed. You are still terrible at cleaning up your rubbish. This is terrible cable management. Is someone trying to start a fire? Not good. I kid. One thing is very different for all of you who leave here today. You're going to walk out these doors, and for some of you, it'll be the last time that you're able to compete. For some of you, there'll be another reason to work even harder next year so you can come back here. But for all of us, we're unified by one thing. The fact that we chose to go through this experience. It reminds me of an important quote that I found not too long ago. You should be open. If something is pulling you to something philanthropic, embrace the opportunity. Part of being human is to enrich the experiences in the lives of others. And this was a great saying said by a great person who 41 years on later, we're still all here because of her.
Ahí es Anita Gay, la que fundó estas competencias.
Ah, ok, ya.
For Dick Edwards, for Anita Gale, for all of you, we're unified by one thing. We do this for you. Thank you for everything that you have allowed us to do for you over these past 2.5 days, 12 months, and hopefully for a really, really long time to come. Now, as much as that's all good, we got to actually do this for real this time. So.
Ahora sí.
Ahora parece que sí ya.
I lied. You really think we're going to get rid of the best part of this competition? I'm not the one who's well placed to do this, though. And I'd like to hand back to the CEO of the Aerospace Education Competitions, one Miss Barbara Kennedy.
¿Ven?
Can we get a big round of applause for Shane? I'm going to go off script for just a second here. How many of you this weekend took on something and you thought, I can do this all on my own and I don't need anybody else? And how many of you took on something and thought, I could do this all on my own and wanted to just take off and do it? Raise your hand. How many of you failed? I did too. I want to personally say thank you to everyone in this room for being patient with us as we transition through big changes to provide a better experience for you all. I'm going to ask for one more big round of applause for all of our volunteers in this room.
Lo hacen de muchísima emoción, ¿eh?
We do it with them.
Jenny, acá en
We
mi
do
rancho.
it for you.
Caro, salte de aquí.
As some of you may have heard, when Dick Edwards used to give this award, he did it on a projector. How many of you know what a projector is? Raise your hands. That's actually pretty impressive. Did you see it like in an antique show or something? He did it with you had to put plastic sheets onto the projector. It was not digital. Plastic sheets. You had to have them pre-printed. They were clear. All of the documents were written on, like all of the things you needed to show were on them. Everything had to be backwards, because if you put it on forwards, it showed up backwards on the screen. It was a nightmare. And so what he would do is he would print out a zillion of these, right, Jack? And he would flip one just like this. And he would talk a little bit, or maybe a whole lot. And he'd pull it down and he'd put up another one. So, who in here is excited to hear the winner? I am going to need twice that volume before I go to the next slide.
Nos va a dar un paro cardíaco, que ya digo.
Ya sé.
I'm going to take one more moment to just once again say that we can't do this without a team. You can't do this without a team. I can't do this without a team. If we handed this proposal to any one of you this weekend, you would not have anything good to show us on Monday. So before I go to the next slide, one big round of applause for teamwork in general.
Ven.
Give me a shout if you want to win. I'll take that. I'll take that. Give me a shout if you had a good time this weekend. That won't do it. We're going to stay on this slide until the volume doubles. Give me a shout if you had a good time this weekend.
Lo importante que va a ser que si los chicos están
move to the next
en
one with
equipo
that.
ganador, Va a ser súper
Oh,
importante para
I think we might be getting really
nosotros como
close.
mexicanos.
I think we might be getting really close. Because of that, I'm going to ask all of our photographers to come to the front of the room.
¿Por qué?
Porque sería la primera vez
Big
que
shout for our
un
photographers.
mexicano
Big shout.
está ganando este
Big
tipo de
shout, and I'll move to the
competencia.
next slide.
Vamos, ya van a decir.
¿Quién?
This is an important one because, as Shane said, every one of you is a winner.
Dios mío.
Every one of you that is here today stuck it out through 3 days of, I typically would not say hell on stage, but Shane said it 5 times. All right.
No, hombre. Esto está, pero para morirse.
3, 2.
Qué desesperación.
Judges, please come grab a handful of medals and come stand up here. Handful of medals.
¿Ganaron ellos? Ok.
¿Cómo?
With that, I'm gonna ask the team chaperones to come up and please collect photographs that we have all signed for your teams. And thank you so much to all of you for this weekend. The remainder of the teams are dismissed. Please go enjoy the park. Please go grab the buses. Have a wonderful evening. Feel free to take photos. Have a good day, guys. Can you guys all grab
Bueno, ganó Vulture por lo que estamos viendo.
the...
Sí.
Oh, bueno, pues qué padre, pero nos hubiera gustado que fuera Flectel.
Ya sé, a todos nos hubiera gustado que fuera Flecter, pero ganó Vulture, que es lo que
All
estamos viendo
right,
ahí.
Vulture Aviation.
Sí.
Please
Sí, sí,
come
sí.
collect your medals across the stage, one at a time. Grab a medal from someone.
¿Sí o no?
Sí, 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 ganó Vulture.
Antes de
Híjole,
que lo dijera,
bueno.
ya le habían puesto el recuadrito.
Sí, ya sé.
You're welcome. Congratulations. You're welcome. Congratulations.
So excited.
Congratulations.
Thank you. Thank you so much.
All the way down.
Okay.
Let's go all the way down. Congratulations.
Oh, I can put it on.
Congratulations.
You.
All right, all the way down, and they have them. You're good. All the way down, they have them as
Sí,
well.
claro,
All
como
the way
dicen,
down, all the
aún
way
así son
down.
ganadores, por supuesto. El de estar en una competencia de esta talla
All the way down, they have them as
está
well.
cañón.
Sí, sí,
Y pues
claro
bueno,
que sí.
siempre tiene
Hay un
que haber
Thank you.
alguien que tiene una solución que
Congratulations.
realmente
Oh,
sea viable para todos, ¿no?
Sí,
Y pues
Vulture,
you guys go.
chicos de
I'll give you that
Vulture.
one. All the way
¿Mande?
down, guys.
Vulture
All
fue
the way
el
down.
segundo proyecto.
Congratulations.
¿O
All
el
the way
primero?
down.
El
All the way
segundo
down.
proyecto, creo que fue el segundo.
Segundo, ¿verdad?
Sí.
Congratulations. All the way down.
Y eran equipos grandes.
Awesome.
Sí, que de más de 50 por lo regular son.
Sí.
All the way down. All the way down. All the way down. Way down.
Los ingleses por ahí con su bandera.
Yo creo que estos son no son ingleses,
¿No son ingleses?
no sé, creo que son
Grab one from the
neozelandeses.
next available person. All the way down. Congratulations. Congratulations. All the way down, guys. All the way down. Congratulations.
Medallas.
Thank you.
Sí, sí.
Thank you. Congratulations.
Con los de China también, mira. Bueno, China es una potencia mundial en cuestión de aeroespacial también.
Sí, ¿no? También los indios, ¿no?
Exacto, sí, los hindúes están también muy fuertes. Y en este tipo de competencias, Alejandra, los hindúes realmente ellos van a ganar sobre todas las cosas porque, bueno, la agencia espacial de la India, cuando tú tienes
Thank you, everyone,
reconocimiento
and
de una competencia como
congratulations
esta,
on an amazing weekend.
tienes mayores oportunidades de trabajo
For those of you that
en la
would like to
industria
head back to
espacial.
the Holiday Inn, I believe the bus is here and waiting for you. Please feel free to go ahead and head on out. For those of you that want to see the park, go for it. Thank you all. Thank you all. You guys.
Bueno,
Chaperones. We have them for the chaperones.
se me
Rock
ocurre
Donald
otro
Chaper. Sorry, I'm so sorry.
Pues bueno, estuvo reñidísima esta competencia. Los proyectos que entregaron los chicos estuvieron fantásticos. Realmente es importante. Es la segunda participación de México en esta competencia de diseño de hábitats y realmente están haciendo un excelente papel. Como decía por ahí Noemí Vivas, ver las diapositivas que diseñaron los chicos y ver su nombre en estas presentaciones ya es un paso de que estamos
Ya todo un logro.
avanzando, ¿no?
Sí,
Exacto, ya estamos
claro.
avanzando. Y pues el tercer año queremos ver a los chicos en una de las compañías ganadoras, esperando que sigamos trabajando. Nos falta más trabajo y yo siento que lo van a conseguir los chicos en el año.
Sí, claro que sí. Esto los va a incentivar también, como a irse preparando con anticipación, ¿no? Y
Sí, en todos los aspectos, incluso en el nivel de inglés.
Sí, y pueden tener la retroalimentación, ¿no? De lo que están viviendo ellos también ya, ¿no? Allá en la competencia. Y el hecho de haber ganado la primera etapa para su pase allá, pues ya es todo un logro, ¿no?
Sí, yo creo que este tipo de competencias, perdón, no solamente van a formar a los científicos, sino también a seres humanos, como le decíamos, más resilientes, más empáticos y con más visión de futuro. Si queremos también que un México mejor, un mundo mejor, necesitamos imaginar que así sea la realidad, que sea diferente la realidad. Y por eso es justo lo que están haciendo estos chicos, en cada plano, en cada modelo, en cada idea, en cada esfuerzo que realizan para poder llegar a este punto, ¿no? Hoy vimos nacer sin duda, Alejandra y todos los que nos están viendo, a la próxima generación de mexicanos líderes en el espacio, y de mí se acuerdan, ¿sí? Exactamente. Y pues bueno, creo que ya vamos a dar por terminada esta transmisión. Muchísimas gracias, Alejandra, de verdad.
No,
Fue
¿de qué?
un gustísimo compartir contigo estas horas, y que estuviste atenta todo el rato también a lo que están haciendo los chicos. Y yo creo que es un llamado para no dejar de apoyarlos, sino al contrario, meterle con todo, porque esto no se acaba aquí, esto solamente es el inicio de lo que viene. ¿Sí?
Claro.
Y van a venir muchísimas más cosas, ¿cómo ves?
Pues padrísimo, y ojalá y podamos estar aquí para ver todo lo que se viene. Sí, muchas gracias a los que estuvieron acá en la transmisión también, que se emocionaron igual que nosotros. Y bueno, pues felicidades a todos, porque ya el hecho de, como les decía, el hecho de haber estado allá, pues ya es todo un logro. Felicidades, papás, felicidades, toda la gente que estuvo detrás de cada uno de los chicos. Gracias, Spaceport, gracias, Katy. Sí, todos los patrocinadores, municipios, ¿no? Que sí apoyaron a los niños. Gracias a todos.
Y pues muchas gracias a todos, muchas gracias, como dice Alejandra, a todos los papás, a todos los municipios que apoyaron. Y que esto es el principio de una generación de chicos que van a seguir adelante, que siguen con hambre de seguir aprendiendo y de llevar el nombre de México a una competencia internacional y de seguir figurando como entre los países que le interesa estar en esta industria. Y pues a nosotros como Spaceport nos interesa mucho el desarrollo de los chicos, el desarrollo de las competencias en los chicos en la industria espacial, y vamos a seguir trabajando para hacerlo posible. Vamos a seguir trabajando todo este año para llevar a la tercera generación de chicos a concursar a la NASA. Y pues a todos muchísimas gracias, a los papás, a todos los que nos han apoyado, y pues ahí seguimos. Muchas gracias, Alejandra.
No, al contrario, un placer. Muchas gracias a ti por la invitación. Y bueno, pues esperemos aquí seguir compartiendo, ¿no? Todos los logros
Claro que sí.
De estos chicos y de los que vienen.
Así es.
Bueno. Cuídense todos.
Adiós, Alejandra. Hasta luego. Buenas tardes.
Bye, bye.
Bye, bye.
Esta es la historia de un grupo de jóvenes que ha roto fronteras, construido puentes y que está poniendo a México y a Perú en el mapa de la industria espacial. El camino inicia con el torneo de diseño de hábitats en el espacio realizado en México y Latinoamérica desde hace 5 años, a través de Spaceport MX. Al concluir el torneo, se seleccionaron a 25 jóvenes destacados en esta competencia, los cuales trabajaron por 3 meses en el diseño de un hábitat espacial en la órbita de Marte. Así surge ARESAM, el hábitat que diseñaron estos 25 jóvenes para obtener un lugar en la final internacional del Space Settlement Design Competition. Más de 1000 estudiantes participaron, solo 19 jóvenes latinoamericanos fueron elegidos, y entre ellos 13 orgullosamente chiapanecos, 3 del Estado de México, 2 jóvenes guanajuatenses y una brillante representante del Perú. Juntos han imaginado ciudades en Marte, estaciones en órbita, hábitats donde la humanidad podrá soñar y vivir más allá de nuestro planeta. Estos jóvenes viajarán al Kennedy Space Center en la NASA para participar en el International Space Settlement Design Competition, la competencia que reúne las mentes jóvenes más brillantes en el diseño espacial. La delegación México-Perú va con el corazón lleno de sueños, con la certeza de que el futuro se construye aquí, ahora, con pasión, disciplina y visión, porque en México y en Perú ya estamos diseñando el futuro de la humanidad en el espacio.